So you got an Amazon on-site coming on in a week. How?
Yeah,
What's the process? Is it just 5 interviews? Did they tell you already?
yeah, it's 5 interviews. Um, it's for the front end position, so I think it would be like 1 or 2 lead code
One or two
rounds.
LeetCode for a front-end interview? So funny.
Yeah, I think so. But yeah, it's kind of random. It could be 0, it could be 2
Yeah,
from
that's what they
what
said.
I heard. That's what I heard from other people. But
Cool.
as I said, it should be one for like algorithms and one for maintainable coding, but it could be also lead code, as I
Nice,
understand.
nice. Cool. All right, we're just gonna get straight into it because I just recently just dropped my new list. One sec. Just need to. B man, audio is fine. Sec. Sometimes the audio tweaks out. Elite, what's up? How's the audio sounding? I just need a couple thumbs up in the chat. All right, all right. I trust y'all.
Ran around.
It's like I'm just dropping. Yeah, thanks for scheduling though. This is gonna be good.
Yeah, thanks to you for the mock interviews. Yeah. So you drop your JP 75 list?
Yeah, I'm
What?
dropping
I
that.
didn't
I'm
look at
dropping
it.
that right now. I'm gonna ask you questions out of it.
Okay. So how do you come up with it?
I
Just
I just looked through. I've done over 650 questions. I just went from the first question I've ever done to the most recent ones, and I just picked off the ones that were the best questions. As best questions, as in I've been asked them. I've had to ask those questions. I've seen people get asked those questions. They're not random questions with weird tricks. They really show off somebody's like skills.
okay.
So I hate those
Um,
questions where there's just a small trick that you just need to figure out, and then it's just 2 lines. You know what I mean? Those
yeah,
ones are
yeah.
the worst. What about you? How many lead code questions have you done, and like what's your like level of skill there?
I done 90 lead code questions, but I was kind of okay during the university, so
Mm-hmm. Okay.
I'm mostly doing like mediums
Okay, I'm gonna
for
send
lead
you
code.
the link to the coder pad.
Okay. How many interviews did you done, by the way?
650. I
No, I
spam
mean interviews.
that I've conducted in my life, or I've done
Yeah, yeah.
Amazon before. I've gotten an offer from Amazon before, and so I know what the process is like. I know how they're gonna ask the interviews. I know what kind of questions they like to ask too. Like I know a few people working there, so I can ask. I'll pick from my list and try to come up with ones that are um, like Amazon-ish, and they care about a lot about just getting that code working. Though I remember for mine, they made me actually run the code,
Oh,
but I think they yeah, I remember it was like on an editor and they made you run the code. Maybe things have changed. That was in 2021.
yeah. I think for
What
now
did they say?
they didn't run the code.
Oh, they didn't
Yeah,
run the code?
yeah. You just
Interesting.
type it in.
Yeah, things
Even for
change.
front end, I done like front UI component for phone screen, and you just code it out and without running, and
Cool.
that's it.
I'm just sending off this list to my friend. Give me a sec.
So how is your first month at Meta?
Honestly, it's been really good. It's the technology stack is really good.
Do you like the team?
Yeah, I like my team. It's probably been like my the best month so far at the company, but lots of initiatives, lots of AI stuff. But yeah, okay, I'm gonna start this video up so we can get right to it. Let me bring up my list too.
Okay.
Hello everyone. So today I have somebody from Eastern Europe, has about 6 years of experience, and we're gonna be working through a coding interview. So could you quickly give a quick introduction on yourself, maybe where you're from, where you're working, how many LeetCode questions you solved, and yeah, quick chat, just introductory chat.
Yeah, okay. I'm from Eastern Europe.
Nice.
I done 90 LeetCode questions, and I'm preparing for my Amazon on-site interview. And, yeah, and I mostly work at mid-sized companies.
Cool. Are you a front end engineer, back end engineer?
Yeah, I'm a front-end engineer and
Okay.
targeting the front-end positions.
Okay. But in your front end roles, do you strictly stick to the front end stack? What exactly do you have to do as a front end engineer, actually? I'm just curious because a lot of the roles here, you kind of have to work across the stack. There's not as
Yeah,
many front end. Yeah, go ahead.
yeah, I'm working across the stack.
Okay.
I don't want to talk about much about my current company, but yeah, I'm doing backend as well.
Cool. All right. Let me just come up with a few questions. Good luck on your Amazon interview. I'm gonna pick from the new Pro to 75 list I just dropped. Are you on the stream, by the way?
No.
Okay. I'm gonna pick a couple questions. Just to, we'll just warm you up. Have you done the two sum question?
Yeah, sure.
Way back in the days? Yeah.
Yeah.
Okay, I got a good question for you. We're just going straight into it. What coding language do you prefer to use?
For LeetCode, I prefer Python,
Cool.
but I think they expect for the front-end engineers they expect to use JavaScript, so maybe I should switch to JavaScript so I can practice more.
All right.
Is it
Sounds
okay?
good. We're gonna work through. Okay, so you want to switch to JavaScript?
Yeah.
Okay, sure. We can work in JavaScript. So I'm gonna post in the first question. So we're given an array of integers representing temperatures. Each temperature is the daily temperature. We want to return an answer array such that each element in that answer array is the number of days you have to wait before you get to a warmer temperature. So you see in the first one, we have to wait 1 day. Here we have to wait 1 day for a warmer temperature. 1 day here because the warmer temperature is the next day. Here we have to wait 4 days because the next warmer temperature is 76. So we need to build that array and return it. So I'll let you go ahead and read that. That's a quick spiel on the question.
Okay. Yeah, let me work to the example. So this is, for this we need only one, right? For this, right, only one also. For this one, we need to check till we find one. So I'm thinking like the brute force approach would be just for every day you pick a number and go through the array until you find a number bigger than your current number. But it would be 2 for loops, and it would be for of and times 2. I
Okay.
mean n square time complexity. So I'm thinking we can like store build up our result array like dynamically. So probably want to allocate the same amount of. I mean, we don't have to allocate all the array at once. So I'm thinking we could also go through the array, but also.
So you think of using a double for loop, which leads to O of n squared solution.
Yeah, but it's probably not the best one. We can come up with something more optimal. Okay. So I'm thinking we can also like sort the array, and it would help us to. But we kind of still need to. Yeah, we care about the ordering, so probably sorting wouldn't be that useful for this problem.
Yep. Like you just said, you want to sort it, but when we sort it, we lose the ordering, and
Yeah.
order is important because these are days. Good insight.
So I'm thinking maybe we can like store the maximum current temperature and so like for this one, for example, for first element we need to find another one that it's bigger.
Exactly.
Okay. Yeah, maybe we can like. So I'm thinking we can like push to the array like 1 as a starter, and if we need to move when we like move our pointer one to the right, we increment all the elements to the left. So, but yeah. So yeah, let me go through the example real quick. Yeah, maybe I change it a bit. Okay.
Okay.
Just to make it a little bit. Maybe like this. Okay, so for the first one, we kind of need to move to the fourth one because it's the first one that is bigger. So I'm thinking we can. I'm thinking we can increment our previous items if it's. But I'm worrying that it still be order of n squared. But let me see. So we start from the first one, and we add 1 for this one. Then we go to the second element. We also add 1 for the second element, and if it's still, yeah, maybe we can keep track of the max element we found so far. So max temperature. It would be for now. It would be. Yeah, but actually, I kind of think about some sort of like prefix sum, but for the maximum. So maybe we can recompute the maximum element for first two elements, first 3 elements. Like if we have an array of maximums, which would store like maximum for first E elements of the array. So would be
So with your brute force solution, right? So for each one, you need to look ahead to find the temperature that's greater.
yeah.
That's the bottleneck, right? How can you find the temperature that's greater faster?
Mm-hmm. So we need to find a greater temperature faster. So you don't like the prefix FAANG? And
How would the prefix sum work? I didn't
yeah, I'm
understand
not
it.
sure yet, but
Okay. It's possible. Like yeah, I'll let you work through it for a bit. So
okay. So if we have like a maximum for first elements, then we can. So let's say we have a second array which with a maximums like prefix max, and yeah, let me work through an example. So for this array, we'll have yeah, it's probably not very useful for this one. So let me make sure, is the temperature need to be like, the bigger temperature has to come after it, after the current day, right? Not, it's gonna be before, right?
yeah, it needs to come. It's like when is the next temperature
Next
that's
day,
hotter?
yeah.
Yeah.
Mhm. Okay.
Okay. Here's one thing. Like, okay, for 73 right here, when is the next hottest day?
It's the first one.
For 73 right here.
Yeah, it would be this one.
When's the next hotter day? Then here.
No, this one.
Well, there's no hotter day than 73 because or here because this we're looking for days in the future that are if the current day is 73, we don't know, right? So that's why the result here is 0.
Yeah, you mean for the last one or for the first one?
Oh, sorry,
Yeah,
last one. My bad.
yeah.
For
Oh,
the
last one, yeah,
73
there's no
is 0, right?
0, yeah.
Okay. What about 76 here? When's the next hottest day?
It's also 0 because there's no.
Okay. What about 72?
It's 76.
Yeah. So try to explore it like that.
Okay. Okay. I think. Yeah, your hint is good. I think we can like store the maximum for which if we go through the in reverse order, we can like store the maximum temperature and the index and which we found it.
The maximum?
Yep.
Okay. Could you just walk it through here and let's just make sure we're get the right result. Like walk back from behind and do a dry run.
Yeah, I'm not sure about the algorithm. Yes. So let's see. So if we store the maximum temperature, and we go from backwards. So we start from. Actually, Yeah, maybe it's would be like a kind some kind of sliding window because yeah. Let me see. So we start from the last one, and if we move our first left pointer one, it would be the maximum in our window would be 76. And if the next element is but we also kind of need to store the number of days somehow. The number of days which will lead to the next warmest, right? So 72, it would be 76, right? And for
Exactly.
69, it would be 76.
Or it'd be
Let's say
72. It's the next
yeah,
hotter day.
yeah, 72, yeah. So it's still be one.
Yeah.
For
So maintaining the max won't work there because 72.
yeah. Okay, let's think about how, our conditions for expanding the window and shrinking the window and see if that's work.
I'll give you a small hint that it's not sliding window.
Oh, okay. Okay. So maybe so if we know the let's say we have like a 73 here, right? And we know the answer for 72. Yeah, it's 1 or whatever. It's any number. That means so to find an answer for 72, hmm. 73, it still be so 72 is more than 72, or 73 is more than 72. So the answer. So how can we speed this up? $76. Yes, I'm not sure yet. Yeah, maybe let's do a more simple example. So
Yeah, that's good. Work through a
yeah,
simple.
maybe like if and it could be like a duplicate, right? It doesn't have to be unique numbers. I'm sure, right? So it could be like 112. So if we start from this one is 0. So let's just do 0. For this one, it could be 0 or it could be 1, right? So it could, if this one is less, is 0, for example, then it for the second element from the right, it also will be 0. But if this element is more or greater, then it will be 1. Okay, that's the basic case. And for the second one, it could be it could be 0. I mean, it still could be 0 if it's like 3. So it could be 0, 1, or 2. So how do we decide which one? Okay, if that number is less than number to the right, then it's 1. If it's equal, then it's the same answer. I mean, not the same, but plus 1. If it's equal, it means that it should be 2. And if it's greater, it could be I mean, if it's greater, it could be also 2 or 0, depending on the first number. So if it's like 3, it would be 2. But if it's 2, it would be 0. So yeah, we kind of still need to go through the numbers on the right. So maybe we can store them somehow like more optimally.
Yeah, let's work through this small solution. Let's say we have 1, 2, 5, right?
Okay.
Okay, we have 5, right?
Yep.
This 5. The result of 5 is 0. Let me put 0 here.
Yep.
When 2 comes, pretend we had some list. When 2 comes, 2 is... Pretend we stored like 5 in the index 0, 2.
You need to store like in a stack or something. Yeah, that makes sense. So when you can access like the next biggest one, right?
Yeah.
Yeah. So let me work through the example. Make sure I understand it. So for when you move your pointer, you add it to the empty stack. Like, okay, so if the stack is not empty, let's say, yeah, we have a 5 here. So we'll get the first value from our stack and see if it's greater than our current value. If it's greater, then that's good. We'll just get this index and subtract it with our current index, so it will be like 2 minus 1, and that's our answer. And if it's not, yeah, then we should we? Yeah, maybe. Yeah, I'm thinking about should we remove from the stack or not? Probably not. Yeah. Yeah, maybe we need to use the like priority queue because. What I'm thinking is, let's say we have like we go through this element and we add it also to the stack, right? It would be like 2 and with index 1.
Yeah.
And when we get to this element, we'll yeah, we got the first one from the stack and we compare it. So yeah, maybe for this example it's quite simple, but if let's say we have a 6 here, what
Oh
will
wait, let me change it like here.
yeah,
Sorry. Imagine instead of the 1 here, we had a 4.
yeah,
So now we have 2 at 1. We have 1 at. Nobel, what's
yeah, 5
up?
3, yeah,
Yeah,
5 3
5.
and
2, update
2
that.
2,
1.
yeah,
1 at 1. Pretend we had a 4, right? Now we just start looking at it. When is the next bigger one? It's not 1. It's not 2. Well, it's 4. Well, it's actually over here, 5. Right?
yeah, but then if we have like one more element and it's like 5, yeah. I'm thinking maybe if there's like some corner case when we delete the numbers and couldn't find it. Yeah.
Here, try exploring like a monotonic stack. If
Stand
you're
stack,
familiar,
yeah.
have you familiar with that?
Yeah, I've heard about it, but it's kind of when you add to the stack also when only when it's a great element, right? So it would be monotonically increasing. So basically, in our monotonic stack, we'll have the like minimum element from the right. Yeah, I'm not sure I fully understand this. For now, let me go through the example. So if let's say we have it would be and for let's say we work through all 4 numbers and now we're at 6, right? So it would be and we remove those 2 because of 4, and we also add 4 here. So it would be like this. And when we find 6, we remove this one, it should be 0. If it's like 2, we find this one, and it would be 1 right away. And if it's like 4, remove this one. Yeah, I think that would work. Yeah, so basically the algorithm would be we keep a like monotonic stack which will add elements only if when we go through the array from the right. So if the stack is empty, we will add element, and we also save index for future. And when we move through the array, we'll compare item with our current value with the stack, top value of the stack. And if it's greater, we'll just add it to the stack and record 0 for this element. And if it's I mean, no. We remove, if it's greater, then we remove one element from the stack and we like continue doing so until our stack is empty or until we found an element that is greater, element in the stack that's greater than our current temperature.
Yeah.
And it's guaranteed to be correct because when we move for the next element, we'll add this element here to the stack. And basically, if we have, it would be like the greatest element in our stack. So
Yeah.
it's
Exactly.
the first one for next elements. And yeah, for the time complexity, it would be. So we go through all the array once, and but we also kind of need to go through the stack some number of times. But each element could be only added to the stack once. So if we remove element, yeah, well, at max we will remove n elements from the stack. So it would be, I think it would be O of n. And for space, space it would be also O of n, because it could be maximum. All elements could be on the stack for the last one. Yep. So how does it sound?
Makes sense. Yeah. Go ahead and implement that.
Yeah. Okay. Let's see. So let's call it minimum. Next, rated temperature. Choose. Okay. So we'll have input array of temperatures. Yeah, let's call it like daily temperatures. Or maybe just temperatures. Okay, let's see. And let's create our answer array. Let's do a stack. And we use array for a stack. So we need to go from through all the elements from the right side. So we'll do temperatures, lengths, and yeah, lengths -1 until I is greater or equal to 0, and we'll decrement I. And yeah, we need to check if the stack is empty. It means the stack length is 0. It means yeah, we also need to allocate the array for answer. Let's do it. Answer. And yeah, this means for our current element, it would be 0. And yeah, we add our current element to the stack. We need to add our current element to the stack. Push temperatures I. So and let's say we can continue. And otherwise, we'll need to go through the stack until we find one. Yeah. Yeah, maybe we don't even need this if statement, but we'll see. So until, yeah, maybe we don't need this one. Yeah. Until the stack is not empty. So until the stack is not empty, and until like we do a while loop was the last element of the stack. Yeah, let's do last element of the stack. It should be stack length -1, and yeah, this one we don't need this anymore. We need to compare the last element of the stack with our current element. So okay, so if we found our last element from the stack, yeah, let's see, is greater than our current element, that means we found our maximum, and we now just yeah, we now just I mean yeah, if the stack is empty, we still need to, yeah, let's add the condition for the stack is empty. Then we'll just add, yeah, maybe we can add like some element. Yeah, okay, let's do this condition. Maybe we can add some like some zero element to the stack, but let's try this one for now. So if the stack is empty, that means for our current temperature would be 0, and we otherwise we'll do.
So can you walk me through? So while the stack length is greater than 0, so
Yeah, maybe I need to finish it. Yeah. So if the stack length is 0, or yeah, this needs to be or, and no, it's not be and the current, wait, yeah, is the stack is not empty, and the temperature, yeah, if our current temperature is more or equal to the last stack element, we need to pop one element from the stack, right? So we do pop, and basically we continue to do this until we found element in the stack that is greater than our current temperature, or until our stack is empty. So after that,
okay, so pretend we had like 1, 2, 3. Our stack is now. So first we put in 3 and 2, right? Let's just like walk through what line by line just to make sure you're getting it right, because I think you're messing
yeah,
up the conditions there. So you start
okay,
here and you start with empty stack and just like walk through it systematically.
yeah, and here it will be like the stack length is 0, so we'll just skip this while loop and go through the through there, and here we check for the empty stack. It will record an answer for 3. It should be 0, right? So then we'll move to the next element, and our stack still empty, but we kind of need to add to the stack here. Yeah. So we need to add this element to the stack before we move on to the next one. So, and here we will check the last element on our stack. No, I mean the top element, right? And if it's greater than our current one, that's good. We found our next greater temperature. So it should be 1 for now. And yeah, we also add this element to the stack. And for 1, we'll also like check the last element from the stack, and yeah, it's greater than our current one, and it should be 1. So I think the condition is not correct, right? So when we I mean, it should work, don't you? Like if our current, if the next element in a stack is less than the current temperature, so we'll pop this element. Yeah. Yes.
Less than.
Let's see.
Pop. Yeah.
Yeah, and
You're close, and we just have a few minutes left because you got to move on to the next person soon.
yeah, okay. So let me finish this one. So if it's stuck, yeah, maybe we need to also. So for the last element, you basically get the last element from the stack, and we'll check the second. It will be our index. And we'll do index minus I plus and index minus 1. Yeah, plus 1. No, I think just without plus 1. And then we'll push new element to the stack. So we'll push this one. And yeah, then we will return our answer.
Yep.
So let me do a dry run, see if that works for this example.
Let's just try running it on these test cases right there and just make sure it works. No need to dry run just because we're out of time. Just run it on the example 1 and let's see if it produces the correct result.
Okay, so do like a console log. Example 1. We didn't add anything to our answer. So for this one, stack length. So the answer is empty for some reason. Okay. Yeah, my bad. I think length.
Yeah, is it length or size?
Stack is not terrible. Wait, what? Temperature.
Oh, it's I minus minus. I minus minus. Why'd you put
It doesn't matter. It's both works both ways. So it's.
I see.
It says like it's not terrible. Yeah, I think because we didn't push here the index. Yeah, we need to push index. Let's try this one, and it would be a 0, 0, 4. Yeah, it's not correct. So for this one, messing up on this one. Yeah, but if we didn't find any elements, I think we don't need. We kind of need to keep the elements in the stack. Yeah, I think. So when we
let me think. Yeah, I think we're out of time. So yeah, let's just park it right here then. But yeah, how do you think you did?
Yeah, that was not the best one. Yeah.
Yeah.
Yeah, I
think
gotta get stuck here at the. I didn't figure out the momentonic stack.
yeah, I think that part is fine. I think for advice there is just when you're working through the question, I mean, work
Yeah.
on looking at from like left to right, but also look at it from right to left as well. Because I think when
Mhm.
you're trying to think about it from how do we go from left to right, a lot of times when you're trying to think of about like you're trying to figure out the future and you have the whole list, you can kind of work from the back because like as you work from right to left, you would have already seen the future and then you could make the decisions better. So so yeah, when you get array, work from left to right, work from right to left. Another thing would just be yeah, just the implementation could have been a lot faster. You understood it, but then you just tripped out a little bit when it came to the implementation. So yeah, I think just working through more questions. You've already only done 90 questions, so I think you're pretty good. Just focus on implementation and not running into these small bugs. How's that sound?
Yeah. I mean, you're very genius.
But yeah,
But yeah, good feedback. Good feedback.
cool.
Yeah.
All right, thank you for
Yeah.
coming out.
Thank you.
Hope you have a good rest of the day. See you.
Yeah. Thank you. Bye.
All right, bye. Okay, Alpha next. Holy, that siren was really hurting my ear. It's crazy. Alpha, I'm in. Alpha. Alpha. Can't hear you. Alpha, what's up? Yo, it's booked like crazy. Not gonna lie. But book tomorrow. There's free available tomorrow.
Hey, can you hear me now?
Alpha, what's good? How you doing? Yeah, I can hear you. Can you hear me?
Yeah. Update something weird, so didn't work. All right, it's fine.
Chat, how's Alpha's voice? Beautiful like always? Let's see.
Let's see. Does this thing work?
Any advice for the last guy?
For me,
Yeah, you were watching?
I didn't really watch it
Okay.
too closely. I mean, it just like kind of slow. Oh, hold on. I think I got it working now. Let me see if I can swap it. All right, can you hear me still?
Yeah, I can hear you. I can hear you. When's Alpha 150 dropping? Chat's asking.
Okay. Now.
That's worse. Wait, let's see.
All right, is that good?
Your other audio is way better, not gonna lie.
Okay. I'll just do that. Okay, is it good now?
Yeah, perfect.
Okay.
All right.
That-
When's Alpha 150 dropping? Or Alpha 69 or whatever?
69 or the Alpha 96, you know, the extended version.
You
Yeah, I
dropping
don't-
that list soon? I would actually be curious to see one of your curated lists.
Yeah, I
done
could
it.
do that. I'll have the rectangle one on there for sure, and then a bunch of
Hell
math,
no.
you know, just to make sure you brush up.
Trolling.
Yeah.
All right.
All right, let me get the. Did you post the?
Yeah, I pasted
thing?
the coder pad.
I
Let's
think I
get into
left.
this because you'll be using Java, and we've already proven.
Can you paste it again?
Yeah.
Alright.
No, I'm just kidding. I'm just trolling the Java.
Dude, I'm so fried from work. Like, yeah. I was
Damn, I
doing
was
on
about to
call
ask
this
you a
week,
hard
and we
question.
merged 2 teams. Don't do it, bro. Don't do it. Can you paste it again? I don't
Yeah.
see it.
Okay, delete the last
Yeah.
guys.
Just give me some meta stuff, you know? Like,
Got you.
what? We can do like 2 if you want.
Well, I was gonna. I wanted to work through this fun question. It's the most optimal data all O1 data structure. I don't know if you've ever worked on that question.
I mean, I
It's
worked
an
on
interesting
most of them,
question.
but I could do it.
Yeah, let's grind it. Just do it in Python, unless you want to do it in Java.
I'll do it in Java. It's fine.
Okay. 'Cause you said you're cooked.
Alright. Yeah, I'm
Alright,
cooked,
I'm gonna
but
start-
it's
I'm gonna
fine. I
start this video.
can't be. It's okay to fail. It's a mock, you know. So,
Yeah. This is when you want to fail.
yeah, exactly.
All right. Okay, I'm gonna start this video. Hello everyone. So today I have Alpha Code again, top 5,000 LeetCode user. They broke the top 3,000. Has solved over 1,500 LeetCode questions. And today I'm gonna challenge him by we're gonna be working on designing the most optimal data structure known to man. It's called all O1 data structure. Pretty much, I'm gonna post it in here, but pretty much all of the operations on this data structure need to perform in O1 runtime. I'm gonna run
Alright.
this here.
Can you paste the Java one?
Oh, shoot.
Alright, yeah, it's gonna be
Java,
rough.
Java,
We'll see
man,
how
Java.
it goes.
And I won't be telling you do this, do that. I learned my
Yeah,
lesson.
sounds good. Alright. Yeah. No, I'm happy to fail. Alright.
I'll let you go ahead and read this. You're a senior candidate, so you should drive this whole conversation.
Bro, I'm mid-level, you know? It's barely. But it's fine. It's fine. Yeah, I gotta change my titles to senior, you know? I heard that gets the views, so. Alright.
All right,
See,
here's it
data
here.
structure. So counts. Okay. So increment, decrement. If the count of the key is 0, remove it. Okay. Return one of the keys. One of the keys, min. Oh man, it's rough. Okay, so I guess the get min, like the no element existing, if there's nothing, like we can kind of figure that out. But yeah, I'm trying to figure out how we could do this like min and max thing.
Wait, so do you understand what the question is asking?
Yeah, I'm gonna read the example.
Okay. Chat, does everyone understand what the question is asking?
I don't know if they read it that fast.
Okay, let's just read over it then. So we're designing a data structure to store the strings count with the ability to return the strings with the minimum and maximum counts. So it's kind of like a hash map kind of thing, and we could increment and decrement a key. So we have like different keys like Alpha, James, right? And we could increment the count. So we can increment 1. We could increment 1 here. Every time you increment, if the key doesn't exist, it inserts it with 1. So we can insert Alpha and James. Then we can increment to 2. Then we can increment to 3. We can call get max key, and it should return the key with the maximal count, which should output James. Or we can do min key, which will return Alpha, right? Pretend we add Paul in here. This is 1. Right?
Mm-hmm.
And then pretend we increment Alpha, it goes to 2. If we call get minimum key, it should output Paul. instead of alpha anymore. And if we increment this to 2, then this to 3, if we see get minimum key, it should output alpha now, not Paul, right? And then pretend we keep incrementing this. We increment Paul like 5. If we call get min key, so essentially we're just storing a hash map with frequencies of the different keys, and we should be able to get the max key and the min key. All of these operations should operate in OV1 time.
Right. Yeah, it makes sense. So the like, so I guess the tricky part here is just these like get mins and maxes, right? So like storing counts for these strings is pretty easy and like incrementing them, but knowing what's the min and what's the max is tricky. And so we might need 2 data structures, just like thinking off the top of my head. One is gonna have, here I can write this. So one will have like a string and its count, and one will have count and like a set of strings or something with this count. So just trying to think if we could handle all the edge cases this way. So essentially, we know the count of a string. So if we need to increment, for example, we would just so 1 would be like increase the count, and then 2 would be like move this up a level in the counts, and same thing for decrement. But how do we ensure that that we always have something available? Like, yeah, so I guess if we move down a level, let's think about this. Yeah, so if we move up a level and the key is bigger, like, so if we move up and this is new level or biggest level or something, we update the max. Might also need to update the min there. And then if we move down a level and delete biggest level, update the max. And then thinking about how we increase the min, so we move up and get rid of smallest, or I guess move down and get rid of we would only have 1 level or something. Yeah, I'd have to think about it, but something like this. So think of me to have both of these things. So what would this look like for this example? Let's walk through it. So, okay, so we have this list first. So we have like hello. So maybe we could say like min 0, max is 0. So we add hello with a count of 1. So that would mean the max gets incremented. And so hello has a count of 1, and now also, yeah, so we could say like hello has a count of 1, and 1 has hello in it. Okay, then we increment hello. So hello goes to 2. So then max would be 2. Min would also be 2 because we moved up. And then now hello has a count of 2, and level 2 has hello in it. Okay. Let's see. So yeah, when we call get max key, we would just get hello, get min key hello, increment. Yeah, so increment would just move it up again, and kind of the same thing. So I think the tricky thing here is just edge cases. But yeah, I think we can try to figure it out as we go along and try to see if we get all the edge cases. So yeah, I'm going to have these 2 data structures where we're going to have a string and its count, and then a count and a set of strings, just so we can quickly add and remove and stuff. And as far as constraints and things like that, so key exists. Okay, yeah, so we don't have to worry about decrementing things that don't exist. Okay, that's cool. And then, yeah, okay. So I think we can start coding it.
Wait, so so a bit.
Uh-huh.
So you're gonna be using two hash maps here? Like, what's the approach?
Yeah. So we're gonna have one map of string to count, and then one map of count to set of strings for that count. And then like two variables like max and min. So max and min.
Okay.
And so when we get the max thing, like we'll have that available. So all we have to do is just pull from the appropriate count. Yeah.
But pretend the max used to be 1, right? And then all of a sudden it says if we decrement something and it's at 1, we remove it from the key. What's the next min after that? Then we have
If
max 1 and
we
max 10.
decrement and we remove it, so we could have a check of like, I guess the simplest thing to do would be, so if we call max and min on empty, should we get like 0? I guess, right?
Max and min on an empty. We could
Yeah.
assume that
There's
like,
always
valid.
items.
There's always items. We could assume that we're the same.
Okay, but yeah.
Well,
so
actually, if no
there's
element exists, return empty string. Yeah.
Yeah, where does it say that?
Line.
Right, yeah. Yeah, so that would mean basically the no element exists would be max and min 0. So we can just check, like whenever we decrement, we can just check. We can also have like another variable called like count items or something. But I think we can also just go off the min and the max. So ideally, if you remove everything, the min and the max should be 0. Like that would be the best way to code it. So min 0, max 0, and then that's how we can check if no element exists.
Or pretend I'm here, right? I do decrement alpha. Decrement, right? Alpha goes to 0 and we remove it here.
Yeah.
How do I know what the next min is?
That's a good point. So yeah, so actually let me think about that. So alpha goes to 0. Okay, so in that case, if things aren't like connected and we can remove them, then this can be like anything, right? Like this can be Paul like 2000 or whatever.
It could, yeah, it could be. Exactly.
Right. And so imagine if we have something like that. Then the problem here is like, what if we just keep adding alpha 1 and then remove and then remove and then remove? We can't like, there's no way to do this like that. So in that case, I think the only way I could see us doing this is a linked list. Because there's no other, so instead of the hash map, we'd have to change it to a linked list. And so the linked list would have a like a count and then a set of strings in it. And then that way, with a linked list, we can have the head and the tail and all that. And so the max will always just be like the top level, and then the min will be the bottom level. And then then our set will be a string to count will be a string to a node that it is in, right? And that's how we have to move it in that case. I'm trying to think. Yeah, so let's say we have this case too. So we have James 10, Paul 5, alpha 1. So if we decrement, like if these are our linked list nodes, so we'd basically have it like this way. 10, like we'd have a node with like 10 James at the top, 5 Paul, 1 alpha. So if we decrement something, like let's say we decrement Paul, we can't move Paul down to 1. So if we decrement, we'd have to have something that's like, if the previous of our list is not like the number below, then we have to make it. So here we'd have to make like 4 Paul, and then like move these connections and have it like this. So I think this is how we'd want to do it then. So we'd have a linked list of levels, and then like every string would just be mapped to like the node that it's in.
So it's gonna look like
does that
this.
make sense?
Alpha. Like if
Exactly.
you look at it's gonna be maybe doubly linked list. Just
Yeah.
for
Yeah.
Paul. Right.
Yeah.
And then,
So like let's say we wanted to move Paul, like let's say we had James at 5, for example, and we wanted to move Paul up. We would check like, does 5 already exist? Yes. So then we would just put Paul in here. We don't have to make a node. And then every time we move something, we have to check like, does our thing have anything left? If it doesn't, let's just get rid of it. So then we would just toss it, and then yeah, basically this way, the max would always just be the end of the list, and the min would be the front of the list. And then if it's an empty list, then you know you have no items.
Okay. So let's just quickly talk about the one case of what if we start removing people? Oh shit, mess it up. So let's do the list of pretend it's Paul.
Mm-hmm.
Pretend we start removing, like, Alpha disappears. How do we get to Paul as the next min?
Oh yeah, so you would just have like a doubly linked list with like a head and tail. That's just like dummy nodes. So tail here. So if I toss Paul, or sorry, if I toss Alpha, then we can just like so the min is always just head next, and the max is always tail previous. And then if head next is tail, then we have empty list, so we just return nothing.
Yeah, so
And it's
seems
always
like a
gonna be
solid
number
approach. You can go ahead and implement that.
Okay, sounds good.
All 01.
Alright, so let's make the node first. So it's gonna have like the. I'm trying to think of, do we even need to have a level? Yeah, we do. Yeah, we definitely do. So level. And then we also need to have the set string like names or whatever this is. What do we want to call this? Keys. Let's see. Sure, keys. All right, so we're gonna increment this guy. So yeah, node. So it'll just have a level. This level, I think it's level. Keys equals hash set. All right. So that's the node. Then we need the linked list, I believe. Actually, let's make another constructor, and this will just be this as well. So this level equals, or actually it doesn't matter. I think we can just do this. Okay. So yeah. So this will just be the empty constructor. So level equals -1, and keys is null. It's fine. Okay. So then the next thing we need to do is we need to make this thing with the linked list. So let's do that first. So class all 01 or something. And so it's gonna have, let's see, node head, node tail, and then what else? The map, right? So map of string to node locations or something. And then the linked list, yeah, I don't think we need anything else. Let's see. So we'll have like, and yeah, I guess you didn't really give me a, like, what needs to go in here, so I'll just make stuff myself, if that's okay, like the function names and all that stuff.
Yeah.
Okay. So all 01, so it'll take nothing. Say this head equals new node. This tail equals new node. Oh yeah, these nodes need to also have a previous and a next. Right. So actually we don't even need that. Well, the upside of Java is you don't need to use this in self everywhere, so that tail previous equals head. Alright, I think that's all we need there. So now let's make these other ones. So inc is a string. Okay, so yeah, so public inc string key, and this does not return anything. Okay, so first we need to check if it exists in locations. So if locations contains key, if it does not, then we are just going to make a new node. Or actually, first what we need to do is we need to get, first what we need to do is we need to actually get it out of where it was. Yeah. Yeah, so we need to get it out of where it was. And if it wasn't anywhere, then we're always just going to put it in the head. I guess we can have two separate things so you can clean up later. So if it doesn't have it here, so if head next, actually want to, yeah, so if head next dot level equals 1, that means this exists. So if it exists, we can just throw it in there. If not, we have to make it. So we can just say head next keys add key. Otherwise, we have to make it. So head, so we have to make a new node. So node, like new node or something. Equals node with a level 1. Okay, and then yeah, and then we have to add it there. So new node keys add key, and then we have to actually like put it where it needs to go. So we can say node after head next. Okay, so we could say after head previous equals new node, head next equals new node, new node previous.
Chat says bro needs to initialize locations.
Oh, that's right. Okay.
Thanks, chat.
I told you I'm cooked today, so I'm probably gonna have like 50 billion mistakes. Okay. New node previous equals previous. New node next equals after head. Okay, so this will take care of the key not being in there at all. Let me make sure I actually add it everywhere. Oh yeah, and then I also need to actually put it in here. So I need to say locations, put key, or I can do that actually. I can do that at the very end. Yeah, there's definitely some cleanup here that can be done. But... Okay. Okay, so this is like an initial thing. So if it's not there, it'll put it in. So let me just double check. Location doesn't contain. If it is in there, just add it in there already. Otherwise, make it then add it in there after previous new node, or after head previous new node, head next new node, new node. Okay, yeah, I think it's fine. All right. So that's the one case. Then we're gonna have the other case, and we can just return here. So the other case is it already exists. So if it already exists, we have to figure out like where it is. So node location equals let's see, locations get key. All right. So if we're incrementing, yeah, this is gonna be kind of similar where we have to get rid of it, and then yeah, so we have to take it out of here, and then we have to move it to the next one. And if this doesn't exist, then we have to delete it as well. So I guess let's do all that. So location, keys, remove or something, key. All right, so we get rid of it there, and then yeah, if head next, or if location next level equals location level plus 1, then that means it already exists, so we just have to put it in there. So then we can just do that. And then otherwise, yeah, so let's do that first. So location, next, keys, add key. And yeah, otherwise, we have to create it. So we can say node, new node, location, level +1, new node, keys, add key, and then we have to like move the pointers. So why is it screwed up? No idea. Okay. Maybe this is some like special thing. Yeah, I don't know what's this color. Weird.
Where?
Okay. On 166, why it's green.
Okay.
Maybe keys is some, I don't know. Okay, so we'll just move on and see what errors we get. So yeah, so we add it here. And then what we need to do is we need to, let's see, we need to actually put this in there, but we can do that later. Oh yeah, we need to have the pointers, right? Okay, so node after location next, and then after location previous equals new node, location next equals new node previous equals location, new node next equals after location. All right. Yeah, so now the last part is we have to check if this new node needs to be deleted, and that's pretty much it. So if location keys is empty, let's see, is empty? I think that worked. Oh, it's this. Okay, so if this is empty, then we need to do this thing. So node. Oh, I guess we just need to do, yes, a node before location. Or equals location previous. Node after location next. Before next equals after previous equals before. All right, so that took care of that. Then what we need to do is we also needed to actually put this in the locations, I think. So I don't think I ever did that. So let's do that. So let's see, location. Yeah, let me read this one more time. So location remove. Okay, so location. Or actually, sorry. This is going to be. Let's see, node location equals. Oh yeah. So it's going to be locations. I think. Yeah. Locations. Put key. Location next. Yeah, definitely I'm starting to see that I should have made helper functions here to do some stuff, because there's like some repetition and it's kind of hard to follow everything. Okay, so we'll just say that's right and we'll debug later.
Sounds good.
So then the decrement, yeah, the get max and the get min is going to be super quick. So, okay, so same thing, public void dec string key. Okay, so at least here we know it's valid for sure, so we don't have to worry about like, are we putting something in or whatever. So what we have to do here is kind of similar, is we have to take it out of a node and move it down to the node before that node. But that node also might not exist. And so if it doesn't exist, then we have to make it. So we can kind of say, let's see. So we know it exists for sure, so node location equals locations get key. Yeah. All right, and then so if location previous level does not equal location level -1, we have to make the new node. So we have to do the same thing.
Wait,
So
let's quickly
node.
just walk the chat through increment. You just walk
Okay.
us through increment and let's just make sure everything's working correctly there.
Yeah. So basically, like, there's two cases. The node can either already be in here or not, right? So if the node isn't in here, then we have to put it at like level 1, like count 1. And so if there is already a level 1, which is going to be always the one right after the head, then we just put it in there. Otherwise, we have to actually make it. So you can imagine, like, we have the head, we have the tail. If we don't have a level 1, like, we have to make it. If not, if it is, then we put it in there. So this is basically, this else is me making it. And then I just put the key in that level. If it's there, then we have to figure out, like, where is it actually located. So if we have, like, the head and the tail, and, you know, we have some counts of like 1, 5, 10. Let's say it's in 10. So we get it. We remove it from 10. And then we have to check, like, to increment, we have to check if the next level exists. So there's two cases here as well. So like 10, 11 might exist, it might not. So if it does exist, we can just put it in. But if not, we have to actually make this node. And then we have to make the connections. So like 10 has to point to 11, 11 has to point to 10, and all that stuff. And then we put the node in 11. So those are basically like the two cases we have. Is like, we either put it in 1 because it didn't exist, or we have to move it up a level. And we have to check, does that level actually exist? And if it does, then we have to put it in there. If not, we have to like make a new node, and then we just update our map to that correct place.
Okay.
Yeah, I'm definitely thinking there's ways to like find some common, kind of like LRU cache and some other stuff. There's ways to find some common functionality and like extract it out into helpers, and then the code would be a lot cleaner. So maybe if we get everything working, we can.
Yeah.
Okay.
Yeah.
Okay. So the decrement. Now there's only one case. So we have this like head, we have this tail. We have some levels like 1, 5, 10. We know for sure it exists somewhere in here. So what I'm basically doing is I'm just saying, okay, find where it exists. Does the previous level to that exist? So let's say it's in the 5. Does 4 exist? If 4 doesn't exist, we're going to make a 4. And then we're going to move it down to the next level. And then we also have to check from the level we removed it, like, is that empty now? If it is, then we have to get rid of that. So it's like two parts. We have to check if the level before exists. If yes, make it. Or if no, make it. And then we also have to check, is our current level empty afterwards? If yes, remove it. And then just update everything. And then, yeah. And then, yeah, the get max and get min are just going to be like head next level, tail previous level, and that's it.
Yep.
So,
yep. Makes sense. Yeah.
Okay.
Those will be the easy one.
Yeah. Okay. So basically, yeah. So if this doesn't exist, we have to make this.
Why not just decrement the value
Why not
of the
just...
node?
Because it might have more stuff.
Oh, you're right.
Yeah. So we could decrement, but if it has more stuff, then we can't. And then we could like add another if, but then we just have like a bunch of nested ifs and stuff. So
yeah, might as well generalize the solution.
Yeah, and then I think the next step, if we get everything working, is to figure out common functionality, extract it out into helpers, and make it a lot cleaner. Because right now it's kind of hard to follow like what's going on. Okay, so yeah, so this is going to be a new node, location level -1. So this is the node we're putting it in. And by the way, so we can always remove it from here. So we can always say location, keys, remove, same thing, key, because we know it's in here for sure. Okay, so make this previous node, and then we just have to move the pointers. So, or new node, I guess. So we do the same thing. So node previous node equals location previous. Oh, not location. It's oh yeah, it is location. Okay, so then we just do the pointer stuff. So new node previous. Actually, let me think about that. Yeah, new node previous equals previous node. Previous node next equals new node. New node next equals location. Location previous equals new node. Okay, so we made this thing, and then yeah, So now we know it's in there for sure. So now we have to put it in there. So we can say location previous keys add key. Now we have to check if the location is actually empty. So if the location keys is empty, then we have to get rid of this guy. So we have to kind of do the same stuff. I guess maybe we can copy some of this. So new node, location previous, node, next node, location next. Okay, so then previous node, next equals next node, and next node previous equals previous node. This guy. All right. Okay, so I think that's it. Yeah, then we just got to do the other stuff. So public int, like get max key. So if, let's see. Yeah. Okay, so if head.next, and I think this will compare for the actual object, which is fine. So this is just nothing then. Otherwise we return. So, or actually not an int string. So we have a set. Yeah, we have a set, and the problem, or let's see, this method must turn. Yeah. Okay, so the problem with the set, or yeah, is like we need to get one item, but we need to. There's no way to access, or at least I don't know off the top of my head, how to access an item in a set. I think you have to use like an iterator to just get a random item. So yeah, maybe I could use the AI thing for that. How to get like a random item with a set without looping
Yeah.
through the whole thing.
Yeah,
I think there's like an iterator
even
way to do
related
it.
to the set too. It's just like
Okay.
we could assume
So
that there's not that many even. Like it's amortized O1 almost, right? Because like what are the
Yeah.
chances that all of them are gonna be at the same value and they just keep spamming?
Yeah, let me look up
But
get value from set with iterator.
or like one small thing is maybe just instead of having a set there, just have a list.
You could do that, but then the downside there is if you do have a lot, removing takes a while, right? So there's
Yeah, yeah.
yeah.
Oh crap! Like
Okay,
I
so
think
it
the
looks like,
optimal is this is like you store you have a link list inside of that you like do the
oh, I
link
see.
hash.
No, I think this is fine. I think this will work. So this will be head next keys, and then you just return iterator next, I think.
What's the runtime of this? Just curious.
So I think iterator is, I want to say O1, just making an iterator, and then next is yeah, I want to say it's O1, but I could be wrong. I was gonna say the other thing you could do is you could do a for loop. Yeah, you could do a for loop, and then basically just like return right away. I think that's also O1 technically. Ian, does that make sense? Like loop through the items, but just return at the first one.
Yeah.
Yeah, so I
Think
think,
it's
I
fine.
mean, yeah, I have to double check, but yeah. So then, so this is actually a min key, by the way, not max. So now we just
Fun
need
question.
the same thing the other way.
Grab some water.
Yeah.
One sec.
Okay, so max, so tail, previous, tail, previous. Okay. All right. So I am curious if we have like errors, but let's try to maybe run it on something.
Run out some
So
very basic test cases.
yeah. Okay, so let's do it here. So let's see. All O1 tests all one. Alright, so let's just maybe try these and see what happens. So let's try to put this in here. I mean, there's definitely going to be like some syntax or whatever. Let's see. Okay, so let's just try to do these things, I guess. All one. Okay, so all one ink, hello. All one ink, hello. So we need to just print these. All right. Get straight only. All right, let's. Yeah, there's definitely gonna be errors for sure. What?
Impossible.
No way. I mean, I feel like if you run this on like an actual LeetCode thing, there's gonna be errors for sure. This thing happened to run somehow. Maybe we didn't do like that much
Okay,
complicated
what's your
stuff
test
in
goes?
this.
Increment hello hello. Increment leet.
Hmm.
Let me make one. James.
Yeah, let's do some more.
Let me test this thing. James. You put hello. Okay, what should this do, James? What should this do?
Yes.
Min key hello.
Hello. Yeah.
Okay, then we're gonna bring in hello here, and then we're gonna bring in Paul. Okay, now, or sorry, we're gonna switch these around. We're gonna bring in Paul. We're gonna bring in Paul, and then we're gonna bring in hello. Okay, what should get max key be?
So it should still be James, and then min should be Paul. Yeah, and I think some other stuff we could do is try to like get rid of that min key, like you were saying.
James.
Is that right?
Hello, James, Paul. Okay, now decrement. Let's decrement Paul.
Yeah, I think that makes sense. Yeah.
And then what should be the min key?
Hello, right? I'm like honestly shocked that nothing crashed so far. Okay, there we
It
go.
crashed.
Okay, yeah. I was gonna.
It's going far,
I
though,
mean, I
going
had
far.
to. Okay, so. Alright, so maybe we need some logs. So if we decrement Paul, yeah, I guess we probably need like logs. So let's just print like all of one head next. So this should be the one, and then this should be like keys. So let's start with that.
Or
see, like,
I think the exception is pretty clear-ish.
Iterator next. Let's see. No such element. So I'm guessing maybe the iterator is like empty.
Which line? 130.
135.
213.
Let's see. Oh, actually, sorry, no, not that one. Solution, get min key. Yeah, so get min key. 213, right here. Head next keys iterator. Which is weird because that's why I wanna print it. Like we could see pretty easily if there's something even here. So we can just do this and then try it again. Okay, so it's empty. Interesting. So it looks like the decrement Paul, somehow this thing is empty, which I didn't think can happen, but let's maybe walk through it. Let's also, before decrementing Paul, let's print it as well. Just to make sure, like, it's fine, and it's what we expect. Okay, so Paul is in there. We decrement it, and then for some reason, there's like an empty thing. Okay. So let's think about it. So locations get key, location keys remove. Did we ever add it somewhere? Yeah. Oh, wait. I see. So we decrement, but the problem is like we add it, but I see what's going on. Yeah. So if we decrement, and the count is 0, we shouldn't like add it anywhere. We should just like not have it, right? So, yeah. So let's think about what would happen here. So locations get key, locations move key. If location's previous level is not... Okay, so what we need to do is we need to... I guess let's think about what the easiest thing to do here. So we don't need to make this new node if... Yeah, we don't need to make this new node if the count is... if the location is 1. If the location's 1, we're basically done.
Mm-hmm.
Or at least, yeah. We might need to remove it. So we could say, like, if location level does not equal 1, then we need to do this, like, get and add and all that. Otherwise, like, we don't need to add it anywhere. But we might still have to remove it, right? So let's try it this way and see what we get. Okay, there we go. So I think it's working. Let me just... Yeah, so that was the bug we had, is when we removed something with a count of 1, it went to 0, and then I think we put it like in the... Or we just basically put it in the wrong spot. It should just go away.
Mm.
So... Okay, I think it's good now.
Nice. Okay. How was that? How do you think you did?
Yeah, so I think... Didn't see the case with, like, the removing, like, I thought you'd always jump from level to level. I didn't realize, like, I didn't think of the case where you were saying, you know, where you have, like, 5,000 and then 1, and then it just, like, jumps to 5,000. There's no way to handle that without, like, a linked list, so I didn't realize that, so I was kind of using the wrong data structure there. And then some small bugs, but I also feel like for this kind of problem, like, it's expected to have bugs in the code, like, because there's just like, a lot. And then, yeah, I was thinking, like, I could definitely make some, like, probably could have structured this a little bit better. Like, I think if you make helpers, then it makes it easy to see, like, what each one does, and then it's less likely you make mistakes. But pretty happy that was the only mistake I made for, like, this complexity of a problem in Java. And yeah, I'm literally, like, cooked from work, so yeah.
No, it's really good. Honestly, good job. Like, you noticed the first solution is a valid solution that you thought of.
With the double hash map thing?
Or no, like it's a way that, like, it made sense why you thought of it, but then of course there's that edge case. Yeah, this question is I like this question. It's like the LRU cache on steroids. I don't know if this is actually one that should be asked in interview, but
I feel like it's reasonable, like, especially if it's a 1. Like, if it's like a meta 15-minute, no, but if it's like a... Like, I think for, like, Google or some ones that ask tougher questions but ask 1, I think it's pretty reasonable. You know, if you have, like, 45 minutes, like, I don't know how long it took me to do this one, but yeah, if you have 45 minutes or something, I think it's pretty reasonable to ask.
All right.
And then, yeah, cool. for the meta ones, I think you would just ask simpler.
Yeah. Thanks, Alpha. Good job on it again. Yeah, if there's more slots, maybe I'll hit you up later.
Yeah, I'll probably maybe book another system designer tomorrow or something. I gotta recover from my work.
Yeah, go rest up, man. How's San Diego right now? It's good?
It's super
the weather's
hot,
good?
So
super hot?
Not the best.
Chilling?
Super hot, yeah.
I see. Chat, how do you think you did? Any feedback?
Yeah,
Any
you
praises?
can check the iterator. You can check the iterator thing, but if I made this correctly, it would never not have next. Like, I know you could do that, but in this case, it would never have that problem.
All right,
but yeah, that's another way to do it. Instead of checking the tail and head and all that, you can just do iterator has next as well. Yeah, makes sense. Yeah, I mean, pretty washed. I didn't think of that. Yeah. So.
Let's see, what is everyone saying? Yeah, no.
All right.
They're like pretty happy that you got to the linked list solution like instantly after the edge case that I brought up. You automatically like linked list, which is good.
Yeah. All right. I'm gonna hop out. So.
Peace. Yo. Hold on.
Yo, what's up, bro?
Just make sure the audio is good. I'm gonna get you on the screen.
Alright.
All right.
Hear me okay?
Yo, chat. I got the YC founder back into the thing.
Oh my god.
You hungover?
Not anymore, bro. It's been a few
You had
hours,
anything to
so I'm
drink?
chilling. Huh?
How much you drink?
Dude, after you left, we went to this like post game, and then I had like 2 drinks. It was honestly, yeah, dude, I know, bro. I was like, what? This is crazy. I'm such a lightweight, bro.
Well, I mean, like that's so funny. You just kept
Dude, turn
going.
your camera on, bro. Or can I? Am I not allowed to? Or you can? Can you not do that?
You want to see me that bad?
Of course, bro. Otherwise, I'm looking at the fucking the fist, bro. Wait, I forgot. Can I swear or no? Should I not swear?
Try to limit it.
Okay.
I'm just kidding. Like you could swear if you want.
Okay.
All right, I'm gonna send you the link. Hold up, your black background is tweaking out on your black shirt. Maybe switch out your shirt real quick.
All right.
Yo, chat. So this is my YC founder friend. He's gonna hop on a coding interview. It's gonna be fun.
I'm gonna get cooked, bro. Dude, give me a LeetCode easy, bro. Actually, yeah. Yeah, either give me a
Pick it from
LeetCode.
my Peralta 75 list, bro.
You got Peralta 75, bro?
Yeah, I dropped the Peralta 75 list.
Damn, dude.
This is perfect.
So you want me to like pick one from the Peralta
No,
75?
I'm gonna choose the list, but we're gonna do a
okay.
quick intro. All right, chat. Everything's good. Okay, I'm gonna start up. There's gonna be a separate video.
Is it better? Like
Yeah, it's good.
All right, cool.
So you got a V-neck on, or your shirt's just sagging?
No, I have a V-neck, bro.
Okay.
Dude, I don't have that many shirts right now, bro.
Looks fresh though. Looks fresh.
All right, cool. Thanks, bro.
All right. Okay, 3, 2, 1. Start this up. Hey everyone. So today I have Camille here, who is a YC founder. He was batch 2022, or which batch were you in?
Winter 23.
Winter 2023. So not that long ago. So he was a founder. He was Nvidia. He worked at Nvidia doing deep research. He's more on like the machine learning kind of stuff. Obviously, he's knows how to LeetCode, but he said he's rusty. Yeah, I have a different video with him when he was talking about how he raised YC, or how he got into YC, how they wired him just 500 grand straight to the bank. It's a pretty interesting story. But yeah, Camille, you want to quickly introduce yourself real quick after my little intro?
Yeah, I mean, you kind of already gave the spiel, so I don't think there's much for me to add. But
All right.
I can add
How many
one.
LeetCode questions have you solved in your life?
I trolled on your form, but I think it's actually probably like a couple hundred. It's probably like 300 around there, 200, 300.
Yeah. Were you grinding at one point LeetCode questions, or not? You didn't really go through that phase.
When I was, yeah, I mean, yeah, of course I did, bro. Like, I think everyone does, right? Well, I guess maybe not everyone. I was one of the people that had to grind it out, though, for sure.
Yeah, you didn't. It didn't just click for you, or did it click for you easy?
I mean, I think once I kind of started studying properly, it made sense to me. But I had to like focus on different things and then like grind that out.
Yeah. What do you mean studying properly? How were you doing it before? Like, how was your
Um,
LeetCode journey? You just started doing random ass questions, and then
I think at first I started doing like random questions that were harder than what I could do. I didn't understand that there were like different patterns to the questions. But then once I started understanding that there were patterns to the questions, kind of like in school, like with math, basically, you could pretty much just like study only those problems. And then,
your camera
like,
tweaked out.
yeah. Sorry. I'm getting my, I think my computer's low on battery. All right, it's better now, right? You see me?
Yeah. So once you start understanding all the different patterns, then it started clicking for you more.
Yeah. Once I realized there were patterns, then I started only studying the specific pattern. I would do the easy problems first, then work my way up the difficulty, and then as far as the difficulty that I needed to go, and then I would just repeat, basically. That's how I studied. And then obviously, like, you know the problems, like the like they have tag problems like on the code, right? So you solve those ones.
Yeah.
Yeah.
All right. Okay, sick. So when you say you go problem by problem, you'd be like, okay, let me work on Dijkstra's and just do basic ones and then going into harder Dijkstra's? Or were you going, okay, let me look at stat questions and go.
It was kind of like that. I mean, like one thing I didn't understand was like backtracking. Like backtracking just didn't make sense to me. And so I like tried watching a couple at some point I like tried watching a couple of videos. Then I solved like the easiest problems, like the ones with the highest solve rate on LeetCode for backtracking. And then once that started making sense and I did more and more and more, and then it was like, okay, now that I've done like 5 or 10 of these, it's all kind of the same. And I know how to recognize it. Now that's like a pattern that I understand and I can
I
kind of
see.
do. Yeah.
Okay, sick. Really good feedback. Let's get straight into the questions then. I'm gonna, in this chat here, I'm gonna send you a link to the coder pad. What programming language do you like to use for these coding interviews?
Python, bro.
Python, let's get it.
All right.
Python is the best you'd recommend?
I mean, Python's just like the fastest, bro. Like Java, I used to use Java and it's like so verbose.
Yeah.
You don't need that.
Yeah. Okay, one question, because I know you're on the other side of these panels, like interviewing people. What are common mistakes people make, and like how could people just handle these interviews and make sure they get the job?
I think people move too slow and they don't, and sometimes that's even worse if you don't use like a language like Python. Like if you use Java, I feel like I don't think I've passed a single person with maybe one, but like most people that use Java just get like kind of cooked because like you just can't like code as fast, right? And if other people can code in Python, then they're gonna kind of set the bar, I think, around that most likely.
Yeah,
That's
because
my take on
we're
it.
gauging people, like we barely don't even care about what language. We just care about how fast did they solve it, how optimal, and like the language
Yeah.
is just a language. So
Yeah,
it's not
but the language.
like we're, yeah. Go ahead.
No, go ahead. Go ahead.
No, what were you saying? But the language, what?
But the language makes a difference, right? Like that's like the highest leverage thing you can change to go faster, realistically.
Yeah. Honestly, too, yeah. Even when you're working on like technical projects, if you're using PHP or like some language and it's slowing you down, like the answer is not always just move faster. Maybe you need to rewrite it in some language or some framework that's gonna allow you to move 10x faster. Right. Cool. So I'm pretty sure you're familiar with CoderPad. It's an interactive text editor. You can run the code as much times as you'd like. I'm gonna post in the first question, and we're try to solve 1 to 2 questions depending on your speed.
Damn, we're going full circle
Start
right
with a
now, man.
softball. We'll do a softball question.
Okay.
Quick. Full circle. Why?
Nah, because you were giving me feedback on the interview the first time, bro.
Yeah. How we met was that I had to watch him do interviews and provide feedback on how he was doing the interviews. That's how we met, but then we just see each other in the office. Okay. So I'll let you read the question, explain to the chat like what the question is actually asking so that they have a good understanding as well.
Okay. Can they not see my screen or your screen or anything?
They can see your screen, okay. But like some people might not be able to understand what the question is actually asking. The same way you would. Yeah.
Okay. Similar to a binary tree with unique values of 2 different nodes, return true if the nodes corresponding to x and y are cousins, or false otherwise. They're cousins if they have the same depth with different parents. The root is at depth 0, and children of each depth k node are at depth k plus 1. So if you have, so does that mean that if you have like 0, or let's say like you have 1, and then you have 2, and then you have like 3. Oh man, tree problems are kind of annoying because of this. So you have like 1, 2, 3.
We have a drawing board right here.
I have a drawing board.
Hop in the drawing board.
Oh shit. Okay. Okay, so you have, oh wait, yeah, let's just do this. Okay, wait, so you have 1, 2, 2, 3, 4, 5. So this is like this. So then this would be depth 0, 1, and 2, right?
Yeah.
Okay. And so then, hold on. So they're cousins if they say, okay, so 4 and 5 would be cousins, right? And 2 and 3 wait, different parents. So 4 and 5 would be cousins, 2 and 3 would not be cousins. They would be siblings, basically, right?
I think that still counts as cousins. Wait, cousins? Two nodes
It's
of a
different
binary tree are
parents.
cousins if they have the same depth with different parents. Yeah.
Yeah, so 2 and 3 would not be cousins, but 4 and 5 would be cousins, pretty much, right?
Yeah.
Okay. Let me think. Okay. I think this is fine. I'm assuming so there's only one binary tree, right? It's not like a disconnected graph. It's gonna be
Yep.
connected. Okay.
Valid binary tree.
Yeah. Okay. And so that means there will be at least one node, right? In the tree.
It could. Yeah. Okay, we'll assume a couple things. We'll assume that the input is correct, as in we're gonna give you a valid binary tree, and we're gonna give you 2 nodes that are actually in this tree.
Okay. 2 nodes that are in the tree. Return true if they are cousins or false otherwise. Oh, so you're given the nodes of the. Oh wait. Oh, so they have unique values and the values of 2 different nodes of x and y. Okay.
We're gonna be
Okay.
given reference to the node.
You're given a reference to the node, not the. Okay. You're given a reference to the node. Do you want me to make my own tree class in that case
Yes.
too?
Yeah.
Okay. All right. I'll just do that real quick. I think it's. You
So
do
my
like,
brother is just saying you need to teach him how to get into YC, but we can talk about that after. 'cause he's
Yeah. I got you. Yeah, you guys should apply together, man.
I don't know. We don't get along.
Oh, damn, bro.
I'm saying.
Wait. Oh, no, you do it like this. Wait. You can do it with data class, I think, right? Nah, probably not. Whatever. I'll just do it the basic way. Let's do def init self value left right. Let's just do okay. Self dot value equals value. Self dot left equals left, and self dot right equals right. All right. Pretty sure that's the way you construct it. And then the function is the root. Okay, so the function is cousin. And so you have the root, which is a tree node. You have x and you have y. And x and y are giving me tree nodes for those two, right? Not ints. James.
With the tree nodes.
Yeah, you're passing in tree nodes for everything, right? Not
Yes,
integers.
we're
Okay.
passing in. Wait, let me see. Let me just verify.
It says the values are 2 different nodes. That's why I'm asking.
Okay, yeah, we're passing in integers. It's values.
All right.
But we could also assume that each node has a unique value.
Yeah, that's why I'm like, okay, cool. Okay. So, okay. All right, now we have to think of the logic. So, I mean, one approach is you could just construct the tree and then like you could construct the tree as like a flat structure, pretty much like a list of lists. And then you could just go through the list. Since we have like, I guess it'd be a list of sets. You can make it like a list of sets and then just like go through once you've constructed like the flattened out tree. If x and y, like the values are both in that in like the same level pretty much. And if they are, then it's true. So that would be like one way. It's not optimal probably because you're using space, but that's like one option. It'd be like linear time, linear space.
Wait, could you repeat that? Sorry, I didn't get that.
So you could make like, you could go through the tree, like you
Yeah.
could traverse the tree and do a level order traversal so that you end up with a list of sets, basically, where like the list, so it'd basically be like, so in the example that I gave you, I think where it was like 1, 2, 3, 4, 5. So you'd have like the result would be like a list of sets where it's 1, and then 2, 3, and then 4, 5. And then you just check if X and Y are both in the same level, and then false otherwise, basically.
But
Yeah,
if they're in
so
the
that's-
same level,
Yeah. So like if you get passed in X and Y, so then you would just like if X is 1, or if X is 1 and Y is 3, then it'd be false because 1 is in like this set, but 3 is in this set. So they're not on the same level.
yeah.
So
But
that's
if
kind
you're passing 2 or 3, that's false still, right? In our case,
No. What do you mean? If
They're-
X and Y are both
they're not cousins. They're siblings, right?
Oh,
That's
yeah, I forgot
incest.
about that. Oh, yeah, true. Oh, yeah, that's actually true. I forgot about that. Never mind. Okay, wait. So you can't just do that, I think. Yeah, so I guess you probably have to do it while you're doing the traversal then. I think you probably could also just do, well, okay, I'm trying to think. One thing that's coming to my mind is you could do 2 separate traversals to find each one. And then you find that node and its parent and its level. And so if you have the level and the parent, if they're not the same, then you're good basically. And if the level is the same, then you're good. But I think you could probably do that in 1 pass instead of 2.
Okay.
So let me think. Yeah, recursion's kind of like annoying. How would you do it? I think you could do. I think you'd probably have to like return the result upward. I think that's what you'd have to do. So you'd have to like find the node. Like when you find the node, you just return that like. Oh wait, is it possible for the nodes to not be in the tree? I forgot to ask that. Is it possible for the values to not be in the tree at all?
They're gonna be in the tree.
They're gonna be in the tree, okay. Yeah, so you can just return like the level of one of them and then like its parent value. And then you could do that for both. And then once you get up to a point where like they're this like where both values are there. No, but I don't think that works because then you still have to return a Boolean.
Like I already like your first what you initially mentioned. You're like, we just need to know for each the X and Y what the level is and who their parent is, and this is simple comparison after that, right? Like, are they in the same level? Are they
Like you're fine
the
with
same
that.
parent?
I don't think that's optimal, right?
Why is it not optimal?
I mean, I'm assuming you can do it in 1 pass, right? Instead of 2.
What would be the okay? What would be the second pass have to be?
I mean, I was just saying like you literally call the same function twice. You have a function that just finds the node and its parent, or like you find the node, its level, and its parent, and then you call that function twice, and then you compare it. That's it. That was my suggestion originally. It's linear still, but it's like it's 2 passes instead of 1. I'm assuming you can do it in 1 pass, right?
I think
It's
you gotta-
fine.
Yeah, it's fine. Let's just implement it and just see.
All right. All All right, so let's just do find.
Like when do we ever dock for 2 passes? I don't usually do that.
I guess, yeah. Let me see. Let's just do that. Find node or find level and parent, and then I think it'd be root node x, and then I think you could just do find the level and parent x, root y, level x level parent one, x level x parent, and then y level y parent, and then it would be if x level equals y level and x parent not equals y parent. Actually, you just do that. And then find level and parent. I don't know why it's tweaking. Non-designable. Okay, that's why. All right, if not root return 0. It'd be return -1. -1 and oh yeah, and -1 and -1. Or I guess like, is this valid? Wait, it's integer. It's unique values. Can we just assume they're greater than 0, or should I just return none or something? I can just return none. Yeah, let's just do none. X level and y level and x parent.
Well, we're assuming that it's in there, right? X and Y are in there.
Yeah. I'll just do this for like to make sure that the that it's not like infinite. And x parent is not none. I can clean it up later. I think that's fine. All right, whatever. I can just fix it later. And then find level. All right, if dot. Wait. Oh, you need to pass. Wait, you need to pass the. Oh no, I don't think you do. If root dot val equals x. Oh, I think you need to pass the parent down to probably. Yeah, I think you need to pass the parent down. Parent. All right, whatever. If root dot val equals x, then return root dot value is x. Return parent be parent, and then the level would be, oh, I guess, wait, how do you do this? I think when you go down, oh yeah, you just, I think you return 0 and then parent, yeah, something like that. Else return 1 plus return, how do you do this one? I think, yeah, it's like you return 1 plus find level and parent. Yeah, I think you would just do, yeah, okay, left. Yeah, it'd be left level, left parent, right level, right parent. Yeah, something like that. Root dot left x root. We do the same thing here. Root dot right x root, and then if left level and left parent, return 1 plus left level, left parent. you can do that. That should be good. Let me see. I'll just ignore this for now. It's kind of a pain. All right. Let me just test this. Yeah, I think in my example I had this. I had like 1, 2, 3, 4, 5. All right. Tree node. All right. Root node. Depth 0 equals tree node 1. Yeah. Depth 1, 1, 2 equals tree node 2. 3, 4, 5. All right. And then I think we can do depth 0 dot left equals depth 1, 1 dot right equals depth 1, 2. Depth 1, 1 dot left equals depth 2, 1. And then depth 1, 2, depth 2. All right. And then we can do is cousin depth 0, 2, 3. That should be true. And then is, oh no, wait, depth should be false. And then this should be, that should be, no, wait. Yeah. And that should be false. This should be, wait, wait, 2, 3 should be false. 4, 5 should be true. Yeah. Okay. And then we can just see that first. Wait, how do you run the code? All right.
Command enter.
Okay, command enter. Okay. So his cousin, the first one, find level and parent. All right.
Wait, can you walk me through this code right here? This find level and parent?
Yeah. Let me just put some print statements, I think. So, all right, so we would do the first 1, 2, 3, go in there, and then find level and parent. So this is called with X. So that's 2, we go in, root exists, root dot value is not X. So you go left, and then you find, all right, the next one, not root. So this would be none, or not root. So root exists, root dot value is X. So you return that. And then you go down, next one. So then right, so then you go to 3. That's root exists, then root dot value is not X. So then you try going left, and then you're gonna get root exists, root dot value is not the value. So then you go left again. So then you're gonna return none. And then I think you're back at 2. So then you're gonna turn none again. And then you'll do the 1 plus none. Yeah, so that's cooked pretty much. Oh yeah. Oh yeah, let's just do this again. If right level and right parent. I think let's try that again. Okay. Let's try that. False. Okay, that's cooked. Let's just check what we're getting. Let's try this first. None. Okay, so they're all none, so it's not ever being found. If left level and left parent. Let's see. We go back up because eventually it gets found. So eventually this would get found. Is it ever getting found? And root. I think it is. Yeah, it is. Okay, so it's getting found. They're both getting found. Okay. So then the issue would be.
I mean, one way I like, instead of doing the recursion going up, just like let's just solve it with like just having a outside variable right here for now, because I think the issue is like when you find the root value, because this one, like how is it returning up here, or is it or I would just, okay, you're already printing it here. It's not returning it properly here in the print x of a y.
Yeah. It's not. Yeah, it's like none.
Yeah, it's none.
Yeah.
So like you're having issues with how you're returning here. So let's look at this condition. If left level and left parent, that means, what does this mean? That means, do we found it?
I think that might be it. Let's try that. Yeah, there you go. Cool. Yeah, there we go.
Okay, what do we do here? 2 and 3. Let me run this in LeetCode. Let's see. How you feeling with that question?
That was cooked, bro. That was a fail, bro. That was definitely a fail, dude.
Okay, I'm running this in LeetCode. Almost done. Runtime error. Okay, it passed. It passed. Okay, we're gonna sneak in one quick one. One quick one. Let me grab off my list. Yeah, it's this one. So we're going to be given a linked list. Return the middle of the linked list. We can assume there's only one middle.
There's only one middle.
So it's like, it's basically odd.
Odd. Okay, yeah.
So what does that mean? So we have 1, 2, 3. This should output 2.
Can't you just have a slow pointer and a fast pointer and then solve that? Like something like that?
Maybe.
Wait, I think so. Let me see. Let me see. Oh shit. Yeah, you're good, you're good. Wait, so I think, see if you have slow 1, fast 1, and then you do fast goes, you go fast goes to 3. Slow goes to 2, fast goes to 3. But 3 is at the end. If 3 next is none, then slow is the middle. So let's try that with 1, 2, 3, 4, 5. Wait, are we assuming that we're getting like, so it's always going to be odd and it's always going to have like at least one node pretty much?
Yeah.
Okay. All right, so if we do this, then we do, so this is that, so slow is 1, 1, then fast is 2, 3, then 3, slow would be 3, and fast would be 5. Yeah, I'm pretty sure this is an algorithm that works. Yeah, I think we can just do that. So it'd be, the algorithm would be if slow, it would be if, so you do a while loop, I think it'd be like a while loop, if fast is none, return slow, and then otherwise move fast by 2, move slow by 1. It might even just be fast.next is not none.
Okay. Try implementing it. Let's see.
All right. All right. Bro tossed me the low ball for part 2.
I like you, so I had to get you the offer.
Damn, bro. Thanks, man. That's a nepotism right there. Wait, okay, so we're passed in the head of the list. Oh, you want me to code my own node too, right? Same thing. Def self, and then you do val and next. Let's just do that, and then self.values val self.next equals next, and then find middle. We just do literally. I just have this code right here. This is chill. While fast on next is non fast equals fast on next. And I guess it'd be and fast on next is not none. Right? Potentially. I think it's just this. Yeah. Well, if fast on next on, yeah, I think we can just assume because it's always odd, we don't need to do that case. And then slow equals slow dot next. And then you return slow. And then be head, fast equals head, slow equals head. And then you want me to code my own test cases, I'm assuming.
Yes, sir.
Actually, node 1 equals node 1. 2, 3, 4. Let's just do, yeah, let's do that. Sure. And then 2, 3, 4. All right, head.next equals node 1. Node 1. Next equals node 2. Node 2 dot next equals node 3. Node 3 dot next equals node 4. All right, and then we can do find middle on head, and this should return 2. Oh no, wait. Actually, you wouldn't even do that. Let's just do it print. Value. Yeah, just do that. Next. Okay. There we go.
Nice.
Thanks, dude.
All right. Giving you're hired. Let's go.
Thanks, bro.
When can you start?
Dude, right now, man. What's our first
honestly, yeah,
assignment?
you did. You get like obviously you're a little bit rusty on the thing, but I mean you're able to debug it, solve it. I mean obviously with just like a little bit of practice, you'll be able to solve that question, that first one.
Dude, I think they were both easies, right?
Kind of. Let's see. The Cousins one is interesting. Um, but yeah, yeah. How do you think you did? What can you do to improve? Like if you gave that performance, what would you do coming out of that to not mess that up next time? Because like we all
Um,
mess up sometimes. Like we've all done interviews where we get cooked, and then it's like, how do you go back to the drawing board and fix it up?
well, I mean, first I would study. I think if I actually first I would study. But I mean, like if I actually gave that performance, I think I'd be like, damn, I'm cooked. I should do more binary tree problems. I would just go and I'd grind out like a bunch of tree problems. Um, like I would do the strategy I told you, like start from the easy ones and then work my way up and then do the harder ones. Cause I think that was probably like an easy, I would say.
Yeah.
Um, yeah, and so I just grind those out, make sure those are solid, and then move on. That's what I would do differently personally. Yeah, because I think the thing I didn't really, yeah, there were like some. It was mostly the edge cases around like when you find it, and like the root, the base case. So
Yeah.
I think that gets like straightened out pretty fast if you're doing like a lot of those problems.
Yeah. All right. Thanks, Camille. Thanks for hopping on. Good luck with your hangover. Hopefully you heal up. But thanks for hopping on the stream, bro.
Yeah, of course, bro. All right,
All
have
right,
fun with the
man.
rest.
Catch you, man. Peace.
All right, later, dude.
Yo, chat. I'm gonna quickly. That's a strong hire for me. Yeah, I don't think that. Well, the job market. The main reason why the job market is cooked is it's hard to land an interview. But when people land their interview, they fumble. Um, that's what's happening right now. I'm gonna take a quick little super fast break.
Hey everyone, John.
I'm gonna grab a coffee. I'll be right back. Give me a sec. I'll be back. I'm gonna grab a coffee. Give me a sec. Give me a sec. Eric, when I come back, we're gonna run our interview. I'm gonna take a 10-minute break. Or we'll just put 15 right now. Yo, Farzan in the building. I'm just gonna take a quick break because I need to grab a coffee. I've been running for a few hours straight, so. Just find it good. You find a good video. Shoot, Apple TV. Yo, thank you, thank you. I'll be back, I'll be back.
What would you say is like usually like the level that you have to be at for like these like positions that like I'd be like applying to for like the LeetCode stuff? Like I want to get done with the LeetCode 150. I was doing the LeetCode 150. I want to get done with that by June, and then I saw that you said that you should start with I forget that website, but it has an ELO rating, like how like chess is for the LeetCode stuff and like just finding the ELO and going through. Like where would you say like the level you need to like be at in terms of like the rating for that zero code is it called? I forget what the website's called. Zero track, yeah. Like do you think there's like a certain ELO range that you should like definitely be at for like a lot of these online assessments?
Yeah, so like zero track, I wouldn't even do it if my goal was just to get a job.
Really? Okay.
People, I only do zero track, and other of the people on the channel only do zero track because they just want to just get really good.
Oh yeah,
But
bro. Some of the people in your channel are like
yeah,
they're inspiring. Like Paul and Alpha, I always see those guys are going at it with
yeah,
like their like mathematical solutions and stuff. I'm like, damn, I want to be like that. It's pretty cool.
no, they're really good, but they're
Yeah.
just like those guys could just probably pass any lead code style interview. So what I
Yeah.
would do is first focus on specific like data structures.
Yeah.
So I would go topic by topic, as in I would start off with arrays and understand arrays in depth. What I mean by arrays, I would understand all of the operations on arrays, like inserts, deletions, indexing, like what are the runtime complexities. Then I would do the common array question. So I would focus topic by topic. Then I'd move on to like linked lists or depth first search and just spend time on depth first search for a week or two, topic by topic, right?
Yeah. Yeah. That's what I'm doing on the LeetCode. I'm going through each one and I'm going all the way to the. I finished the whole thing, like to the hard problems on like each topic.
Yeah, and then once you finish specific topics, you'll be able to pass at least like 70% of the interviews, right?
Okay.
After that, start going to specific algorithms. So what are specific algorithms? Like two pointers, Dijkstra's,
Yeah. Yeah.
topological
On the
sort.
TikTok one, I got asked the Dijkstra's and a breadth first search. I
Exactly.
remember that. Yeah.
So I would start going algorithm by algorithm, union find, right? The common
Um.
ones, binary search. So those are
Yeah.
patterns that like operate on those data structures, but those ones like I have a video also on the top 6 common patterns. I don't know if you've
Yeah,
seen that
I
yet.
was gonna ask like some of this stuff on here. I'm thinking like I don't know if they could ask for like the roles that I'll be applying to, like some of the stuff like backtracking, 2D dynamic programming, bit manipulation. Is that stuff asked for like the positions that I'd be applying to? Do
I
you
would
think
say I would say
less common?
it's less common. So
Yeah,
the most popular ones are two pointers, sliding
yeah,
window. Those are very common.
yeah. I'm pretty
Depth
good at
depth
those.
backtracking, that one's common. Depth first search, breadth first search, and then binary
Okay.
search.
Yeah.
So
Okay.
those will cover a lot of ones. And then I've been asked topological sort a lot, but honestly I've barely been asked dynamic programming. I've barely been asked I've never been asked the bit manipulation question, so those
Okay.
ones are way less common.
Yeah. Usually whenever you do the like the live coding interviews, I usually like follow along with it. I try to like do the questions on my own to like to kind of see where I'm at with some of these people,
How
and
are
like
you
I'm getting
doing?
better at it for
Yeah.
sure.
Yeah, we should run one at some point.
Yeah, I'm definitely down. I'm definitely trying to get better at it.
Yeah, and just send me your resume.
Yeah,
I'll do
I
some
have
I'll
it in
do some work on.
your channel actually.
Oh really? Did you anonymize it already?
I don't think I did that.
Oh, okay, okay. I'll look
I
at it a
mean,
different
I
time.
don't really care. I don't think
Let's see.
it's I basically when I put it in there, the advice that I got from a lot of people in the channel was I need to be better at the XYZ thing, and like I just don't know how to put
Oh,
the
I
Z
see.
part,
Yeah.
and then they say kind of just lie about it. I don't know like how though with some of these projects.
Wait. I requested edit access.
Yeah, let me see.
Which is really good.
That should be on Google Drive. You think? Let's see.
Yeah. First off, feel like your resume is super empty right now.
Yeah, I know. It's not good. I need to get better projects on there for sure.
Yeah, I requested edit access. I'll just quickly like X out some spots. You can change it after.
Yeah, I think I gave you access. Let's see.
Nice.
Yeah, you can. Okay.
Like this.
Yeah, no, I mean, yeah, it's not good. Like, I'm not saying it's good at all. I understand why I'm getting rejected.
Okay, I'm gonna bring it here. So let's look at it. Okay, I think you're ordering it properly. You have education. That's the most important part.
Yeah,
I
because
would
everything
put
else is so weak.
yeah projects. I would move my work experience above the skills.
Okay.
Because like what does the skills even tell you? It doesn't really tell anything. It's just more just like for
Yeah.
the ATS. Like if you say you know JavaScript, like how do you prove it, right? Well, you
Yeah.
proved it because
Through
you
the
did
projects.
projects, right?
Yeah. Yeah.
So that's why it doesn't. That's why like it doesn't really matter that it's at the
Okay.
bottom here.
Yeah, I figured because my work experience isn't like related to like tech, so that's why I put it so far down. But yeah, it
I
makes
would
sense.
just like update the spacing here a little bit. Like, it's a little bit too much spacing there.
Okay.
When is your expected graduation?
I think it's May 2027.
I would explicitly just say that, or I
Okay.
guess it kind of says it here, but I'd be like, maybe like we can go current expected. Something like that. So
Okay, yeah, that makes sense. Yeah, I see a lot of the companies when I apply to them, they always are like, "What's the expected
this
graduation?"
one, I think, yeah, this is more explicit.
Yeah, yeah, yeah. I see that. That makes sense.
I would add more links here, like add your LinkedIn and stuff. Build a LinkedIn presence a bit, or just add people on LinkedIn.
Okay. Yeah, I don't have one of those yet.
Oh, add one for sure. That's how
Okay.
I get all my jobs.
Okay.
Portfolio, website, and GitHub.
Yeah, I definitely need to be better at the networking part. I'm
Yeah,
not that good at it.
so you can do this, and you could even, like one way, you could even just like add a hyperlink here, so it's not. So when you add your portfolio website and the LinkedIn, otherwise it just makes it look nicer. Right?
Yeah, I get you. Some people have like the icon for like the GitHub thing I saw.
Yeah. Let's see. Yeah, I would just like improve the bullet points a bit, and you could just run that through GPT.
Yeah, yeah. To get the percentages in there and like the numbers better. The Z.
But that's only do that really when you have work experience. I think it's fine to do it to have it like you're not optimizing anything when you're
Yeah, I'm
building a
not.
project for the first time. It's like you're just building it from 0 to 1.
Yeah,
So it doesn't make that as much sense.
yeah. There's no optimization though. I'm just trying to get it to work.
Yeah,
So like,
exactly.
please
So
run.
but what I would try to do is like one thing that would set it apart is if you built something that maybe had users. So
Yeah,
pretend you did you built something in a hackathon you want. Like what are the achievements with the project? So like,
yeah,
projects are fine, and that still will get you a job. But like to even set yourself even further, like if you build one and it gets actual users, or you build one and you win a competition, that might set you even further apart.
yeah.
But if you have time, I think just build up more projects and fill this out a little bit.
Yeah, would you say like would you recommend like I don't know how to put like the next pro like kind of like the genre of like what projects I should be working on like now? Because I've got like the simple ones. I wanted to build a deploy one like fully like online is my next one. You know what I mean?
Yeah, and like what you'd have to do is just like have like link to the website or something like that,
Yeah, yeah,
and just like to do a hyperlink. You could also just make it public in GitHub and just have the GitHub link there. That also works. Sometimes I do both. Like I'll just have like GitHub
yeah.
and like the link to the website if I want both access. But yeah, maybe we could have a section called like technologies used. I don't know why it's not making a bullet point. So we could update it like this. Just to avoid cluttering it.
Yeah. Do you think most job applications that you send are being filtered through the ATS, or do you think recruiters are actually like reading them before?
I think they're reading. I think that the ATS helps, it prioritizes who they're looking at.
Okay. Yeah.
So there's so much. There's so many resumes coming in. I doubt, like they need some AI to rank and sort them.
Oh
and
yeah,
tell
for
you.
sure. Yeah.
There's no way that they're looking at all of them. So you'll see them say that they're not using the ATS. It's like, but I'm pretty sure the ATS is definitely sorting them.
Yeah.
And then
How would you recommend me going about applying? So like what I've been doing like to apply for stuff, I've just been like trying to find everywhere. I'll Google like jobs near me for like the software stuff. I'll do LinkedIn. I'll try to find it. I'll try to do Indeed, all the things. You have like a recommendation for like how to go about it?
so what I do is first create my LinkedIn profile.
Yeah.
Fill out everything on my LinkedIn. On your LinkedIn, you can point out to different projects. You can point out to all of your classes. You can point out to different awards. Like LinkedIn, you could build your whole resume on LinkedIn,
Okay.
essentially, and add everything there. Because a lot of recruiters use LinkedIn to find people. So you could specify all the stuff there, and then I would set my thing as open to work,
Okay.
so that they know that you're open to work. And then I would just optimize my LinkedIn profile. Honestly, my best luck has been through LinkedIn, and that's before I ever had any social media presence.
Okay, I'll have to get on that then.
Yeah,
That makes
that's like
sense.
the best way. Yeah. What other questions you got?
I don't know. I've been struggling with coming up with ideas for my next project. Because I've just been doing the LeetCode grind. And I want to be able to do like a project that both like I can learn some stuff and probably like deploy it online, and then like learn some skills along the way too. Because I saw you recommended the personal finance app, and that was pretty good. I got to work with like APIs and stuff like that.
I don't remember doing this. Develop the or recommending that.
I have
but
I have the photo I think from your stream that I took.
so that's so funny. Integrated Plaid. Oh, so you actually integrated Plaid into your own personal.
Yeah, I got dummy
Wow.
info.
Well, that's cool.
Yeah, through the Plaid API. Yeah, let's see.
So I
check
think
out your photo,
when
yeah.
I'm looking at your projects right now, I could tell you're good at you're able to do some front end and some back end.
Yeah.
What APIs did you use? Oh, you use RESTful backend.
Yeah.
So do something with like like we need to include some infrastructure like AWS. We back. Input, output. Eric, hop in. Eric,
Yo, what's up?
how's it going?
All good, man. How about you?
Nice. I like the accent.
Thanks.
Yo, do we have an accent to you? I mean, it's kind of a stupid question, but like when you look at Americans or Canadians, like
Canadians.
What? It's
Yeah, definitely. Yeah.
It's like you're like, that's a dude. Does it sound weird? Like these guys have a weird accent, like a different.
Probably not as weird as you would like hear me, because I'm used to like Hollywood films and a lot of influencers are American, you know. Whereas you wouldn't be used to like much Irish celebrities like growing up.
Okay, yeah. So so you could. That
Yeah,
makes
I'm
a
more
lot of
used to it
sense.
than you would be.
Yeah. So like, if somebody like who never heard English before, they would think obviously like kind of like my accent's kind of the default, and then British is like a variant based on
Yeah.
Hollywood. Yeah, makes sense. Cool. All right, let's get this thing started. That's funny. How's the weather over there in Dublin?
Dreadful. It just rains all the time. It's
I just
miserable over
heard.
here, man.
Like even at this time.
I mean, we had good weather like 2 weeks ago, but it's just been raining non-stop since.
Yeah.
Like in Irish summer is like 2 weeks of sun and then just overcast or rain for the rest.
Are you?
How about over? Are you in Canada now, or are you in the States?
I'm in the States. I'm in California. It's sunny today.
Oh, that's very nice.
Yeah. So just updating this. Yeah, we'll get into some intros and stuff. They're saying you sound like a little bit like your mic is in the background or you're far from your mic. I don't know if that's
I'm
good.
far. I can move it closer. Is that better?
What is he? Say hello.
Hello?
Okay, yeah, that's fine. Yeah, it's cool.
Okay, go. Oh, they're saying I'm louder than you.
It's fine. I could adjust that on my end. Don't have to do anything.
I'll move it away.
No, it's fine. I could adjust that on my end. All right, let's get this thing started.
Okay.
Sorry. All right, 3, 2, 1. Hey everyone. So today we have someone joining in from Dublin, Ireland, and yeah, he wants to prep for coding interviews. Do you want to give a quick background of yourself and where you're from, and maybe like what companies you work for, or if you're a student, and then also why you're doing LeetCode, how many LeetCode questions is your algorithmic journey kind of thing?
Yeah, my name is Eric, and I graduated 2 years ago with a computer science degree from Dublin City University. I've been working for the same company that I've done my internships for in third year, and I've just basically just worked from there. And I'm just sort of in the area of job searching with doing like grinding LeetCode questions. Yeah, and that's basically it. I've just been working for the same company. I work for like a Dublin-based company. I doubt any of you wouldn't know them. So
Yeah.
I doubt. Yeah, that's
So
basically
people
it.
are doing LeetCode even in Dublin. They're making y'all do LeetCode too.
Yeah, that's something I should probably mention. The standard for entry is a lot lower over here than it is in the States.
What do you mean standard? Sorry, you cut out. Okay, you hear me?
Yeah, sorry, I cut out there.
Okay, yeah. Like, what do you mean by
Yeah.
standard? As in, like, they're not gonna ask you LeetCode hard or LeetCode medium?
Yeah, no, they would ask medium, but a lot of the companies won't ask. Like a lot of the interviews I've done so far, they're not LeetCode based questions. They're usually it's usually just more so like you're given a hacker rank like full stack app, and you just sort of have to debug. A lot of the big companies though would still do LeetCode, but even then they wouldn't ask as hard as questions as they would over in the States.
Yeah, that makes sense. Like, honestly, LeetCode style question, I'm not a big fan of it anyways, but people are asking it. People want to know how to get better at it. That's why I make sort of this content, but I try to mix it up. But, like, what companies are in Dublin? I know, like, a ton of companies are in Dublin these days, right? Like, I think they did something where they cut out all the tax or something. Now all these companies are starting to build offices there. I think that's what
Yeah,
happened.
legit. All the big like companies are over here. So yeah, and it's
What are you aiming for? Like, which companies? You want to work in FAANG, or do you want to work in mid-size startup? Like, what's the ecosystem there, and where do you want to work?
I realistically I don't mind once the like the growth opportunities are good enough, and the tech like the tools and technologies that I'm working on are interesting.
Yeah.
So yeah, but mainly like yeah, I work for a small startup at the moment, so maybe I would like to break out into a more bigger company than currently.
Yeah. Let's see. What's it called? What's my other question? Yeah. Damn, I had another question. So you want to break into sort of like the bigger companies? How many questions have you done so far?
Yeah, I only started about like 2 months ago. Like I think I was just checking in April 16th, and I've been grinding a lot. I've done like 200 and I think 97 so far.
Nice.
But like 10% of those I reckon aren't like my own submissions. Like
I see.
when I started off, I've gotten the habit of just like uploading like ChatGPT solutions that I couldn't find. But yeah, I've learned that it's better off not to do that. So if I don't understand the solution now, I'll move on and come back to it later. Like.
I see. Okay. Oh yeah, I remember a question. Like, what's like the kind of salaries that you expect out there? Like, if I work at a startup all the way to working at a FAANG company, I was just curious how it compares to like
Yeah,
Canada and the U.S.
the salaries are much less. Obviously, the cost of living is way lower over here. Than California. At least the salaries are much lower.
Yep.
So, like for a FAANG company, like with 2 years of experience, total compensation, you're probably looking at about. Like obviously it depends. Like obviously if you do really well, you can get like higher. But from what I've seen and from the interviews I've been doing, it's like it ranges from around like 90 to 120K for like 2 years of experience. That's like upper end.
190 or 90 to
No,
120 euros? Sorry.
90 to 120K, like total comp. That includes like bonus and stocks.
What like you get paid in euros or what? Like
Yeah,
what's
euros.
okay,
That's
euros.
slightly stronger than dollars. I'm not sure what that is.
Okay,
Like
that's
converted, like
actually really good. How much is like a one bedroom apartment?
in Dublin, it actually is quite expensive over here. I wouldn't know off the top of my head, but it's yeah, it is in the city center. It is quite expensive. I'm pretty sure it's like top three most expensive in Europe.
How much is houses? How much is I want to buy like 3 bedroom house. I have 3 kids. How much am I paying for a house?
Yeah, the housing market in Dublin especially is very expensive. Like very like for like a 3 bedroom house, like probably it depends. Obviously, it depends where you live. But it can range from like 450 to like 650,000.
Wow. Yeah. I mean, it's not terrible as the U.S., but it's just interesting because the cost of living is high, but then like there's you just said the cost of living is lower, but then all of a sudden
Yeah,
you bring
the cost of living overall is lower, but the housing we have a housing crisis over here, so
I
the
see.
like houses and just like rent is extremely high in comparison to other European cities.
Yeah, they
if
got
you
like
wanna,
housing crisis everywhere at this point.
yeah, they do, to be fair.
Let me what's it called? How much is it to go out for food?
Yeah, like it's probably like a similar-ish price. It's like I don't know if you want to like go sit down for a meal. Like if you're not going to like a big fancy ass restaurant, it's probably only like 50 quid, maybe 60 quid. If you don't drink alcohol, but if you drink alcohol, it's going to be more, obviously.
What's 60 quid like euros?
Oh, 60 euro, yeah.
Wow, that's actually expensive. That's actually crazy. Yeah, I don't know. I mean,
Not
it's similar
even
to
cheaper,
US.
but if you're going to like a more casual place, it'll probably be like 30 euro.
30 euros just to eat. Damn, yeah. I don't know. Like, it's just that's kind of the same prices out here. Honestly, little bit. Like, it's actually pretty close.
Like, how much is a coffee over there? Like over here,
Coffee?
it's like
Okay, $5 USD.
5.
It depends.
Yeah,
Yeah.
yeah. If you're getting like a fancy
Latte,
latte over here,
$5
it's
latte.
probably, yeah, it's around the same over here. It's like 450 over here.
Wow. Yeah. Yeah, it's like $5, $6. If you go
I thought
to,
it was way more in California. I thought it was like $8.
it
Or is that more
depends. It
Are
depends.
you in
If
the
you,
Bay Area or?
yeah, I'm in the Bay Area. Like, I just got
Oh,
one
really?
for
Oh.
$4.50, and the one I'm drinking $4.50. Like, but if I go to Starbucks, like $6.
Yeah, Starbucks is trash anyway.
Yeah. Cool. All right. Nice understanding how life is over there. It's super similar. I mean, doesn't really matter. We're in different areas of the world, and we're both still doing LeetCode, so it's pretty funny. I'm gonna send you. That's what you realize when you do this channel. Is like everyone's joining in from different parts of the world, but everyone's kind of doing the same thing. It's not like there's no real difference that I'm in Canada or in the U.S. like, or you're in Ireland. But I guess like all these companies operate heavily in Ireland. Anyways, I sent you the link. All right.
Yeah, I'm in.
So we're gonna start off. I'm gonna pick from my list. You're good. You've done 297 questions, right?
Yeah, give or take. Again, not all of those solutions are mine, so around 270-ish would probably be more close.
270-ish. How many easies, mediums, and hards?
Off the top of my head, I don't know, to be honest. I think I have like 20 hards done, and then like 70 easies, then the rest will be mediums.
Yeah. Like when you went to school, were you pretty good at those algorithm classes, or it just went over your head and you just couldn't understand it? Like, were you pretty serious?
I was really bad. Yeah, like we done data structure and algorithms in second year, and then like third and fourth year was more like design based stuff that I done better in. So like when I had to go over 2 months ago, it took a while for it to click, but once it does click, it like you learn a lot faster. Like
Yeah.
like that's just the thing with programming. Everyone says it, like it can take ages to learn something, but then once it clicks, it just sort of clicks, you know.
Yeah, and you grow exponentially too. Like you can just keep getting real good. Okay, I'm gonna post in the first question here. Yeah, thanks for taking the time out. I know it's late for you. We're gonna go through this first question. We're gonna try to go through. It ends in 40 minutes, so we can get through 1 or 2 questions depending how fast you get to them. But the first question is: we're gonna be given an integer array of numbers. We essentially want to move all the zeros to the very back of it while maintaining the relative order of the numbers in the array. Does that make sense?
Yeah. Yeah. Okay. Yeah. Give an integer right now. So you must do it in place. Okay, that makes things harder. While maintaining the relative order. My first sort of solution is to, okay. So basically, okay, nums.length and nums can range from this. Okay. Move all zeros to the end of it will maintain the relative order of the non-zero. And can this array, will it have duplicates, or is each number will be unique?
It could have duplicates. It could
Okay,
all be ones in here.
Yeah, yeah. Okay, that makes sense. And obviously these are sort of already sorted, so like can an array be given something like this as well?
An array that can come in already sorted, yes.
No, but can the array be of any order essentially? It like
Yeah, it could be any order. It could
Any
the
order,
values
yeah,
in
yeah.
it are we don't we all we want to do is move all the zeros to the end and maintain the relative order, but the order of those elements could be in random order.
Yeah, yeah. Okay, my first I'm just brainstorming here. Approach would to have an initial run to keep track of yeah, my first approach would, so you must do it in place. So it says this, you must do it in place, but can I use a data can I use just a separate array to store, or can I not use any extra space?
What would be your extra space solution? Let's
It
just
would
discuss it.
It would to essentially, for every non-zero element I see, I will just store the index. I will just store the value of it essentially. And what I will do is, so when we go through, let's just say this input here. Oh, sorry, this input here. Let's just put it down here. I will keep track of each zero number. So then when we see it, since we're keeping track of it, it doesn't necessarily matter what we see. What we see here. So when we go through it first, yeah, and then we keep track of all of the non-zero integers. So then when we go through it again, we'll essentially just store on each index. We will store. Yeah, this will be a queue then actually. So on each index, we'll pop left from here and put it inside of. Just not put it inside, but change the value of that current index with what this is. So we pop left from here, which is 1, and then we pop left from here, it'll be 3, and then we keep popping left till it's empty, then it'll be 12, and then when that's empty, we'll just put everything else to 0. We'll change everything to 0, if that makes sense.
Yeah, that makes sense. So when it's empty, you just put zeros.
Yeah.
Until like it meets the solution. Okay, I mean, go code it up quickly, and then we'll figure out a more optimal. We'll investigate it. It's a good first pass, but yeah, just code it up. Let's just see.
What's this given as your website? we also want to keep track of the length. So for num and num's q.append num, and then we have it here. So this will essentially build up our array of non-zero values. And then what we want to do now is, I don't think we, for index in range, now we just want to essentially change every value that's in num. So we want to say, sorry, I'm using JavaScript syntax here.
Mixing back and forth.
Between between work, because I work mainly JavaScript and work. I think that will work, and then we just want to return nums, obviously. Q equals C. So for num and nums, if num does not equal 0, Q to append num. Range and if Q greater than 0.
Okay, walk me through line by line.
Yeah, so we have the length of nums, and then we're just initializing our queue. So what this sort of loop does is we're just essentially, for every number that isn't equal to 0, we're just going to add it to the queue. So that will essentially build up our array to look something like this: 1, 3, 12. And then what this one does for index in the range of this, we'll check if the queue is greater than 0. So basically, we're just checking if there's a value within that queue. Then we'll pop from that queue and change that index, that current index of the queue, of the value, to the whatever was on the left of the queue. And then otherwise, we'll make that that value 0 because there's no more values left.
Okay, run some tests on it.
Yeah. Let's start off with this one first. How do I run?
Command enter or the green button in the top
I'll
left.
have to do something like this, print nums.
Okay. What's your time and space complexity?
Yeah, the time complexity is O of n. Well, we're going through n twice, but obviously we can just rationalize it down to O of n, and then since we're using extra space of O of n as well, worst case. But given that it's in place, I think there's probably a solution that could be done without using any extra space.
Okay, so you said O of n time, O of n space?
Yeah.
Okay, yeah. Can we look for a way to do this in O of n space and time? Can we do in O of 1 space?
Yeah, I definitely think we can, especially given the fact that it's asking to do it in place. Can I just think for a couple of minutes first?
Yeah, go ahead and think.
Yeah, I think I have a solution now. Yeah. Or do I?
What are you thinking?
I was thinking of to keep track of the current index, essentially, of where we want to put a non-zero value. So for here, we'll just say the current index will equal 0. So every time we see a non-zero value, we'll increment this. So when we see 0, we add this to the end, and then when we see the 1, we move here and move this up 1. But my edge case I was thinking is, how do we handle this 12 when we make the swap between the 0 and the 12?
Okay, so we're gonna have a current one right here on 24, and we're gonna have another pointer kind of moving through the array. Is that what you're thinking?
Yeah, something similar to that.
Okay, yeah. Keep exploring. Seems like
Yeah.
it's like you're going the right direction.
Okay, another solution is every time we see a 0, we want to find the next non-zero value, and we just make the swap there and move on. So we have a 0 here, and we mark this index, and we'll move forward until we see a non-zero value, and we make the swap. So then this will become 1 0. Then we move on again from here until we find a non-zero value and make the swap here. So this becomes 3. Then we move here and we continue traverse until we see non-zero empty and make it like that. Is
Like, what would be the runtime of that solution?
yeah, so since we're so we go here. Yeah, worst case that could be n squared actually, because we're like the last value could always be at the end of the array, so we'd be constantly searching.
Mm-hmm.
Or not necessarily actually. Could it be O of n? Yeah, it could be O of n, because when we come here with when we make this the swap, we can set the new. Yeah, we'll keep track of. It'll be 2 pointers. We'll keep track of the current index of change and our current index of where we are in the array. So when we make the swap, we will increment the. So right here, let's just say our pointer is pointing at this 0 here, and we have, let's just say, this. When we make that swap, we will also have a pointer pointing at this 1 here. So then when we make that swap, we'll set this to 1 and we'll set this to 0, but now we set the current index to here. So then we can continue moving up until we find that. So then when we set this to find this, we'll set this to 1 and we'll set the current index to here. Sorry, I mean, we set this to 1 and then we set the current index to here, and then that would make it O of n while not using any extra space. Does that make sense, or am I?
Sorry, could you repeat that again?
Yeah, so we're going to keep track of
Let's do it on a small case like this.
Yeah, so we'll keep track of yeah, let me take this. Keep track
Right
of
here.
2 pointers. So the first pointer will be the index of the 0 that we want to change, and the second pointer will be the
Just mark it like this, and then move it.
yeah. So the first pointer will be at the first 0, the 0 that we want to change, and the next index will be the sort of like n for next will be the pointer that we're essentially looking for a non-empty 1, a non-zero value. So when we come to this 1, we notice that it's a non-zero value, so we'll make the swap there. And when we make that swap, we'll set this pointer here to whatever that pointer was. So we'll move that up, and we'll set this to basically +1 of that pointer. And then when now that we know that this is the value that we want to change, we'll keep iterating this until we see a non-zero value. So we see that it's here. So we'll set this to 3, and then this to 0. And then essentially what we'll do here actually is keep iterating until we see a 0 again. So we have a 0 here, and then this will be, oh, see, that's O(n) squared. This is tricky, man.
I think that's like promising right there, and let me just walk through that. So we have 0, 1, 0, 3, 4. Let's go. So we station C at or Z at like the next 0, right? And we just have a pointer.
Yeah.
Every time we see it, we just swap 1, 0. You move this up, and then you just keep moving. C4, swap. Move this up. Right? Just swap.
Yeah.
Every time you see.
You see a non-zero value. Yeah.
Yeah.
But is that O(n) still? Oh, it's we're only going through each. Yeah, we're only going through each item in the array once. So yeah, that's O(n) actually. Yeah.
Mhm. Yeah. We go try to implement that.
Yeah. So we need a value for
Google Productions. Thank you.
So the
Appreciate
best way
you.
that I think of approaching this would be to have obviously the pointer for the 0 we want to change, and essentially then the first pointer will be the pointer after that. So instead of using, so how will I? So yeah, I'm just gonna have cur next equals 0, 0. Oh, that's, yeah. So what actually is just gonna be cur equals. Essentially, I'm just gonna continue iterating the current value if it doesn't equal 0. So I'm just gonna say if nums of cur does not equal 0, just continue essentially. And so when this point hits a 0, then we know that we're currently at a 0. So then we'll set a second pointer to keep iterating until we see a non-empty 0. So we'll have something like next equals.
Yeah. Makes sense.
So what?
I think we can move on to the next question. I think you got the gist of that question.
Okay.
Yeah. Let's move on to this one. Because I want to get through 2 questions. Breadth over depth.
Yeah, that's no issue.
Breadth over depth.
That's no issue.
Yeah. Let me fix this up quick. So we're gonna. Sorry. Let me fix this up. So we're gonna be given an m by n grid, right? Initialized with 3 possible values. You're gonna have -1 equals a wall or an obstacle. It's gonna exactly look like this. Let me fix up the input. Yo, Paul, what's up? Oh, it's kind of tweaked. Something like this. This is so. Well, we're gonna be given a grid like this. So you could see there's different values in here. There's -1, that means it's a wall.
Yeah.
There's 0, that means it's a gate. And infinity means it's an empty room. That means there's nothing there. So what we need to do is we need to fill out pretty much the distance for each room to the nearest gate. So it's the answer is going to be like this. Right?
Okay, yeah.
Wait. Oh shoot. I'm missing some of the output. Let me fix this. It's kind of annoying. So this is the answer, and I'm gonna quickly explain why this is the answer. So these are gates, right? This means it's like a wall. Or sorry, -1 is like a wall that you can't get to. Gates is like an exit. So why is... Dude, this is so... I need to like left align this. So it's just easier for you. Sorry, chat. Okay, this is better now. Okay, so we essentially just need to fill it out. So why is this top left 3? Well, it's because the closest gate is 3 away, 3 cells away, right? You can see the closest cell is 0, or you can't pass through walls. It's an obstacle. So 1, 2, 3, 4. This one's 4 away, and this one's 3 away, or 1, 2, 3, 1, 2, 3. This one's 4 away, right? And then you see this one's the closest one is 2 away, 1, 2. But then when you get to this one, the closest one is actually 2 away because it's this gate. So basically, for each infinity cell, we just need to answer the question: what is the closest gate to it? Does that make sense?
Yeah, that makes sense. Yeah. Yeah, I think I have a decent idea of how to. Obviously, we're gonna need to use a search algorithm, and since it's shortest and they're non-weighted, I think breadth first searches are probably best approach for now. I was looking at it for a while and I was confused on what was the best approach of doing this, of where to start essentially the search. But I think we obviously don't want to use a breadth first search approach on each sort of time we see infinite. So, and since we're looking for where are we looking for a gate, is it? Fill each empty room with the nearest, to the nearest gate. So the best approach would actually be to use a queue, but add each 0 to the queue. So obviously when we find a 0, we'll add the roll call, and sort of it'll obviously be the distance would start off at 0, and then we'll use that sort of queue to find all of the infinites that are adjacent to it and add that in and just add it +1. And then that way we won't need to essentially perform a breadth first search on each time we see infinite. And so when we see a new infinite within the grid, we just need the +1 of what the previous value was essentially. And we won't need to use any form of extra space. We can just essentially update the previous array that was. We can just update the grid that was given to us. And if essentially that way we can prevent like the breadth first search from adding previous values from preventing an infinite loop from happening that way, if that makes sense.
Okay, you're gonna start at 0 and 0. Or sorry, wait, could you just quickly repeat it again?
Yeah, so I'll take down some notes actually. So we'll iterate through the array with a queue, and for each 0 we add we append it to the queue. And then after we do that iteration, we begin a breadth first search algorithm of the elements that we found in the queue. And essentially we'll add the row, the column, and then the step. But the distance will essentially start at 0. And for every time we see we'll essentially look for all of the adjacent rows and columns. So row +1, row -1, call +1, call -1, etc. And every time we see an infinite, we'll essentially add that to the queue, and then this +1. So for example, for this one, we'll see that this is here. Then we'll just add that to the queue, and we'll change this in the grid to 1. So that's essentially the distance from this to here.
I see.
And then it says, look, it should be filled with infinity. That way, we don't need to fill it with infinity because it's already filled with infinity in the grid.
Okay. Yeah. Seems valid. Go ahead and try it out.
Okay, cool. Why is that happening? It seems that it's like registering my code as a comment.
Let's finish this off right here. There you go.
Okay, cool, thanks. What is it? Find. Yeah, just find distances. I always forget to spell Q. Oh yeah, I'm doing this wrong. Why is that an error? Oh yeah, it's just 0. And then, so that's essentially adding all of the gates into the queue essentially. So after we add them into the queue, we just want to perform the breadth first search. So then we have row call. And we want to get the candidate row, the neighbors essentially. So we'll do this. We'll just copy this. So these are what this is doing is essentially just getting the neighbors of all the rows and columns, and we want to essentially iterate through this and validate each neighbor row and neighbor column to make sure that they're what we want. And the first way of doing that, is to make sure that are actually within the grid sort of parameter. So we want to check that they're not out of bounds essentially. So I'll do that now. How do I check for infinity? Is it just like float infinity like that, James? Or
Yeah. Yeah.
okay. Let me just see. So yeah, what I'm doing here is just checking that if it's not out of bounds.
I'll create a variable right here called float. Just
Okay,
use that
cool,
variable
thanks.
line 27.
Okay, sound, thanks. So yeah, I think we can just, since it's a breadth first search algorithm, essentially the first infinite item we see in the grid will be the shortest distance to it. So we can essentially just straight up append it to the and we also want to prevent the infinite loop, as I was saying earlier. So we want to change that distance here, so that this way we don't need to keep track of a set or anything. We can just essentially update the grid itself equals this plus 1. So if 0 less than equal neighbor row less than a grid or not 0, that should continue. This plus 1, so that should end it. Sorry, I'm just going through here to make sure I didn't miss anything. Do grid neighbor on it was this plus 1. I think that's a close enough solution. I'm just going over it to make sure I didn't miss
Yeah.
anything.
Walk me through line by line.
Yeah, so I'll walk you through on this example here. So what this essentially does is just getting all of the gates, the gates within the gates within the grid. So on this approach, after doing that, the queue should look something like this. So this is row 0, column 2. So and that's 3 1. Sorry, that's 3 0. Sorry. So yeah, so after this approach here, it should look like this. And then when we run the breadth first search algorithm, we will pop this first. So this will be our initial row, column, and distance. So we're looking for the neighbors here. Wait, this is actually infinity first. So we're looking for the neighbors here, and it'll check both of these values. But since this is -1, it'll essentially continue. It won't check that, and then it'll check this. So since this is infinity, it'll append that row and column to the list, and then that distance plus 1, and it'll change this to 1. So now our queue looks something like this. So that was 2 0. So our queue will look something like that, and then it runs it on this approach here. So up here we have this. It'll essentially change this and this to 1, and it'll add those to the queue, and then it'll go back to what we had here, and it'll change this to 2 essentially, and then it'll check this one here, and it'll change both of these to 2, and then this will become 3, and then this will become 3, and this will become 4. And I think that's what we have down here.
I see.
Yeah.
Let's see. Okay, run it on a few test cases. Run it on the test case, like build the test case and run it and assert that it works.
Yeah, sure. Let me just say it. I pasted the wrong thing. We have infer. And this was actually 0. That was the initial test case, wasn't it? This was infinite as well. Yeah. You missed the oh yeah, commas. Let's try that now. 3 minus 1 0 1 2 2 1 minus 1 1 minus 2.
Print it like you should print it line by line so it's easier.
Yeah, okay, cool. So I'll just do something like this. Yeah, that seemed to work. Do you want me to try more test cases or?
No, I think that's fine. We're coming out of time.
Okay, cool.
Cool. How do you think you did? How was that experience?
Yeah, no, that was cool. I think my intuition on the first one was a bit slow. I think that happens from a lot, like probably more often than it should. I feel like with those, I feel like the second question went well, but I like with those like algorithm heavy questions. Like if you know the algorithm, once you see it, it's very easy to implement. But like with those like sliding windows or 2-pointer type questions, it's sometimes intuition. If your intuition's off, it can be hard to think of an initial solution, even if they're potentially easy.
Yeah, yeah, I see. Yeah, what would you give yourself rating? You passing yourself? I'll give mine after.
Yeah, it really depends on the interviewer. Like you can obviously have some interviewers which can be harsh, which wouldn't pass. But I say overall, I didn't do perfect, but I think I done decent enough.
Yeah,
I feel like it's a bit late over here, so I wasn't communicating the best either.
yeah.
There's a few times, especially in the last question, where I was just coding large blocks without saying anything.
Yeah, honestly, you did good. Definitely a pass. Um, the first question you gave the brute force solution. You were able to implement it. It worked. I asked you to um, like improve on it, and you're able to improve on it, but it took a while, so couldn't give you like you still would pass the question. I would just yeah. I think that question is kind of a little bit tricky with that thing like. But you're going the right direction. No real problems on that. Honestly, I like your code. Your code is clean. It makes sense. You structure it well. Use good variable names. Um,
Yeah, the breadth first search question, it's I learned that from one of your videos, so it's similar to how you would approach.
yeah, it's nice. It's like I like it maybe because yeah, it's similar to how I would do it. Honestly, the only main thing that I would say is when you're going through the when I tell you walk me through your code line by line, you started like highlighting the comments, but I want you to do is actually walk me through line by line by actually referencing your code. I need to know that that
Okay.
so it's like what's the code doing, and you have to walk me line by line the code here because
Yeah.
you're going on the comments showing me what it's doing, but how do I know that your code is doing what you say it does? You have to prove it
Yeah.
to me by walking line by line by the code. Otherwise, I think it's good. You read the question well. You didn't jump into coding. You clarified the question and some edge cases. You had good clarifications. You're like, is it going to be sorted? Is it going to be like what happens if like you just had some good clarifications. That's always good. And then you walk me through the approach and runtimes before you implemented. Like solid job. Yeah, just keep like you're good enough to get a job. Just I would just keep working on more questions to just make sure that you don't get a question you've never seen before and get folded. But otherwise,
Yeah, yeah, yeah. No, definitely that happens. Yeah. Sometimes I'll spend hours on an easy question, which shouldn't be happening there.
yeah, cool. Thanks for
No,
hopping on.
no. Thanks for having me, James. Thanks a
Yeah,
lot.
cool. All right, nice seeing you.
Cheers. Best of luck.
See you around.
See you.
Yeah, yeah. Actually, Paul, what I said there is kind of dumb. Like just because you have good job, Eric, solid job. Just because I mean, if the upside is not hard, if there's no upside, I would just work 4 hours too, because otherwise you're just performing for no reason. But if there's an upside, like you'll get a promotion or you're learning really good things that is gonna help you in your career, make you like a more solid dev. I would work more. So it all really depends on what they're doing. It's a two-way street. You don't just put in the work and get nothing back. You need to put in work, and they need to either give you more money or give you good projects. Like that it's a two-way street there. Yo, chat. How do you think he did? And Paul, like you're doing the right thing. Instead of spending an extra 4 hours on work, you're getting a college degree, a master's degree. That's like when I worked a super boring internship before, and I would just stop working early and just start reading like a textbook or trying to work on a startup because that was more interesting to me. So if they can't find work that's interesting for you, then you have to find it yourself too. Like it's a two-way street. You know what I mean? Like, okay, who's next? I'll be right back. Well, I'll be right back. I'll be right back. We got somebody. We got somebody. Two pointers, one pointer, whatever. As long as you solve it, honestly. But yeah, there's always like some optimal solution. Thanks for tuning in all the way from Ireland, though. What's the current time there right now? So I'm gonna put this thing into standing mode. Dude, we've been streaming for 3.5 hours, but we're gonna run this on for a minute. Let me pick this up. I have to like put this on there like this. Just to, because the light tweaks, turns my hair purple. Next we have Jack. Jack, what's up?
Hello, hello.
How you doing?
Doing good. How are you?
Pretty good, pretty good. Were you tuned into the stream at all?
Yeah, I mean, I just kind of got off it.
Nice, nice. Okay, cool. I'm gonna start this up. Let me just stretch. James, do you watch chess? No, not really. So what's up, man? Where you're from? Let me check.
Missouri.
Missouri. 200 LeetCode, pretty rusty. Local
Yeah,
nonprofit.
haven't done it in a couple months. Yeah, no. I thought like, I mean, I've basically worked at a nonprofit, but like right now, what I'm doing is at a bank. So
Nice.
yeah.
Let's see. Cool. Yeah, we'll just start. I'm gonna start up a video in a second.
Yeah,
Wait,
just
let me
not the
check.
best at
Where
LeetCode,
the
so
heck
just
is
trying to try it out.
Missouri, bro? I'm only like I don't travel much. In the near Kansas City, near Iowa. Midwest, considered Midwest? Is that considered or not really?
Yeah. I'd say so.
Hey everyone, so today we have someone joining in from Missouri. Could you give a quick background on yourself? Maybe where you work, what school that you went to, how many LeetCode questions, and then just have a quick intro conversation, just so the viewers have an understanding of, like, where you're from and stuff.
Yeah, for sure. So I go to school in Missouri.
Nice.
Obviously studying kind of computer science, obviously. And then in terms of like where I've worked, I guess I worked at a startup, like nonprofit kind of vibe.
Mm-hmm.
And then working at a bank right now. And in terms of the LeetCode, I've done about like 200, I'd say 100 easies, 100 mediums, kind of half split. But yeah, I haven't done it in a couple months. I just kind of grinded it out more so during like interview season before,
Yeah.
like the last interview season. But yeah, I just haven't touched it, but I'm trying to get back into it.
Yeah. Okay. So what year are you in?
Yeah, so I'm like a junior right now, or like I finished my junior year, so I'm an incoming senior, but I have to take like an extra semester. Yeah, because I like switched into CS a little bit later, so like in order to finish my classes and all that, like I have to take an extra semester. So yeah, incoming senior technically though.
Okay, incoming senior. So for anyone who doesn't know where Missouri is, it's literally in the middle of the U.S. So what kind of like what's the leak code culture there or software culture out there in?
Yeah, yeah. So the school, I mean, in terms of the school I go to, I would say it's not very a big CS school. Like I kind of went there first to like pursue kind of medicine. So there's not too many people, I guess, like grinding and doing leak code and things like that. But yeah, just like obviously knowing that it's kind of required to get some of these jobs, just trying to do it.
Yeah. Um, what kind of companies are there? Are you aiming to stay in Missouri or are you gonna move out depending on where you get a job?
Yeah, no, I'm not like actually from Missouri. I just like go to school in Missouri. I'm
I see.
from Texas, but yeah, no, hopefully not trying to stay in Missouri long term.
So maybe you'll
Yeah.
go back to Texas or something.
Yeah, yeah, yeah. I mean, just honestly not Missouri.
Yeah. What about like Bay Area, San Francisco, or New York or whatever?
Yeah,
Any
yeah, I'll
other?
definitely say some of those like bigger spots, like yeah, like you said, like Bay Area, kind of New York, Chicago, those areas definitely have some decent kind of tech jobs. So yeah, those would be
Nice.
ideal.
Cool. All right. So we're gonna start you off with some questions. I'm gonna pick from my list. Let's see. Let me see how I'm feeling today. Okay, I got it. Let's see. All right, all right. So we're gonna try to get through a couple questions.
Okay.
Probably started off with something more simple, and then we'll ramp it up.
All right, cool.
So, what programming language do you like to code in for these
Yeah, no,
interviews?
I would say Python. Yeah, I don't really not the best at any of the other ones.
Okay, so we're gonna be given the root of a binary tree. We need to return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. And the length of a path is between two nodes represented by the number of edges between them. So hop in the drawing. I'll just quickly show you.
Where is it at? Okay. Yeah, I've never used Coder Pad before, so okay, I think I got it. Yeah. All right.
So we're gonna like the values don't really matter here, but so the diameter of this one I think is 2. Why? Because that's the
Okay.
diameter.
Like the farthest two nodes,
Yeah.
basically.
The diameter of this one of it now is 3.
Okay.
What about now?
Assuming it's 4.
2. Yeah, 4. Click one. Let's see. What about now?
I mean, are we assuming that it has to like run through, I guess, like the very root, or is it just like in general, like
Doesn't
the
have
farthest?
to. It doesn't have to run through the root.
Okay, yeah. So I'm in 1, 2, 3, 4, 5, 6, 7. Right. Should be like right here.
Yeah. Well, it's this
Okay.
one. Yeah. Okay.
Yeah, just like that tree right there.
Okay. Yeah. Let's stay in here. Like, how are you thinking of solving this question then? Swipe
Yeah.
over for a bit.
Let me see. So I mean, I know obviously it's like a tree problem, so I'm thinking kind of the 3 traversals, like the pre-order, in order, and post-order. And Yeah, so I don't think it's like anything about in order because it doesn't have to do with, I guess, like values and stuff. And usually in orders to get like in orders for like the BSTs and things like that. So looking at kind of pre-order and post-order. Yeah, I guess in order to like actually get the height of these trees, you need to kind of have information about like when it becomes a leaf technically, right? Like you would have to be like down here to know to start kind of counting up. So I think in terms of the information that you require, you need to like kind of traverse the like below it first. So I'm thinking kind of post order in that way. So I'm just gonna write that down. Post order because you kind of need information of I guess like children technically. So yeah, I think just like going through and then doing a post order traversal. So it's like the left, right, and then you kind of look at your node. And essentially, I guess we would have like a max value of some sort. So like value of some sort to track, I guess, the length of the left plus the right at any given node. So to track length of, here, let me get out of this drawing thing real quick. Yeah, so the length of the left and the right child node, length of left child node and the right child node. And yeah, just you would want to have the max at kind of every instance basically. So let me, okay, yeah, just looking at this example, I guess we would start obviously at the root, go down, just keep on basically going down to the left until we get to this very bottom node. I guess return 0 like right here. And then that's when we can kind of start tracking up and like I guess adding 1 to like to get the height, right? So at this point it would be 0, but then once we get up here, our left tree would be 1 here. So we would get the max of the left plus the right, and there's no right here. So that would be, yeah, just 1 there, and then it would go up again because obviously there's no right child. Go up to this node, look at the left, and now since the left will be 2, will return 2. You're gonna go right, and there's nothing there. So then I guess the max value switches to 2. Kind of go up here again, and now the left is at 3, right? But then now this one has kind of a right kind of child. So we have to first explore the right child before we can assess kind of the current node. So just going down right, this would check the left, nothing there, and then this would go down, kind of down and down. But I mean, but yeah, basically it would
post order,
go
right?
down. I don't know if you want me to, yeah, post order.
Okay, I think you're gonna do a post order. You're passing back like the current length. I think you're going to the right approach. Let's just go ahead and implement it, and we'll just work out the kinks if there are any.
Okay, cool. Yeah, so we'll just do, so just create a quick function here. I assume we're given some sort of a root. I'm gonna like define the node, or is that, can I just assume it's?
You could assume it's there for now.
Okay. Yeah, so find diameter. We have to have like some max value, of course. We can start that out at 0. We can do, okay, max value at 0. I think obviously we have to create like a post order DFS. Just have like a current node inside. I guess honestly we can nest this inside here actually.
Sure.
Yeah, post order DFS, and just assuming that logic works out, just because I want to kind of yeah, map it out. Obviously call that DFS function on the root and then return the max value. Yeah, just to kind of lay out the skeleton. And then in terms of, I guess, starting the implementation, we got to first check if it's the node is there or not, right? For the base case. So if you would return 0, and then we want to check the left and the right before we do anything. So yeah, we would have to recursively call the left side on the left child, and then kind of the right on the right child. Once we have this, this basically means that we have already looked at the left height and the right height. So we would just kind of, I guess, get a current diameter. Would be left plus right, I believe. And we would want to, let me see. Yeah, since this max value, I think we have to pass it in as like a global. I think just, I guess to make it easier, I'll make it an array so that we can access it inside as well. So we'll do max value here. And then now, yeah, now we have to do the logic of actually returning. Let me think about this. Yeah, obviously we have to return 1 plus to give height. And then I don't think we would have to return both the left and the right every time. Yeah, we would always want to return the max, I believe, from each node. So I think something like this would potentially suffice. Left equals post order. Return 0. Current diameter. I'm gonna just look at my drawing board real quick. Just yeah, I think this is somewhat reasonable. Are you able to kind of follow through, or anything you kind of want me to explain?
Oh, sorry, I was muted. Can you run it through a test case?
Yeah. So I have to like define a class then, right? To like make the nodes. Okay, I'll quickly make, how do you do this? Yeah, I think. I guess val, and then technically you don't need to do that. Okay, so equals 0. None. Okay. Should be fine, I think. I don't know why I did 0 there actually. Okay. Just make a couple nodes. Now I have to like make the actual tree, so we'll do
one plus max of left or right?
node. Node 0 dot right to node 3. So I'm expecting this would be node left 1, 2. So yeah, I think the diameter should be 3 for this thing. Node 2. Yeah. Okay. Yeah, let me just kind of pass it in to see what happens. Find diameter. Just pass in. How do I run this thing? Oh, it just says run.
Yeah.
Yeah, so it says 3, so that's what we expect. I don't know if I want to make it a more complicated test case. Let me just try something else. Like, would there be like a certain edge case you would want me to test, or?
I think it looks good. Let's move on to the next question.
Okay, does this look fine?
Yeah, that looks fine.
Okay.
Let me come up with another question. So this is gonna be a networking question. We have
Okay.
or it's like it's still regular coding, but assume we have a network of n nodes
Yeah.
labeled from 1 to n, and we're also gonna be given times, which is a list of travel times between two nodes, UI VI, where UI
Okay.
is the source node, VI is the target node, and W is the time it takes for it to travel from between those two nodes, right?
Yeah.
So it's gonna look like this. I'm gonna hop in the drawing board.
Okay.
So we're essentially going to be given a bunch of nodes like this, like 1, 2. Like these are the different nodes, and they're gonna be connected. Yep. They're gonna be unidirectional, not bidirectional. Like this. So we're gonna be given something like this, and we're also going to be given the weight of each one. Right?
Okay.
So, and then we're gonna be given some sort of k, right? Equals 2. So when we say k equals 2, we need to understand. We need to return the minimum time it will take for all of the nodes to receive the signal. If we start at this node, we're given the source essentially. So for this one, the time it's going to take is 2 to get to all the nodes. Why? Because it takes 1 after the first iteration. It's going to take 1 to get here, and then this. So basically, this is the last node to get hit, and that's going to be hit at time t. Pretend we had something like this, right? We had 1, and this was actually 5. Maybe it takes 5 seconds to travel this one. What's the answer?
The shortest time, so it'd probably be 1, 2. Obviously, you don't want to take that 5 route. So you do. It'd be 1, 2, 3.
For all of them to get after time t, pretend we just send the signal broadcasted. So after time t, this one is reached and this one is reached. At time 2, this one gets reached, right? So it's just 2. The result is 2.
1. Oh yeah. Okay, you can do it at the same time.
Yeah, same time, just broadcast it. We just need to understand the minimum time it takes for all the nodes to receive the signal. So pretend there's another node right here, 6.
Yeah.
And this is a 1. It's like a 7. This is a 1. how long does it take for, if we start at 2, how long does it take for all the nodes in this graph to receive the signal?
I'm assuming it would be 6, right?
Why 6?
Because I mean, obviously, when 2, 1 to 4 is just that's 2 time, and then to hit 6 and 7, it's just 1, 1. But then there's a 5 right there, right? So hitting that path to the 4 is going to be slower than just going from 2 to 3 to 4. So it's basically like the longest path, yeah, where you're able to like effectively hit the nodes sooner, right? So would that make sense? Is it 6?
Well, what we're trying to do is figure out the minimum time for all nodes to receive the signal. So it's not 6 because 4 you can actually get there in 2 seconds, right?
Oh yeah, you don't even have to. Okay, yeah, that's my bad. Okay, yeah, it'd be 1, 2, 1, 1, 2. Yeah, it would just be 2, right?
Yeah. Okay. What are your thoughts on the question and like
Okay.
your initial thoughts?
Yeah. Well, I'm thinking, I know this is obviously some type of graph problem, right? I know with like regular shortest path problems, you just can use regular BFS, but like since there's weights associated with certain paths, like it's more advantageous to go about it in a different way. As shown in this problem, like going from 2 to 1 to 4 is a lot kind of less time than 2 to 3 to 4 or 2 to 6 to 7 to 4. So yeah, probably doing some sort of Dijkstra's, I think, is what the algorithm is called, where you is how you can get the shortest path associated with weights, I believe. Is there going to be negative weights? Because I think with Dijkstra's, negative weights can't occur, right? There's not going to be any negative
Yeah,
times.
no negative weights.
Okay. Yeah, so I mean, I've done a Dijkstra's problem before, honestly, but I kind of okay. Yeah, so I think the way that we can go about it is obviously, so K is our starting point, right?
Yeah.
We'll send the signal. Okay. Yeah, so since that's our starting point, I mean, first thing that we need to do is we need to build like some type of adjacency list. So it says, I believe it gives us a list of travel times from source to node. And then
I'll
also
show you
kind
what
of
the
the
input
time.
looks like.
Yeah, that would probably make it a little easier.
So we're gonna be given a list of lists like this.
Okay.
N just tells us how many nodes are in the graph. It's like,
Okay.
You could use it if you want to, but we're saying from 2 to 1, there's a weight of 1. From 2 to 3, nodes 2 to 3, there's a weight of 1. From 3 to 4, there's a weight of 1.
Okay. Yeah, so I think you would have to build, I think first things first would be to build an adjacency list. Let me think about how I'd do that. Okay. And this is like all directed paths, right? Like you can't go both ways.
Yeah, you can't go both ways.
Yeah, so I think you would need an adjacency list as well as something to kind of quickly reference like the time, like another map of some sort, I think. So I guess what I'm thinking initially would be a regular kind of adjacency list where it would be a mapping like to like a list, because you could have kind of several ways to go. But then also have kind of another map where the key value can be that path, right? So it could be like a tuple of 2 to 1, and that's going to be equal to 1. And that will allow us to kind of get the weight like instantly, right, with the O of 1 lookup. So let me just kind of set this up to see what that would look like. Okay. Let me add 3 to 4. Okay, I think this could be a good starting point.
Okay, if we had this 2 to 1 to 3. Okay, we're saying neighbors. 2 has neighbors 1 and 3.
Yeah.
2 to 1. I mean, why not just store it here, like the distance inside the
Oh
JSON,
yeah, we could do that as well.
just to make things simpler. Don't have to do 2
Okay.
lookups.
Yeah, we could do 1 1 3 1. Yeah. Okay, so it would map. This is mapping node to a tuple of the neighbor node, and then the weight to get there. Okay, so that would be a decent start. And also, I believe we need a priority queue of some sort, as we want to prioritize kind of the lowest amount of times, or I guess we want to prioritize the ones that are lower time. So let me see. Yeah, just give me a second to think about it. Yeah, so. I guess you'd also need to like find some way to track like which nodes you've already seen, right? So that you know when you'll be done. So I guess a way to track when you've seen nodes. So we can do maybe like a visited set of some sort. And then maybe when the length of the visited set equals n, we could terminate and just return the longest value we've seen. And yeah, I guess going back to this priority queue, right? We have to use it to kind of prioritize lower, like lower values or like lower time tables. And I think in terms of what we want to put inside there, I think we'd have to have like a total time or like a current time. I guess a current node that you're on. Current time, current node. Let me think. Yeah, I think current time, current node. Then I guess, yeah, I guess we could traverse its neighbors using the map. Traverse the neighbors using the map. And then I guess update update the current time plus what the associated weight would be, and then write like the neighbor node, for example, and then put that and put it back in PQ. We would also want to, I guess, track that we had already visited it. So I guess add to our visited set too. I guess that we'd want to have a check here where it can be like if, like the thing I was talking about earlier, but like if the length of the visited equals n, we would terminate and just return, I guess, the max time we've seen. Okay, so max time variable. Yeah, and then in terms of like setup at the beginning, we would add obviously our starting node to the visited set, and then put in the neighbors into our PQ to start it off. Does that sound reasonable, or if I'm being completely honest, I'm kind of winging it here, but.
So we start at node K. We put the starting node in the visit set. We put the neighbors into PQ. We have a priority queue with the current time. Yeah. Oh, you delete.
Let me just put that like bottom just to. Sorry.
If the length equals visited, return. Looks good. Go ahead and implement that and let's test it out.
Okay. Yeah. Does it sound reasonable?
Sounds reasonable. I think go in the right direction. It's all about implementation at this point.
Okay. Cool. Given a network. Okay. So I'll just say, I don't know, network problem. And then what are the inputs we're given again? So we have the times n and then k. So. Okay. Yeah, so to start, we'll say our max time will equal 0. Kind of initialize everything. Visited equals set. I think we have to import. Actually, I don't know if it's from, I think it's just import. Yeah. So yeah, we have our visited set. Max time. Let me see if there's anything else. Okay, yeah, I think we just get started with building the adjacency list. So yeah, again, we're doing kind of mapping our node to the things we're doing for source. Was it source, target, and weight? Okay, source, weight, and times. We have to first make a map, so let me do that. I want to use the default dict library, so I guess node to neighbor, something like that. So the node to neighbor, and we'll put source dot append target and then weight. I think that is honestly fine for what we're doing. And then now setting up the PQ, we want to add what K is. And then, yeah, honestly, I think with the setup thing too, honestly, we could just put K and then we could start the current time at 0. I think that would be fine too. So I'm just gonna create a quick priority queue. So PQ equals that. Heap Q dot heap push. into our PQ, and then we want to put the time first. So time and then K. So we'll say while PQ, we'll pop off the node like we decided. So our current time and current node equals something like that. If length of visited equals n, we can return max time. I'm thinking, I mean, we could update max time here or later. I'm just gonna put it right here though for now. And then now we want to kind of look into the neighbors. Actually, this part. So let me think. Yeah, now we want to traverse the neighbors. So looking back at what our map is like, we'll do for neighbor node and wait in node to neighbor current node. Neighbor node wait in node to neighbor current node. Yeah, now we want to push the values in back into our priority queue. So we'll do heap push. Obviously, we'll do current time plus wait, and then push in the new node. And then obviously we want to update our visited here, or I guess we could do that up there as well. I don't think it would. I believe it wouldn't matter. Since I'm gonna do it here, I'll do it here.
Visited dot add neighbor node.
Yeah. Because this is like when, the first time that we see our neighbor node. Yeah. And then we're also kind of maxing out the time, right? Because if we took the certain path with the wait, we would have to max that out with kind of the time, because that's how much time it took to actually get to that neighboring node. And yeah, I think if you don't get here in the end, that means you weren't able to complete it. So I don't know if it is impossible for all end nodes, I guess return -1 here. Just look. Current time, current node. Just make sure that I'm not leaving anything out here. Yeah, I mean, I think that's my implementation. I might be missing some things, but maybe I can try to test it with some things we have.
Yeah, let's test it on the example that I gave, right?
Okay. Yeah, I mean, I'll just copy this stuff. Boom.
Or I'll just post it here.
Okay. Yeah, so I'll just do print network problem. Honestly, just copy and paste this in. Four and then 2, I think is the way I have it set up. Was that what it was supposed to be?
Yeah. Let me just run the code. I mean, it looks solid.
Does it look okay? Okay. Yeah, no, I haven't implemented extras in maybe, I don't know, like 5 months, I think. So that wasn't the smoothest, but.
See if it passes the test cases. my timeout.
Okay, yours timed out.
Let's see.
Okay, yeah, let me think about
Oh, it's giving the wrong answer. Yeah.
wrong answer.
I think I see why. Walk me through line by line. Like actually reference the code. Let's just make sure it's all working.
Okay, yeah. So we'll start, I guess, with this
Start from
example.
max time right here. Or just walk me through. We don't have to go through examples. Just walk me through.
Oh,
what
okay,
each
just walk you
line
through the
is
code. All
doing.
right. Yeah, so we just start with max time equals 0, just initializing the things. First thing is building the adjacency
Don't
list.
skip over
so-
lines. Get every single line in here.
Oh, okay, yeah. Okay, so start with the max time equals 0. And then visited is just a set so we can track what nodes we've already seen.
Mhm.
Because the idea of it is that the first time we've seen kind of all the nodes, we want to just return right away, right?
Mhm.
We don't want to take kind of those alternative paths that aren't as advantageous, for example. And then the node to neighbor is just kind of initializing the list from the source node to the target node and the weight. PQ is obviously just going to be our priority queue. So we're building this adjacency list. We're just setting kind of source and mapping it to our target and weight. And then just setting up the PQ would be, obviously, since we're starting at K, like our time there would be 0. So we're just pushing in 0 and then the starting K node into our priority queue.
Okay.
And then kind of going into the Dijkstra's part of it. We do while PQ, and then just kind of popping it off, the first thing. If we do see, or if the amount of nodes that are in our visited is equal to the total amount of nodes, that means we saw everything, right? So we just want to return kind of the max time that we saw. For this, it would be looking at kind of the neighbors and then just kind of heap queue, heap push. We would want to do the current time plus weight. And then our neighbor node, obviously adding what we need to add into our visited, because that's what we're using to track if we've seen everything, and then updating the max time. I guess another thing would be is, I guess if it's already in our visited, then we don't have to go to it anymore. Like we could just, wait, actually. Yeah, were you able to follow that though?
Yeah, I'm following. There's a slight bug into it, and it's related to like, how you're managing visited. I think
How managing what?
visited.
Oh, visited. Okay.
So, like, why are we just pushing to visit right away? And, like, when do we ever look at visited?
Yeah, wait, so the reason I put visited here is because
I mean, did we really visit it?
I think technically we did, right? Because the way that I maxed the timeout, I add our current time with the weight. So assuming that we got there.
Okay, let's hop into this right here.
Okay.
Come.
Yeah, I'm in here. Hold up.
So.
Yeah.
Pretend we are at 2. We pop. We go here. Visited. We visit this one.
Yeah.
What if it pops this one first, and then this one, and then next? Like, you know what I mean? We start with 2, and it goes.
Yeah.
It goes left and right, or since it goes 2, and then it goes. Yeah, essentially, we visit this one, and then we process this node before we process this node. So it would have pushed 4 with 5 there.
Oh, yeah. So we'd have to process it after, because we don't want to. I think this is probably. Yeah, because it could, until we actually get there, we wouldn't want to just like pre-process that because it could be really bad, like at 3, for example, because both of them are at 1. Yeah. So I'm gonna do just current time here. That means that should just add on its own, and we'll add current node. So yeah, I think something like that would make a little bit more sense, because that way we're actually letting the priority queue do its work in terms of actually giving us what the smallest time or the lowest time it takes to get to that node instead of immediately just taking it the first time we see it.
Mm-hmm.
Yeah. Okay. I should have thought of that, honestly. I was thinking of those are the two areas that it could be. But I just didn't think that through.
Let's see if it runs. For some reason it's slow. I think its time limit exceeded. I think you're not managing the visited, or you're pushing too many nodes into the stack at this point.
Yeah, I mean, I guess we could do something here. Like if the neighbor node is already is not invisited, we should put it in. That way, if we've already seen something that's smaller, there's no point in adding it, basically.
Exactly.
Like if we've already seen the node, right? So I think adding that should definitely help with the complexity because we wouldn't be adding in nodes that we already have tracked.
Exactly. Boom! It's working.
Okay, is that good?
Good job, man. Honestly, really good job. How was that experience? What do you think?
Yeah, I mean, I'm not gonna lie with the graph one, the diameter one, I had seen that one before, so I kind of remember that one if I'm being honest. But with the network one, yeah, I don't know if I've seen something like this, but I do remember doing a Dijkstra's problem one time, so I knew that I had to use like a priority queue of some sort. I know it's like similar to BFS. So yeah, I mean, I guess the biggest thing for me is like being able to explain my code very well in terms of also running through some of the examples because I feel like I wasn't able to fully explain like that even the diameter question really too well. And also like I feel like with this one, there could have been areas where I could have explained it better. So I guess that's definitely something.
Yeah. Honestly, good job. I think people in the chat really thought you were good as well. I thought you were good.
Appreciate that.
Variable names were good. You figured out its Dijkstra's. Implementation is good. You just messed up with the visiting part. I think
Yeah.
with these Dijkstra's, that's the part where people trip up the most. So just make sure you're understanding, or with anything related to queues or DFS, BFS, or I notice when people don't know how to manage the visited stat or they mess that part up, it really messes up their thing. So
Yeah.
that's the part I'm always super like watching really closely is how are they managing the visited because you see like we just shifted the visited a little bit and fixed the solution.
Yeah, yeah.
Otherwise, the whole thing
Yeah,
is just
for
boilerplate.
Dijkstra's it is super important. Yeah.
Yeah.
Okay. All right, I'll keep that in mind for sure.
But honestly, really good job. That's one of the best interviews on the channel. Not gonna lie, but
Okay,
yeah,
nice,
you did a
nice.
good
Yeah.
job, man.
Thank
Cool.
you, thank
Thanks
you.
for hopping on. Good luck on all your interviews. Keep me updated if you get anything. I'm pretty sure.
Yeah,
you
yeah,
will.
for sure.
All right.
For sure. Thank you for kind of providing this opportunity.
No problem, man. Catch you.
All right. Have a good one. Bye-bye.
Yeah. That guy's good. I don't count Alpha in it because that guy did so much questions. So when I'm saying this is one of the best interviews, is of everyone minus Alpha. Alpha's too cracked at LeetCode. Okay, I'm gonna eat something real quick. Let's see. Let's see this. It's true, bro. Not glazing. Yo, is he in the thing? I don't know. He said 200 earlier. Let me see. Okay, we got somebody coming up in 5 minutes. I'm gonna literally eat my food before he comes on. Yo, who watches NHL? Is it NHL game on today? Yo, let's go Edmonton for NHL. NBA Finals is crazy too. NBA Finals is crazy. I was tweaking out watching that game yesterday. Okay, I'm gonna quickly grab my food. And let me just show you. Hello everyone. So today I'll be unveiling the Peralta 75 list. And let me just show you this cool animation. I wanna get feedback on this stuff right now. This is why I'm playing this real quick. What's everyone's thoughts on the Peralta 75 list so far? Or this animation that I spent a couple hours working on. I'm gonna grab my food, give me a sec. Check that out. So the Peralta 75. After solving 650 LeetCode problems, reaching the top 0.5% of LeetCode users worldwide, and landing offers at Meta, Amazon, Bloomberg, and various Silicon Valley startups, I've decided to curate a list of questions that were pivotal in my algorithmic journey. No gotchas, no obscure tricks, just pure practical problems that will transform the way that you think about coding and prepare you for any technical interview. This is the promise of the Peralta 75, and I'll show you how I came up and curated this list, and we'll just do a quick walkthrough, and I will tell you why this list is a great list. So yeah, I built this page. You can access it at jamesperalta.com/Peralta75, and you'll have access to the Peralta 75 list. So how I actually came up with this list was I went on LeetCode. You can see I've solved 650 problems. I've solved problems on other accounts and other platforms. That's why I said 650 plus algorithmic questions. And you can see that solving this many questions puts you in the top 99.6% of LeetCode users. So this is based on problem solved. People might go on my account and be like, oh, you didn't do contests and things like that. I'm just saying 0.5% of, I'm the top 0.5% of LeetCode users based on what LeetCode is saying right there. I mean, how many LeetCode questions I've done or how long? Honestly, I didn't spam it all at once. I've been doing LeetCode for the last 5 years, on and off. I only did it every time I had to do a job hunt, and every time I had to do a job hunt, I did 200 to 300 questions. So before I got my first job, I did 300 questions. Then I did 200 for my next job hunt, and I did like 150 more with this YouTube channel. So I don't just spam it all in one go. Keep asking questions. I'll take a bunch of questions right now. Just grabbing my food real quick. Grinding sophomore? Which year is sophomore? I don't speak in like these. I just go first year, second year, third year kind of stuff. Second year? Yeah, get just what's it called? I mean, it's good to get the basics down, you know what I mean? You don't have to spam all the hard ones, but 300 is solid if you did the right questions. Let me tell the next guy I'm going to be late by 5 minutes eating. Was what worth it? Yeah, in my coding journey, I've solved 180 easy, mostly mediums, 57 hards. And how I actually came up with this list is a very tedious process. Selling my soul to LeetCode. Was it worth it doing 650 LeetCode questions? Is that your question? Dude, to get to 600, I could do, was it worth it? Yeah. I didn't do 5 years of LeetCoding. You could see, I'll show you my graph right here. So the first question I did was in 2019. Then 2020 right here. You can see I just spammed it at 2020. So in 3 months, in just those 4 months, and then this whole period, I didn't do LeetCode. 2022, I didn't do LeetCode. 2023, I didn't do LeetCode. So I was literally chilling those years, working. I did LeetCode a little bit right here, a little bit of LeetCode there. It's like, what is it, 2024? And then like, I just been doing LeetCode spamming here, but like I wasn't just 650 questions. I didn't do it all in one go. I only did it when I had to do interviews. So, and honestly, it's worth it if you're able to get a good job that pays well. We have someone up next. Let me just finish my food. Tourists on Code Forces. 1 sec. But I literally spent between 5 to 8 hours in one go, starting from the very first LeetCode question that I ever solved all the way to the most recent ones. So you can see that I started back in 2020. It's been over 5 years since I've been doing LeetCode, and the LeetCoding industry or the LeetCoding questions have totally changed. When I started doing LeetCode in 2020, the Blind 75 list was already out and it's still there. And don't get me wrong, the Blind 75 list is still good, but this new list is an updated version. People aren't asking those Blind 75 questions anymore. Honestly, some of them are too easy and been asked way too many times. I rarely get asked questions directly on the Blind 75 list. So all of these interview questions that I have here are interview questions that I personally have been asked. I've interviewed in a ton of different companies. I probably did over 10, maybe over 15 on-sites just myself. I've probably done over 30 coding interviews plus where someone's asking me a question. So these are all questions that I think that I've been asked. I've also been on the other side asking people, conducting interviews. I've done 100 of those, not just on YouTube, but also in my different jobs. I've done so many different coding interviews, and these are all the questions that I think are actual questions that you will be asked based on conversations with my friends, based on what I've been asked, based on what I've had to ask people, based on this big community that we built and the Discord channel where people are posting questions that they've been asked. These are real questions, and I think that's why I decided to compile them. And how I built it was literally going from the very first question that I did all the way down and picking off all of the really good questions. I tried to avoid questions that had weird tricks in order to solve it, and then the question just ended up being 2 lines of code. All of these questions are legit questions, and there's no weird tricks to solving them. I think a lot of these questions really show off how good you are at data structures and algorithms, and I would make hiring decisions based on the success of a candidate solving these questions. House tour. What's up? What's up?
What's up? Welcome to the house. Welcome to the
James Peralta, John CFA, and we're gonna take you around the Peralta family ancestral house. This is our this is our childhood home.
Yeah, pretty much.
So what are the specs on it, John?
What's the
CFA?
spec on it?
How many square feet?
Probably like 1,600 square feet. We're just guessing.
Like a bunch of bedrooms, a bunch of bathrooms, but we're gonna take
Yeah.
We're gonna take you to a few things in this tour. We're gonna take you to obviously the different parts of the house. Then we're gonna show you our wall of fame. We're gonna show you the coveted CFA. It's hung down in our basement.
Oh man.
And then just the different setups. Like John will show you his setup where he's streaming. I'll show my setup where I'm streaming. So come through.
Yeah. Oh, you could actually see like what we used to look like back in the day. I don't know if people could see that. Jose's in that too. Jose's in that too. We're gonna get him. We're gonna get him in the video. He's just not in Calgary right now.
So this right here is the couches. Almost done eating. Almost done eating.
Yeah, we kind of just visit here and then leave.
This is our kitchen. This is where
We used to drink, take shots.
run some parties, have people standing up on here. Dishwasher. What else? Air fryer.
Yeah, that's the essentials.
I don't know.
Pressure cooker.
Honestly, we didn't really cook
Pressure
too much.
cooker. There's some Filipino food in here. This is what makes you good at LeetCode. I don't know. That's the pre
That's
the
it,
pre
yeah.
the pre meal before LeetCode.
Every time I'm about to hop in an interview, go LeetCode beast mode, I eat the Filipino food. Yeah, and this right here is this is John's setup right here. You can see he's running some fast API, johnperalta.com is back up and running. Like we have the different stuff. johnperalta.com is live. Different setup. He does LeetCode on one screen, has the answer on the other screen.
Even for twosome, I can't remember what a hash map is.
Alright, this is our wall of fame. This is everybody in this house. Every Peralta in the house has a college degree. Like, they didn't even give us our last name until we got the degree. Like, I just earned it a few years ago.
Check this guy's though. This guy's got the most stacked one though.
So
This guy.
this is mine.
Look at computer science.
Hey,
It's your
somebody's
first
gonna
class.
clone this thing.
How? What? That is a clone. It's not even real.
Yo,
That's not even the real one.
I
The
keep-
real one has to be in
I-
the U.S. for
I
visa
keep
purposes.
the real one in the U.S. But this is John's business degree. My brother and my dad has a Magnum. I'll answer that in 30 seconds. Just finishing eating this real quick. 30 seconds. Where are you based though? Degree too, and
Yeah,
my mom has a degree.
I
Everybody
don't
in this house
I don't
has a
know what
degree.
the degree is.
This
What
is
is
like a
that?
Filipino degree. My mom didn't want to put this up on the wall because she's like, it's not even from North America. And then my dad forced that on the wall. Alright.
Okay.
How long is the video so far?
Dude,
4 minutes? This is the TV. We just chill here, we eat. We can watch TV.
yeah, that TV's from like 2008.
Yeah.
Got some chips.
Some chips. Regular. This is Canadian. These are Canadian. Woo! That food was amazing. So what's the expectation for IC level coding rounds? I think expectation is get your code working. Make sure you capture all the edge cases. Prioritize actually getting to the optimal solution. Yeah, they're pretty much just gonna test that you get to the optimal solution. Usually they make you dry run the code line by line because you're not allowed to actually you're not allowed to, like, the code's not runnable. So they make you run it line by line. It's very the way I run all my interviews, you'll see, and I'll run them right after this. Is you're gonna see that's pretty much the experience, honestly. Get working code, be able to dry run your code. Dry run as in you be the compiler, walk it line by line, try to get to the optimal algorithm, be a fast coder, because they want you to solve 2 questions in the span of 45 minutes. That's my advice. Popping in though. Yo, what's up?
Yeah, what's good, bro?
How you doing?
Yeah, hang on, let me mute this
Yeah.
the YouTube thing. Yeah, I can hear you properly now because there was an echo on my
What's
side.
up? Are you from the UK?
Nah, bro, it's Nigerian, but I live up in Canada.
Oh, that's sick. That's sick.
Yeah.
Yeah, we'll do some intros real quick.
Or
Just make sure the chats understand. But you live in Ontario, right?
correct, yeah, I do, yeah.
Nice.
Actually, I've been up here for a while, to be fair.
When did you move from Nigeria?
2014, I think. Yeah, it was 2014. Yeah,
Damn, you've been
I
here for a
moved up.
minute.
Yeah, I've been here. No, but the thing is, I was in BC for a while. Then I
I
moved up
see.
to Ontario. Yeah.
Is there a lot of Nigerians in Ontario?
Yeah, it's actually there's a bunch of us actually. There's a bunch.
That's sick.
There's a lot actually, not even a bunch. There's yeah, a lot.
Yeah, I have a lot of Nigerian friends too, especially in Calgary, Alberta. There's a lot.
Nice. A good friend of mine moved here actually last year. Or
Nice.
2 years ago, I think. Actually, no, I'm tweaking. It was last year.
Who's your
Yeah,
favorite Nigerian artist?
But I got a bunch, man. I enjoy it. I just enjoy the music. I wouldn't say I have a favorite. I just enjoy music. Like the top three, Burna, Wizkid, Davido, love those guys. Then there's like low key guys too, that I enjoy.
Mm-hmm.
But it's just, to be fair, it's just like I just enjoy all of them, man. I wouldn't say I have a favorite.
Like, what's your favorite genre of music?
Right. So like the thing is, I've been into what's the word, like old school rap,
I see.
like for a minute actually. So like the Biggie, like the Tupac, Wu-Tang Clan, the
Big L?
what's
You
this
listen
guy's
to Big
name?
L?
Yeah, Big L, yeah. So essentially, I've just been on old school for a minute, maybe like a
Yeah.
month and some change. But like essentially, I would say like Afro beats, hip hop. I like a bit of R&B every now and then.
Yeah,
But
I
yeah,
see.
that's essentially what I'd say. Them two, to be fair.
Same for me. Like, I had my back in the days. I was big into old school hip hop too. Like, same
Right,
people you're
right.
talking about, like Nas, Big L, like way back.
Right.
And then, really, I only listened to that until like Drake and them started coming out. And I was like,
Right.
Drake was like the first artist of this new generation where I was like, okay, he actually slaps.
Right.
Especially like
Yeah,
Nothing
no.
Was the Same and stuff. Do you like
Right,
Drake
yeah,
or
no.
no?
Yeah, no, I enjoy his music, man. Like for me, like I don't really have like a favorite guy. It's just my taste is just everywhere. But I wouldn't say I like country though. That's the one I can't stand. It ain't really my thing. I've tried, I've tried getting into it, but I don't know. It's just not my thing. But everything else is, I'm cool with everything else.
What about for like house music and EDM and stuff? Do you mess with that or not really?
It's not in my playlist. Like it depends, it depends on the function. It's usually like a function where I'm at. Like
Yeah.
they be playing that, I just bump my head at least. But
Yeah.
like personally, nah, that's not in my playlist. I'll tell you for one.
Nice.
I in my playlist for one. But it's cool though. But it's not in my playlist.
Sick. Alright, I'm gonna start up a
Yeah.
video. We could talk about the algos and stuff.
Right.
Start up 3, 2, 1. Hey everyone, so today I have somebody from Ontario and he's gonna hop in and do a coding interview. You wanna give a quick background on yourself, maybe what school you go to or how many LeetCode questions you solve, and then what companies you're targeting?
Right. So like I've essentially done about like I'd say maybe 198 over like 4 years, I guess, because I started 2022. but then like I only started taking it serious, or like I've been on the grind for like say 3 weeks. Actually no, maybe like in May, which is I don't remember the week. Actually, let me look at this. Once maybe like actually no, the first week of May, where I started grinding. So I've been on the grind for a bit actually, but apart from that, I've just been on and off. As far as like working, I currently work for myself, so like that's like building apps and stuff. But like I'm
Nice.
actually targeting like companies and stuff. Like I don't really have a preference. I'm just applying on wherever
Yeah.
like I go to and stuff. Because I just
You
graduated last year, right? So
okay? Nice, nice.
right, so
Um,
yeah,
so you're just targeting anywhere from startups to large
yeah,
companies, whatever.
yeah. Essentially, yeah. I
Are
don't really
you
have a
are you
preference.
targeting sort of Canada, U.S., wherever?
No, so it's strictly Canada, right?
Yeah.
As far as like my application is strictly Canada.
Is it just preference kind of thing? Like you don't really want to work in the U.S., you want to stick to Canada. Maybe like you don't have a visa yet or something like that.
Yeah, so with the US, I have to get like a visa and stuff, which is just shit. That's just long, man. Yo, that's
Yeah.
just long. So I
Are you a
just
citizen already there in Canada?
no, no, no,
Okay.
not yet. No, no, not yet. No.
Yeah, that's what makes it hard. Otherwise, you could just get the TN, right?
Right, yeah. So essentially just strictly Canada and stuff. So and now that I'm looking at my LeetCode thing, so I've essentially done just 198 questions, right? So yeah.
198 questions. How many easies, mediums, hards?
So easy, I've done 113, mediums 85, and hard. I never do hearts.
Careful.
Yeah, I never do hearts because I just think it's OD, right? Like,
Yeah.
what are the chances that you get asked that?
Yeah.
At least for my, as far as my thinking, I think it's usually like guys that do like competitive programming. Maybe they do the hearts. Oh, you're just cracked,
Yeah, I haven't
right?
done that many hards, honestly. Okay, with
Right.
arrays, how good are you with arrays? Give yourself a rating
Yeah,
or
I'm good. Like so, like with respect to any questions, I'm good because the past 3 weeks I've been on it, if not close to a month, right? So I've been on it. So like I'm good for whatever.
all right, let's get it.
Yeah.
I'm gonna send in.
All right.
I sent you the coder pad, so just hop in and just,
Yeah, so I'm just gonna join. Just give me a second here. So I'm just gonna get started. All right, I think I'm in. I don't know if you can see my thing.
yeah.
I think I am
I
in.
see.
Yeah.
Okay, sick. All right. First question. We're gonna. What Python or what language do you like to use for the coding
Java.
interviews?
Java.
Java. Okay.
Yeah, I use Java. Yeah. Oh, 20. Okay, nice, nice.
Oh shoot. Let me just reset the tab. All right. This is the first question. I'm gonna post it right here.
Okay.
So we're gonna be given an array of strings. We need to group the anagrams together. So you know what an
Right.
anagram is?
Yeah, so it's essentially characters, or like say a string, comparing two strings, like the amount of characters in both of them equal each other, essentially.
Yeah, like the
Right?
frequency of each character.
Yeah, yeah, the count. Yeah, essentially, yeah, correct.
So
Um,
yeah, we just need to group these up. So you see bat, you see nat and
right,
tan are in the same group because they have the same characters. So
right, yeah,
does
I see that.
this one. So this is the first challenge.
Right,
Yeah, I'll
right.
let you take a
Okay.
vote.
So like just cause actually, so off the top of my head, I'm thinking we could just we'll need to iterate strings. I'm just gonna call it array, right? And then for each character, we want to basically, or rather, not even each character. For each string in the array, we want to sort the string and then store that in a map where the key is essentially a sorted string, and then the value is an array of characters, right? Because like I'm pretty sure the question says, oh right, so the question says you can return the answer in no order, so in any order, so like it doesn't really matter. Does that make sense?
Mm.
So like like the flow of things is I'll just say actually I'm gonna describe this algorithm. So like we want to iterate. So iterate the array, right? So for every iteration or for every string in the array, we want to sort. Say for every string in the array, sort and append to a map, right? Now, the trick to this map is the map is going to hold, or the keys of the map is going to essentially be a sorted string, right? And then the value are the strings in array. Does that make sense?
Mm-hmm.
So that's essentially the flow of things. And then could you say the map holds? Let's just say the map is essentially going to be say value. Oh no, actually no. The key would be sorted string in array, and then say the value. It'd be an array or list array of string in AR. Oh no, even the strings in AR. Does that make sense?
Yeah.
All right, cool. I'll just go ahead and implement this. So so I'm assuming. What do you want me to return? A list
A list of lists.
or an array? All right. Okay. Cool. So I'll just make this. Doesn't really matter if it's public. So I'll just say a string, and then what do we want to call this? Give me a name because that naming is hard. Let's say it's SOL, and then just go and give us final string.
Say result or something.
Right. Yeah. So let's call this the solution array. Call this result since you gave me a name. Right. So what do you want to do now? So we need the solution. Since we're using Java 20, I'll just use the new API. Right. So which is I'm going to call this results, and then new array list. Actually, no, I don't want to do that. Just give me a second here. Instead of naming this a var, I'm going to make this still some code here. So what do I want to do now? Wait, why is this complaining? What the hell? Yes, weird. Turn the results. And then what do I want to do? So I essentially want to, we also need a map, right? So I'm just going to use the map, new hash map, with string, and then a list of string. Right. So what do I want to do here? So I just want to iterate for the array, call it S array. You know, let's just call this, make this clearer. So now that I am iterating this array or strings, right? So what do I want to do? I want to basically sort the current string we're looking at. So I'm just going to say var c equal to s.2 char array, right? I'm going to sort it. Probably not going to be very efficient, but it is what it is in this case. And then what do I want to do? So I want to basically append set value into the map if it exists. So I want to say map the compute if absent. I'm going to say new string s. So if this function exists, I think this takes in a function, but right. Actually, can I do this? Actually, no, I can't do that. But I think it takes in a function, but just keep carrying. Actually, let me just make sure you're following along. You understand the algorithm I'm implementing, correct?
Yeah. Makes sense.
Okay, cool. Right. So essentially the flow of things, I'm going to reiterate the solution again, right?
Sure. Go ahead.
Actually, no, I'm missing one last step. to iterate the values in the map. So I'm say map dot call this m. Actually, I'll call this val, and then the map dot values, right? And then I just want to do results dot add val, right? So the flow of things. Why is this complaining keyword for? Maybe this is not new. I'm just gonna give this a random value. Now this should compile, right? Yeah. So essentially, the flow of things is for each characters, or rather for each string in strings, right? I want to first of all sort them, right, and then append to a map if it doesn't already exist, right? If it does, pull that value out from the map and then append the unsorted string into the result. Does that make sense?
Yeah.
So that would be the flow of things. If you need, because I know I was watching earlier, you want people to dry run their code, so we can do this, right? So using this example, right? So say first string, I'm gonna call this s equal to eat, right? After we're gonna turn this into a character array, right? When we sort this, it will look like AET, right? And then in our map, we can see in our map it doesn't contain. So I'm gonna initialize the map here, right? So our map then is gonna look like AET, right? And then it'll just be an array of eat, right? Does this make sense thus far?
Yeah.
Right. So in the next iteration, we have T, right? When we sort T, it rounds up to EAT, right? And then when we compute this, right, it's essentially going to look like T, right? Because this API is essentially map dot compute if absent is essentially saying if the value exists in the map, right? We just want to pull it out and then append S, right? S is the current string, right? If it doesn't, append a new array list rather, and then append the current value we're seeing. Does that make sense?
Yeah, that makes sense. Yeah.
Right. So in our next iteration, now that we have tan, right? When we sort tan, right? What is this going to look like? A and T, right? Right. The array is then just going to look like this, tan. Does this make sense? And then in our next iteration, we have 8, right? 8 is just going to come over here because we already have a sorted AET in the map, right? Which would be 8, right? And then NAT would be the same thing here. We're going to append NAT because it's the same. When we sort NAT, it's ANT. And then finally, BAT is then going to look like this. BAT. Right, so we end the loop, then we iterate the values in the map, which should just be EAT, this, and then append to results. The question says the order doesn't matter, so it's calm.
Yeah.
Right, so that would be essentially the flow of things. Actually, to even simplify this, we could possibly even do something like this. I wonder if this would work. I've never tried this before, but let's just do map values. Let's see. I don't know if I can't test.
Yeah.
Can I?
Try running it.
Oh yeah, I can. Yeah.
You can run the code as much times as you like.
Right. So I'm just gonna do a few things here, and then just do results system dot out the print line, and then hold on. Let's say I call results. Why make this static? Actually, hold on. Static. And then what is it taking? So it's essentially going to take a new string array. What do we have? I'm going to cheat a bit because I don't want to have to tap over this. Okay. Yeah, so it should output the same. Right. So let's see. Actually, no. I guess this didn't work, so I have to do this turn results. All right, let's rerun this. Yeah. See. Did it? Am I tweaking? Wait, hang on. Give me a second. So this should be not tan, but okay. So it is not doing that. Give me a second. Let me think. See what's going on here. So I'm iterating the values, right? The values is essentially a list of strings, right? Hang on. Let me send out the print line.
Okay, walk me through this part right here. So you take C, you turn S and you turn it into a array.
A character array.
Then you take C and you sort it.
Correct.
And then
oh yeah, C, yeah. You're right. Yeah, you're right. Yeah. Thank you for that. This should be C instead of S. Yeah, you're right. Yeah, now I shouldn't have that problem. I don't think.
Let's get it.
Right. So, I mean, like the question says we can return the answer in any order. So this will still pass, right? Because
nice.
But just one more thing before I want to see something here. I want to see if this will return the result I'm looking for. So let's do new array list, and then let's do map.values, right? And let's see. This should return the same thing, right? Yeah, there we go. Yeah.
Map.values. I see. Because it returns a list of lists. And then
right. Yeah. Right, because like in Java, like the constructor takes in a collection, and then the values is essentially a collection.
Why not just
collection?
What if you just did this? Not the values. Is that syntax?
Nah, it wouldn't work.
Okay.
It wouldn't work. Yeah, it wouldn't work. Yeah, because map of values is a collection, right? So that wouldn't work. Yeah, but yeah, that's the flow thing.
Awesome. All right, we're moving on to the next question. Good job. Let's move on to the next question. We might have to hit the drawing thing because it's going to be a tree question.
Okay.
Let's see.
Are you going to send me a link?
Yeah, we're just going to replace all this. Let me reset the tab.
Okay, I got it on my own side, yeah. All right, cool. So it says you're giving it a...
So we're going to be given a root of a binary tree with unique values and an integer to start.
Right.
At minute 0, an infection starts from the node with that value at the start.
Right.
Each minute, a node becomes infected if the node is currently uninfected and the node is adjacent to the infected node. Right. We need to return the number of minutes before the entire tree becomes infected. Does that make sense?
Yeah, so essentially we have a binary tree, right? And then we're given the root of the binary tree and then a start integer, right?
Yeah, exactly. So let's look at, hop in the drawing. I'll draw it.
Yeah, I'm right there. Yeah, I'm right there with you.
Okay, so pretend we're given, we say this is the first node to be infected, or this node. Like what is the, how long does it take for all the nodes to get infected?
Right. So like, and it's guaranteed that at least one node is infected.
Well, the tree starts off with no node infected, but
right,
it'll tell you, like one of the inputs into the function will be the first node that becomes infected, and after that, so at time 0 this gets infected, and then how long until all the nodes are infected?
Right. Off the top, if that's the case, because this looks rather simple, we can just say the number of items we have in the tree would be the time. Does that make sense?
Right here, like, how many items are in the tree? 1, 2, 3, 4, 5.
Hold on. Right. So let's see. So it says each minute a node becomes infected if the current node is uninfected. The node adjacent to it is infected. Right. Okay, I got you. So like, yeah, that makes sense to me. So say we have a particular node that is infected. It's adjacent nodes, so it could be at most 2 nodes, actually no, at most 3 nodes, right? At a particular minute, all 3 of them are infected. Does that make sense?
Yeah, I whoa. Yeah, exactly.
So say in this case, right, we have say we have oh my goodness, say 4,
Yeah.
right? The adjacent nodes to 4, I'm assuming, is 5 and 2.
Yeah,
So in the first minute, them two are infected, correct?
exactly. So
Right. So okay, cool. I mean, I think in that case, we definitely want to use a level order traversal, right? Where and just to clarify again, so is the starting actually, let me reread this question. I don't have to ask you. You're given a root of a binary tree with unique values and integer start, okay? At the minute 0, an infection starts from the node with the value start, right? So does that mean what's the word I'm looking for? Like the infected node will be given to us as a parameter.
yeah.
Correct. Okay, cool. Um, so let me just say we have um actually I'm gonna draw this on the not on the whiteboard but on the thing. So say we have 8 and then we have 9. Actually no, this should be 7. And then we have 9. Right, so say 9 is the first infected node. Right. So we should essentially say, okay, so the first node infected is this, cool, and then right, this is kind of a tricky question. Hang on, so you're given a root node of a binary tree with unique values, and then it just starts. At 0 minutes, an infection starts from the node with well, I'm a bit confused here, actually. So if the question is saying um, at a start, or rather at minute 0, an infection starts from the the node where the value starts,
Hmm.
right? Am I to assume it's the root node that's
No,
where the infection
no,
starts?
we're gonna be given like pretend this is our function. Um,
Okay,
get or this is called solution. We're gonna be passed in the root of the
okay,
binary tree, and then we're gonna be
okay,
given an integer like 9. So the
okay,
root will have a tree like this, like you mentioned. Just
right,
add like some random stuff to it.
right,
Okay, pretend we do that.
right,
We're gonna be given the root of a binary tree. We could assume that, I mean, we have like a tree node class
right,
with value left and right. But essentially we're given the
right.
root of the binary tree, and then we're gonna be given some random number within here.
Oh, within the I got you, I got you.
It could be 10, right? And that will affect the result. If it's 10, then how long does it take to propagate? Well, after 1, it's this. 2. The result would be 3 if they pass in 10. If they pass in 7, it's 2. If they
Right.
pass in 9,
Uh,
it's like literally 1, 2, 3, 4 minutes until everything's infected in the tree.
right. And then in this case, with respect to the solution, 9 being is the start time, or is the infected node.
That's the starting infected node, and so we infect that at minute 0 right here in 11.
Right. Oh, this is good. Give me a second. Let me think.
Yeah, gather your
So
thoughts.
we don't know where the we essentially say 9 is the starting node. So how do we want to start traversing? Right. So do we want to find the first current? Right. And then but
Also,
then it
all
just
the
makes
nodes are unique, so it's not like we're gonna have two
right,
lines there.
right. Well, that's okay. Okay, fair enough. Um, um, let me think. So, just a clarification question, actually. So, say 9 is the starting node, essentially the start infected node, right? So that does that mean the adjacent being the only adjacent here would be 8? So at minute 0, this is infected, or like adjacent meaning it's children. Does that make sense?
Adjacent is okay. 7 right here. Adjacent is 8 and 10.
Oh, I got you. I got you. I got you. Um,
Because it's not just their children. Otherwise, if we have 9, right, then we wouldn't be able to affect anyone because 9 has no children.
right, right. Okay, cool. So how do we want to do it? So if we do a level order traversal, so BSF, no, DFS, what's it called again? Basic level order traversal. So if we start from here 8, we don't see that full, right? And then we go into the next point. Now we see um a 9, which is the infected, right? So what does that mean? So can we essentially say the adjacents are 7 and 8? Okay, cool. So what does that mean for this? So that's gonna mean 7 to 10 in the second minute, right? And then in the third minute, it's this will be 2. I can't. I'm not even gonna lie, bro. This is not clicking. This is not clicking because it makes things a lot challenging. Where how do I want to traverse this tree um, to essentially find the first, or like to take if I already know the starting point of the affected node, right? How do I want to traverse or keep track of the nodes before the starting point, or before the start the infected node or the first infected node?
Sorry, can you repeat that?
So I'm essentially I'm a bit stuck here in terms of I understand I want to traverse the tree, right? But like whilst I'm traversing, I want to keep I essentially want to find the first affected node, the occurrence, right? So say in this case, right? In this case, this is 9, right? So the adjacent before this is 8. So how do I keep track of the node before or the adjacent node before 9? Does that make sense?
The adjacent node before 9.
Right, because like the adjacent, according to what you explained before, the adjacent node to 9 is 7 and 8, correct?
Or it's not. It's not 7. There's not adjacent as in it has a edge directly to it. So if 9 is the first to get infected, at minute 0,
Right.
9 is infected. At minute 1,
Right.
8 is infected. At minute 2, 7. So and then this and then this. So like if we
Right,
X, that means it gets infected. This gets infected. Then in the next minute, this guy gets infected because it's next to like there's a direct edge between an infected node. Then this gets infected. Then this gets infected. Then this gets infected. So it'll take
Yeah, infected.
1, 2, 3, 4 minutes to infect the whole thing if we start at 9. Okay, what happens
Right.
if we start at 10? At 0 seconds, this is infected, right? At 1 second or 1 minute, this is infected. At 2 minutes, this is infected, right? At 3 minutes, this guy gets infected. So
infected, yeah. Okay, that makes sense to me. Oh, how do I want to accomplish this? So you want to essentially say at the first middle, and 1. So this is 1. These 2 are infected. Right. So can we can we just do something like how do I want to? I mean, do it for a second. Just append everything to an array and then do some sort of logic. So say we have 10, the first two adjacent to 10, and these not. Man, I'm not even gonna lie. This is not clicking. What am I? What? How do I traverse this map to keep track of the values?
Pretend it. What if it was like pretend it wasn't just it wasn't a tree and it was a graph. How would you do it?
Pretend it was a graph. Um, I mean, like a tree is a graph. Is a type of graph, I think. How do I want to? So
Pretend it
we
was a
can
general graph. It wasn't a. It wasn't like a. Like, tree is more specific version of a graph, right? With like some
right,
constraints that's
yeah,
kind of tripping you out. Relax the
right.
like. What if
Oh, okay.
like yeah? Go ahead.
Right. So like that makes sense. Now the issue with this is how do I want to okay, can I essentially just do something like this? Right? I want to find the occurrence of the first node affected,
Mm.
right? Um Now because this is a tree, I can't go up. Mm, 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 mm. Let me think for a second. It should have been um um so you want to essentially say, so let me try something here. So if we have, say, level order traversal, so we want to first find 8. So if we say 8, all right, cool. Say 8, the adjacent to 8 is nothing. Say 7 and 9, right? So that's 1. All right, cool. Right, and then this next one, this is 2. And then let's say we have 10. Right, 10 becomes 1. And then 2 becomes 1. Right, so how do I want to traverse this? Should be 1, 2, 1, 2, 3. Right. 3. Wow, this is a you have to send me this question after because this is a good problem. Yeah, I can't even lie. This is a good problem because I can't. It's not clicking for me right now. Um,
Pretend it's a graph. What's a graph? Or pretend it's a bi-directional graph now, right?
right,
Let's hop into drawing.
right.
So pretend we have 8,
Um,
7,
okay,
9,
okay, okay,
10,
okay.
and 2.
Right,
Right. Pretend this was just a bi-directional graph.
right,
So let's think about this now. Like, pretend we had this bi-directional graph. How would we, and we infect this node right here?
right.
Like, what would be the algorithm to figure out how long it'll take before all of the other nodes are infected?
Right. So like if it's a bi-directional graph, right? I would at least my approach to this would be basically like a level order traversal where um
Starting at
for
10?
essentially yeah at 10, right? So I want to get the its neighbors, right?
Okay. Yeah.
And then how do I get its neighbors? So like it would be based on essentially level order traversal, right? Where like I'm just getting the neighbors. Once I get the neighbors, I increment the time.
Yeah.
Does that make sense? Because in this case, it would be 7 and then 2,
Yeah.
right? And then I'm gonna add that to our queue,
Yeah.
right? And then based on 7, right? Say when we pull out from the queue, it would be 7, right? We have already seen 10, so we don't have to include it. So from 7, how many of its children can we get? Or like its siblings, I guess, right? Because it's bi-directional. It is just 8. So I increment the count to 2,
Mm-hmm.
right? Then pop 7 out from the queue. Then we then have 2. we see we have a 10, but we have already seen 10, so we don't include that. So we essentially just don't don't increment anything. Then in the queue we then have 8, right? From 8, how many of its children can we get? It's just 9. So we then increment our count, add 9 back into the queue, and then pop out 9. We see we have already seen 8, and then 9 doesn't have any other sibling, I guess. But then this is kind of different because with respect, well, actually, do you understand what I just explained?
Yeah, it's sort of like a level order traversal.
Correct.
Um,
Yes.
yeah, I mean, definitely it's gonna work, right? Like, I don't
Right.
see why it wouldn't work. How are you gonna convert the current input into a graph like this so that we could perform that level order traversal? That'd be my next question.
Right. That's a great question. So we can build an adjacency list for the tree, um, and then basically apply the logic I just explained. Does that make sense?
Yeah, that makes sense.
So like that would essentially be how it solve this problem. So for the tree, we'll need to basically build an adjacency list. I'll do that using a map, right? Where for each value or each node in the map, I want to get its left and right, put them into the positions or the values into um, um, what do you call it, an array list, right? And then yeah, that's essentially the flow of things. Now let me think for a second. Now that if I have that in our map, right, what do I want to do in terms of iterating the map using DFS? Um, right. Okay. I'm just gonna go back to the whiteboard and then no, rather
Yeah,
the
yeah,
coding
whiteboard.
part. Right. So let's do something. I guess that kind of I think that helped, but hopefully I can come to a solution. So let's say
Well,
we
you
have
came to
from
this solution, right? Like,
right.
what you said there makes sense. Yeah, I think the next part, let's just figure out like how are we gonna convert this thing into a graph so we can perform a level order traversal.
Right. So like how I would do that is essentially I'm gonna build a map, right? So say from 8 we have 7 to 9, right? The next iteration, say from 7, we just have 10, right? And then from 9 we have nothing, right? From 10 we have a 2, right? And then from a 2 we have an empty array, right? So and then we know the affected node is obviously going to be um it's obviously going to be 10, I think, right? Then say it's 10, right? So from 10 what do we then want to do, right? No, actually, no, that doesn't really make any sense if I were to do this way. I ain't gonna lie, yo, I'm stuck at the point where I understand the algorithm, but them implementing is just a
Yeah,
different
yeah, yeah. That
just
makes
a
sense.
different
We're
thing.
running out of time anyways. Let's just go into the drawing board. So I'm gonna show you
Right.
one small thing. So we're given a binary tree, right? That means every node has a left and right child.
Correct, yeah.
Pretty much in order to build the bidirectional, because essentially we want to turn this into bidirectional, what we can do is do a DFS, and for each
Okay.
node, all we need to do is like a hash map and store like the parent of each of like when we do a DFS, just store the parent.
Store
We
the
know
parent,
seven's
yeah.
parent is 8, nine's
Right,
parent is 8, right?
right,
Ten's parent is 7. That gives
right,
us that turns our tree something like this, right? And then
right,
as soon as we get 10, all we need to do is what you mentioned is we start with 10 in the queue, right? And then from
right,
10, pop 10 out, and then view its neighbors. How do you view its neighbors? You view the left and right pointers,
right,
and you view the parent, and then you pop those into the queue if they've never been in the queue before, and then you just do a
right,
DFS level or traversal from that, right?
right.
Yeah, that's
Yeah,
gonna be
that
the
makes that,
solution. I'll send you
yeah,
this
that
question.
makes
It's a good question, huh?
Yo, it's a brilliant question actually. No, I ain't even gonna lie. Yo, like I thought it was good in terms of like DSA because I've been grinding for like a month. Yo, this is the I'm not even gonna. Yo, this is different. You gotta send me this question. It's a bit humbling actually because I thought I was a bit confident coming
No,
into
you
this,
honestly
but then
you're
it
really good. You were good, especially with the first question. But yeah, then that's why I decided on this question. This question is a bit tricky, but
right, yeah, yeah, yeah. You have to. What is it? You were
it's a
explaining something
medium.
before, like your the thing you have, like your top 75, I
Yeah,
think.
it's in my 75 list. It's in my top
Right.
75 list. So yeah, try
Right.
it
Yeah.
out.
No, I'll check. Yeah, I'm gonna check that
Yeah,
out because
try
it's a
out that
bit.
list because all the questions in the list are different. Are just questions that are different than what you'll just see in regular blind 75. I these are like the 75 questions that I thought
Right.
were
Yeah.
actually really good.
Right. Yeah. No. Because yeah. I mean, like coming into this, I was like, yeah. No. This. I've been on this for something. Yo, this is. I ain't gonna lie, man. Yo, this is different. This is like it's a bit humbling, but it is what it is, man. You live to learn, right?
Yeah.
So yeah.
Now
Anyways,
you'll never fold on a question like that again.
yeah. No, I'll never fold on this, yo.
Like
But
what did
yeah.
we
No,
learn here? You learned that yeah, maybe you can look at it like a graph. You learn
right.
how to
Yeah.
convert a tree to a graph. Like if it's not in the data structure that you want it to be, you can like in some of those questions you can try to convert it into a data structure that allows you. Because if we were to try to do a level or traversal
Right.
using just the tree, that would be hard because with the tree
Yeah.
structure we only know the children. We can't like go up the tree at all.
Right.
Yeah.
Right. Yeah. Yeah. No. Hey, that makes sense to me because like at least my approach before was what you just said, but then like that just explained it. So essentially, it's a bit of DFS and BFS, right? But then you have to build like the adjacency list, or like this question is essentially adjacency list with a
Yeah,
bit of twist.
first you do a DFS to build the adjacency list, then you do a BFS
Right.
to actually figure it out. So it's interesting. You get to try both the questions. I actually really like this question.
Right. Yeah. No. Me too. Yeah. This is a good question. But yeah. I mean, like, I don't know how much time you have or we have. I'm pretty sure we're out of
Yeah,
time. So
we're out of time. Yeah,
um, yeah.
cool.
But anyways, this was cool.
Yeah, good luck.
Humbling, but
Yeah,
enjoyed it.
you have any questions for me on like just like job hunt or anything? You got a few minutes.
No. From my own end, it's I don't think I came essentially coming here. It wasn't really a question. It's more like
You just want to see where you're at, kind of thing.
yeah, exactly. It's just testing, pulling the muscle, I guess. Mock
No, it's good.
interview. You know what I mean? So
Yeah, mock
yeah.
interviews are important. Like, thanks for coming up. You're
Right.
not scared to hop on in front of people, do the
Yeah, no, no,
question.
no, no, I ain't scared, bro. This isn't cutthroat, so like
This
it's
is
just
you'd rather
this
fail
is
now than when you
yeah,
do a
like
job that's
you
gonna
know what I
make you
mean, like
100 grand.
right, yeah, yeah, essentially, yeah.
Cool. All right,
But
man.
anyways,
Thanks for hopping on. See you around.
for sure, yeah, for sure, man. Bye
Peace.
for now, man.
I like that question. That's one of my favorite questions. Who's next? Let's see. We have Jacob McDaniels. Mr. B, how many questions have you solved? Yeah, I got you, bro. Dude, it's in the Pro to 75 list. I'm telling you, this list is the list that people need to be doing. This list is different. You see, he never seen a question that good before. He likes that question. It's not even a premium question. Everyone, get on that Pro to 75 list. %. I'm telling you, a lot of these questions that I have here are the good questions. Trust me. I spent a lot of time picking all these out. Pro to 75 list. Check it out. I'll be right back. Let me use the restroom real quick. Then we got our next person on, Jacob McDaniels. Give me a second. Jacob. Bro, like there's a Zoom link in the calendar link. Hop in. Hop in. Hop in, hop in. Jacob, like check your Google Calendar. You should be on there. Yo, chat. Can you hear me? Test, test, test. Did it tweak? Jacob, what's your... Yeah, it goes to your email. It goes to what email that you applied with. 99@gmail.com. Like, there you go, there you go, there you go.
Hey, how's it going?
Jacob, what's good? How you doing?
Doing all right.
Is this your first time here? Or did I interview you or no?
No, I think it was maybe like close to 5 or 6 weeks ago. We talked a little bit, but you were like ending the stream.
Oh, so I never ran an interview on you yet?
No, not yet.
Cool. All right. Yeah, thanks for hopping on, Dan. Could you just quickly give a brief background on yourself? Yeah, like whatever you want to share. Maybe what school you go to, or what company you worked at, and how many LeetCode questions, like whatever you're willing to talk about. Just to give the chat a little bit of intro, so they know who's doing the interview on the other side.
Right. Yeah. So I'm a student, computer science student at Indiana University, Indianapolis.
Nice.
Go Pacers. I started at Ivy Tech Community College around January 2024, and I've been kind of doing like software development, like courses and like building stuff since like September 2023. I've probably since that time probably done like around 100 to 150 LeetCode problems. But I would say in the last like probably since the last time like I hopped on the stream around that like week or a week after that, I haven't done any LeetCode for like 4 or 5 weeks now. So.
Oh, you haven't done 4 or 5 weeks, so you're gonna be a little bit rusty.
Yeah, definitely. I think at that time, yeah, I'm definitely gonna be a little rusty, but I think I'm willing to just kind of figure out where I'm at.
Yeah.
I think I definitely have a good kind of understanding for data structures and algorithms. I think where I just struggle is like consistently like having the syntax to be able to do problems.
I see. Okay. So, what year are you in again? Sorry, I missed that part.
Yeah, so I'm actually getting a bachelor's degree in computer science in 3 years. So I actually don't really know. I guess I would be like a junior.
How
I only
many
have
years
like
of college have you done? Like how many years of university?
So I have a bachelor's degree in psychology, and
Nice.
I'm going through and getting a second degree in computer science.
Nice.
And
Well,
then,
what made you want to switch?
yeah, so actually, I had a bit of a rough time after I graduated. I was trying to get into a top sports psychology master's program, and yeah, I just didn't have enough experience like coaching sports.
I see.
So, and then 2023 was a really rough year for me. I was trying to find a career coaching basketball,
Nice.
and yeah, that just I didn't find any opportunities. So
I
I
see.
had to make a career change, and I ended up kind of just, I guess, falling into not even computer science. It was just like software development. I started with Harvard University's free computer science class on edx.com. And I tried that out, and I was like, yeah, I like this. I like building stuff. So that's kind of where my journey started.
Yeah. That makes a lot of sense. Like, are you a Pacers fan?
I mean, I don't think I mean, yeah, I guess I am. I mean, I've been to a few Pacer games,
Yeah.
but I wouldn't say it's like my favorite team. But it's kind of exciting to, you know, I don't think the last time I remember the Indiana Pacers being in the Eastern Conference Finals was back in like 2014 with Miami Heat LeBron. So,
Yeah. I mean, they're in the
it's kind of
finals.
yeah, exactly. So it's kind of exciting for
Yeah.
the city.
Yeah.
Um, I definitely, not to be like a hater or anything, I definitely never would have guessed it though.
Yeah. No, that makes sense. How is it with like landing interviews and stuff for you? Are you trying to get an internship?
Yeah, so I actually did finish up an internship. I was actually, I mean, kind of doing two at the same time. I finished them both in May. Um, but one of them was unpaid. Another one was kind of like a program where they have you build. It's kind of like a boot camp, but then at the end of it, they try to get you like they have like jobs actually lined up for you. That kind of makes sense.
I see. Cool.
So I was doing both of those at the same time. I finished both those in May. But yeah, I've been having a pretty rough time just getting interviews.
Mm.
Um, but yeah, I've been applying.
Okay.
Um,
How are you with like trees? Are you able to implement depth first search, breadth first search?
I mean, like I was saying before, like I think I have a good understanding. Like I understood, kind of what was going on in the last interview. But as far as like implementing it with syntax, I'm not really too sure. I think I'm willing to give it a shot. I think the last thing I remember with breadth first search and depth first search is like using like recursion
Yeah.
a little bit with that. Um,
Okay. Okay, let's just get into this coding interview then. I think I have a gauge of where you're at. Let's see. I sent you the link to the coder pad.
all right.
Okay.
Okay.
So
Should be in here.
okay. So this is the first question, right? We're gonna be given
Is it alright if we use Java? Is that fine?
yeah, we can use Java. Let's see. Damn, 3 people today using Java. It's a record.
Yeah, I don't really have a lot of experience with Python, with data structures and algorithms, just C++ and Java.
I see. I see. So we're gonna be given 2 arrays, array 1 and array 2, right? 1, 2, 3, 4, 5, or 10. And both of these arrays are going to be sorted, right? I just want you to output a third array that's combines these two lists and has the two lists sorted.
Okay, so you said that array 1 and array 2 are already sorted. You want me to combine both of them, and the ending result should be also sorted.
Yeah.
Okay. Um. Right. So, what I'm probably thinking about here is, kind of making another array for just the solution, and then adding each of the arrays into that array, and then just sorting it.
So create a third array, put all those
Yeah.
elements into that array, then sort it. What's the runtime complexity of that?
That would probably be like brute force. So maybe O of n.
How fast is a sort algorithm?
I'm not really too sure.
Okay. Sort. I'll just tell you then that sort is n log n operation.
Okay.
So if we put all elements into this array, 1, 2, 3, we pretend it's like, and we sort it, we get a O of n solution, or like the runtime is n log n, right?
Wait, so what happened to array 1?
I just added 25. Okay, so could you explain your solution again?
Yeah, so I have array 1, 2, and eventually I'm going to have array 3. So what I would do is I would create, or I guess instantiate array 3, add all of the elements from array 1 into array 3, and then I would add all of the elements from array 2 into array 3, and then finally I would sort array 3.
Yeah, and then the runtime of that is n log n, because, like, why would it be n log n?
I have no idea.
Well, because, are you familiar with how to calculate? So could you write out that algorithm? Let's just walk through it.
Yeah.
Yeah, try implementing it, and then we'll walk through. I want to test if you understand time complexity as well, because that's a very important part.
Right.
It's here. I would write it inside of this here.
Oh, okay.
Because in Java it needs to run, right? It needs to run in a class in Java.
So this should be the outer part, the main that kind of takes my solution, right?
Yeah. So what's public static void main here? What is that?
I guess static is like it's just the main is kind of, I guess, like encapsulated to like itself. It's like um I guess like things that are inside of the main can't be used outside of the main unless it's in this like parameter.
Hmm.
Like use it somewhere else.
Okay. Let's just assume that we create a array here. Like, okay, how do you instantiate array in Java?
I'll just go ahead and that'd be a list. As far as an array, I would do it a little bit different, but yeah, an array list, I would do it like this here.
Okay. Okay, we have a list of integers, and let's just start off with like this. And we have array 2. Okay. Now just like write the function that's going to produce this result.
Okay. I'm going to, and this is what I was saying is that I'm going to make obviously a third array that would be my result. So I would do that, and then I would do. I don't want to need. Finally, oh. There's a library for this, maybe collections that I need.
Wait, so you're going for I in array size. You're doing I in array 1 size, and you're doing. Maybe try printing this out. Just
Okay.
few errors. Oh, just make sure you understand. It's illegal start of expression.
Right. So if okay.
You can prompt the AI assist right here. You see the AI assist tab?
Oh, okay, yeah.
You see it here? This side?
Yeah.
You can like ask, type in hi or something. I just want to make sure that it. Okay, cool. That it shows on my end. Okay, what would you ask this AI in order? I think the first part is like I don't think you're creating the array list properly. Can you ask it how to create like an array list properly?
Sure. Right. So, yeah, normally I would probably do it like this. As far as putting it in like this, don't really do that too much. But no, I definitely understand this for sure.
Check it out now. I just prompted it of how to initialize it.
As a list. Okay. Okay.
So you created the two list result. Okay, what's happening here? Line 26.
I don't. Maybe I should do this -1.
No, you're fine here because I is less than. Right.
Okay.
So
Array
what's
one
happening
dot
here?
size.
You're looping through every element in array 1 and you're adding it to the result. Right?
Yep.
Okay, what's happening here? Why is this array 1, not array 2?
Oh, yeah, that's probably not good.
Okay, now if when you run it, try running the code, you'll see that you have it. Now you're right, we just need to kind of sort it. Now it's complaining. What is it saying? It's saying there's no such thing as sort.
Right. I think what I'm pretty accustomed to is there is a collections library. I'm not sure if that's just util.
Prompt the AI.
Okay.
Nice.
Yeah, I was thinking it was this. I wonder both sort, but more for primitive arrays, right? So this is for the lists. Okay. Okay. Yeah, as I was saying, I'm kind of rusty on the syntax, but I think I definitely can remember using collections, sorting.
Mm-hmm.
So
okay. Okay, let's analyze the runtime complexity. How long does this algorithm take to run? Like this portion of what's the runtime complexity of this?
So you'd have to go through basically every single element in the array. So I would guess that'd be O of n.
O of n. Okay, what about this one?
Yeah, same thing.
So you're saying this is O of n?
Maybe not exactly the entire solution, but the for loops independently are O of n.
How about this? O of n. Okay. What about this? Sort. I think I told you
This
earlier.
last part,
The sort.
the sort. Yeah. So I'm trying to think how that would work. So you'd want to go through the array and assess if the element before the one that we're currently at is or I'm sorry, the element that we're currently at is
Well, here, one sec. Let's assume because you sorting, I told you is gonna take n log n, right? N log n.
okay.
That's just how it is, right? That's because there's different sorting algorithms that I could walk you through that as well. But now that we broke down every single step, what is the total runtime complexity of my whole solution?
I'm not really too sure.
How would we calculate that?
I don't think I've ever done that.
Okay, you never had to ever do
No.
runtime. Okay, just taking notes because I just want to see where your gaps are so we could improve on that. So, what's the time complexity? Well, if this takes O of n to run, this takes O of n to run, and this takes O of log n to run. If we add, do you know what O of, like, what time complexity even means?
Yeah, so like the kind of like the time that it takes for an algorithm to like complete.
Exactly. So if we say the first part takes n time, the next time takes n time. But honestly, I'll just walk you through it. So array 1, let's say array 1 is of size n. Array 1, this is of size n. Array 2 could be a different size, so we can't just use n. We have to use a different variable, m. So we're saying array is of size n, and array 2 is of size m. That means this first loop will take n time, this second one will take m time, and then this right here would actually take n plus m, because it's looping through if you add up the length of both n and m. Does that make sense?
Okay. Yeah.
So if we add it, if we say this algorithm, the time it takes is first is going to take n time for the first part to add it to the array, then m, then this, right? So that's the total time complexity, but you could simplify it by taking the largest term, and you should just research how to calculate runtime complexity. It's very, very important for computer science to understand runtime complexity. But basically, you take the biggest term, which is n plus m log n, and that's kind of how we achieve this runtime right here. So that's the final runtime of that algorithm. And in coding interviews, they're going to ask you that question. They're going to ask you, what is the runtime complexity of your algorithm? Does that make sense? Because they want to understand how efficient your algorithm is.
That makes sense. Understand.
Nice. Okay, let's go into another question as well.
Okay.
So I think for that, let me just give some feedback. I think definitely seems like, yeah, you're still super early with coding and your DSA because you weren't that familiar with like the syntax for Java. I think you just need to familiarize yourself more with Java as a whole. Like if I ask you if you want to use Java in a coding interview, you have to be super comfortable with it. That means, what I mean by that is really understanding the library, the standard library, and the standard things you could do. So you should be able to have known that you have to do array as list kind of thing. And then just the syntax with how you sort. You shouldn't really have to look up those things in a coding interview. Some of the more complicated things you might have to look up, and you'll have to look up. But like some of the basic syntax, I think you just need to familiarize yourself well with the programming language. Does that make sense?
Yeah, I actually just started coding in Java. I want to say in March.
Nice.
I actually took my data structures and algorithms class in C++.
I see.
So, I mean, Java seems pretty close to C++, but it just, of course, different, like collections that sort and
Yeah, exactly.
some,
So
just minor stuff. So, yeah, I mean, I probably do just need to practice more.
exactly.
Yeah, so I agree. I definitely agree.
And then another
I've
thing
definitely
would
done a few LeetCode problems using like this. But it's like I said, it's been like 5 weeks.
honestly,
So.
if you're just learning Java and you're just new to coding, I would just learn Python and just stick with Python because it has the less syntax, and you'll be able to code a lot faster using Python. That's my advice since you're just starting.
Yeah, so I have a lot of experience like coding with Python and like Django, but I just haven't really had the time to like learn object-oriented programming and data structures and algorithms in Python like to the extent that I have in C++. Um, but yeah, I mean, I've definitely considered getting more into it. It seems like the language that people prefer to do data structure and algorithms in.
Yeah. Well, yeah, because you're still new, right? You don't want to be solving language issues when you're solving these questions as well. It's just gonna if you're already really good at LeetCode or you've done a lot of programming, like your experience in Java, I would say do it because then all algorithms are just gonna get even more complicated than this. And if you have to satisfy the compiler, it will just slow you down a lot. And I think that's not what you need right now. What you need is to be able to solve questions fast. You need to gain more breadth in understanding and breadth in the question solved. So I think just focus on a programming language that's less verbose. Like it's almost like Python's literally like almost like pseudocode, just so you can understand the algorithms and only focus on the algorithms and nothing related to the language. Right? Does that make sense?
Yeah, yeah, that makes
Yeah.
sense.
Another thing would be I think you need to just like research some of definitely need to understand runtime complexity. This is crucial for interviews. Understanding runtime complexities of the most um,
I mean, I know a few of them, right? Like I know that O of 1 would be like hash tables and nested loops are of n squared. I just like for example, like adding them up. I'm not really familiar with that.
Yeah.
Some of the other ones like n log of n and log of n. Sometimes I can forget about those. Um, and the reason why I kind of know like O of n is because it's brute force and n squared. I have a lot of like I guess like LeetCode problems that use like nested loops, and I just remember that O of 1 is like hash tables.
Yeah.
So I just think that, like I said, like adding time complexity up from a solution. I don't like I said, I've just never done that.
Yeah, that's I would just practice that, like being able to do those runtime complexities. And what I mean is, you also need to understand the runtimes of things like sorting. That's really important. And then for the date for like inserting into an array, popping from a stack, popping from the front of an array, all the common data structures, understanding the runtime complexities of the various operations. So that includes sorting an array. So yeah. Um, let's just move on. Does that make sense so far?
Yeah.
Okay. Let's move on to the next question. So I'm gonna give you the prompt. So this is kind of a classic one. Pretty sure maybe you've seen it before. But we want to write a program that prints the numbers 1 to n. But for multiples of 3, print fizz instead of that number. And for multiples of 5, print buzz. For numbers that are multiples of both 3 and 5, print fizz buzz.
Right. So we would want to use I've done this one.
How would you explain it? Let's just walk through and just make sure.
Right. So I guess first, right, so our first part of this says that write a program that prints the numbers from 1 to n. So we need n. The next part of this is that we would want kind of if-else statements that utilize divisibility. So basically, if n is divisible by 3, but for multiples of 3, we're going to print fizz. If n is divisible by 5, we're going to print buzz. And if n is divisible by both 3 and 5, we're going to print fizz buzz.
Yeah. So how would you structure, like, right? Just go into the main and implement that then.
Right. So I guess we're going to have an integer n, whatever that might be. So if n what was it, 3? Right. Sure. We'll just do a random number. All right, so that's what that would look like. As far as getting in, I just initialized it to 10, but this is how we would do that.
Okay. So let's run this code. It just said buzz, right? I need you to print out like this is the expected output right here.
So the expected output is 1, 2 fizz, 4 buzz fizz. Okay, so write a program that prints the numbers from 1 to n.
So for this, pretend I put n equals 15, right?
Okay.
We want this to pretend this is a console. I want to look at the console and see this 1, 2 fizz, 4 buzz fizz, 7, 8 fizz buzz 11.
Oh, I see. Okay, so if my salute or my n is 10, then I want to start with 1, and if there's nothing, if it's not divisible by, or if it doesn't meet any of these conditions, we're not going to print anything. We're going to continue. We're going to go to 2 and check. Is that what you mean?
Like basically what I mean is right now when you look at the output, right, it only said buzz. I want it to on the console print out this whole thing, 42 to 56. Starting from 1 to 15, print out the result of all those.
Right. So I'm thinking that we're going to do a for loop, or not 10, I'm sorry, to n, whatever that might be. Right. And what we want to do each time is check I instead of n. So control B. And we would want to check if I is I. And then we would need to. I don't remember if what I'm gonna do is because I don't remember if print line includes a new line.
It does. It does.
Oh, it does.
Yeah.
Okay. So yeah, I would just print I. And then we go to that new line. Same thing for the rest of these. So we'll run that. Right. So if that, oh yeah, so we also need to print each. So the other thing that we'll do is we'll system, we'll do else. What we're gonna do is right. We're just going to print I. So that should 0, 1, 2, 3 is okay. I believe that's it. I mean, I could try. Oh, you changed it to 15.
Yeah. It doesn't. It's not matching what I expect.
Okay.
3 should print fizz. Like 15 is not printing fizz buzz. It's like, it looks off.
Okay. So from 1 to n, but for multiples of 3. Right. So if we start at 0, or no, we're going to start at 1. Okay. So if we start at 1 and then we check if 1 is divisible by 3, it's not. We're going to continue. It's not divisible by 5. It's not divisible by 5 and 3. So we're just going to print 1. That should be correct. So if we go through and we go to 2, right? 2 shouldn't be divisible by 3 or 5 or 3 and 5. So that should also print I. When we get to 3, that's divisible by 3. So we're going to print 3 and then fizz. So that would match the output on the right so far. We would pass 4, and 5 would be divisible by 5. We would go to 6. That would be divisible by.
Are you pointing somewhere? Sorry.
No, I'm just checking. I'm checking. I mean, I would say up to this point, what I've checked, that would be logically correct according to what I have.
Okay, pretend we have 15, right? What should be output at 15 if we have 15?
Right. So that would meet the condition that I is both divisible by 5 and 3. So we would print fizzbuzz.
What would it print out here in your solution?
Oh, right. Okay, I see now. So right. What I'm thinking is we're gonna need and I will 5 does not equal 0. That's what I'm probably thinking for this potentially. Yeah, that's probably what I'm thinking here for that.
Okay, if I delete this, I don't know. Yeah.
Yeah, so we would probably want, I guess in this case, like that doesn't exactly say that we want to find numbers that are exclusively divisible by 3. Although by stating that it's not divisible by 5, I guess we could just go off of the conditions that we have divisible by 3 and 5. and just use those.
Mm-hmm. Yeah, I think it still looks off. Like 15 there is not printing FizzBuzz.
So like here,
Wait, let's run the code. If you look at
yeah,
the
it should be
console,
now.
oh,
Yeah, it says fizz buzz at the end.
oh, okay, wait, because you're printing this. It should, like, I want it to match exactly there. Okay, there you go. 13, 14.
Oh, okay. So you want it on the. Okay.
Yeah.
I wasn't sure.
Like, we don't print the number unless it's not divisible by 3, divisible by 4, or divisible by 5.
Okay. Yeah, that's fine.
Cool. Right. All right. Okay. How do you think you did? Anything, any like things that you wanna? Yeah, just curious on
I mean,
your side
that's
of
pretty. I mean, I think I've done harder questions than this. This was pretty easy. I think some of the, minor details, I just needed to work out, like exclusively being divisible by 3 and 5. But yeah, I mean, the other way I could have done this is I could have just taken that last else if statement and put it at the top. So that, like, if it's not divisible by 3 and 5, it'll just continue. I think that might work by the program starting at the top.
Yeah.
But this also is fine in my opinion.
Yeah. I mean, okay, yeah. I think it definitely could be cleaned up. It's like there's a
Okay.
lot of too many conditions here. I think yeah, initially where you messed up was that you weren't ordering the if else conditions good. So it was exiting early. So how do you do that is usually, I mean, you do like if I is divisible by 3 and divisible by 0, do FizzBuzz here. Like you mentioned, if I is divisible by 5, what do we want to print out? Buzz. If I is divisible by 3, right here, we print fizz. Otherwise, so that should give us the right result, right?
Yeah.
And so it's a bit cleaner than the original solution. Yeah. I think you're definitely like still definitely new from what I see. You just still have to practice more. That's what I would say. Is like start from the basic questions, easy questions. Like this was an easy question, you figured it out, but you should be able to figure it out in seconds and like implement it without any bugs. Not seconds, but like within a few minutes, right? That's where I would want you to get to on this question.
Okay.
But I think you're in the right direction. You just literally need to keep practicing. You're still new. You just started. Yeah, I think everything's there. You're doing the right things. It's all about practice. No one starts off good at LeetCode or coding or any of this stuff, right? Like you said, you've been coding for under 3 years.
Yeah. So yeah, probably around that.
Around
I think
3 years now,
in like
or 2 years.
yeah, I started in like September of 23, so
2 years.
probably under
Yeah.
2 years.
Yeah. Cool. All right. Thanks for taking the time out to interview. Hope it was like insightful and how you learned some stuff.
Yeah, definitely. Thank you for having me.
Cool. All right. See you around.
Thanks.
Peace. All right. Next, Paul's gonna run an interview on me. Give it a sec though. Let me delete this Java tab. Let's wait the 10. Let's wait the 10. Let me take a quick break. I need to get some sun real quick. Wait the 10. Wait the 10. everyone. Which new vid?
But I probably won't be doing LeetCode before that because like if
Yeah.
I fail, it'll just make me nervous.
All right, it's recording. So I got 3 questions. Oh, I showed that already. Give me a sec. I'll be back. Watch this guy, this Columbia freshman, work on the question. Actually, let's find a different one. Hey everyone. So today, okay, we're gonna be building a full stack app in Cursor real quick. Full stack to-do list application using Cursor. So I'm gonna build the front end using React. Be right back. I'm gonna build the back end using Express and Node.js, and I'm gonna do the whole thing using Cursor here. I'm gonna do it as like pretty much build the whole thing from scratch and yeah, build it as fast as possible. Let's get into it. Chat. I want to build a full stack to-do list. Front end in React and back end in Express. I think even with that simple prompt, let's see what it could generate us. So it's giving us the folder structure. So they want to set up a folder structure like that. Sure, I'm gonna let that run. Oh. Okay. This is crazy. Okay. It wants us, oh, it's just telling us this is the folder structure. So let's build the basic Express app. So can I enter? Let's look over it quickly. In memory, everything to do. Or a get request, a post request, a put request, a delete. And then, okay, now it wants us to build the React component. So apply both of these. Accept file. So it built the React component. Add some basic styling, sure. Is this going to apply at both of these? Or just one? Whatever. Trust the process. Okay, we have the basic front end and the basic back end. Now we actually have to set up the back end. Okay, it's going to run it. Okay. Create the React front end. I don't want to use create React app. It's just something more lightweight. Don't really want to use create React app. It's a little bit outdated. I don't want to use create React app. Is there anything else lightweight? Okay, yeah, yep, I like Vite. Run. Oh, what? Why did it delete? Okay, deleted some. Okay, now we have our front end and our back end. Cool. We're using Vite. Okay, it deleted the to-do. So we'll just say, add context and we'll say, or it, can you create the to-do app in the client? So we like literally went from an empty text editor. We're running things on the terminal. So apply that. Okay. Yep. Command Y. Accept all. Actually build the command. Accept. Accept file. Oh, these are, it's giving you different options. Okay. Create the styles. Cool. Now let's see what this actually looks like. Now it's even showing us how to run. It didn't run. Or, okay, we should be in the client. CD. Now run. Now let's look at this. Oh, wow, it looks good too. Okay. Dude, this is entirely from scratch. Okay, getting a CORS error and stuff. Let's just like, I mean, we didn't even start the backend yet, so let's just start the backend. How do I start the backend? Dude, people could build anything with this actually. Now we're starting the backend. Is it started yet? Still CORS. Okay, what did it do? Look at how much code it generated. CD server. Let's just add this here. Yep, let's run that. Let's run this. And let's run dev. Okay, we need to CD into the server. Let's run the dev. It's crashing. Oh, because something's already in use. Okay, let me close all these again, and then we're gonna start the servers. And let's just ask the AI to do it. Can you, okay, cool. Yep, this is proper. It's actually telling us to like, something else is listening to 5,000. We need to kill that one. Or let me run it on like 4,000 or something. Okay, run it again. Something's running on port 5K. Port. Can you refactor the code? This is pure AI generated. Okay, we're gonna use port 3000 now. And then it's saying we have to update our files here. That makes sense. To use port 3000 instead. Okay. Now reload everything. Now we can't. Now it's working. It's talking to the front end. It's talking to the back end, sending post requests to it. Let's see post request. But now we can't see anything here. But we can delete. Hello. Hi. Okay. Now we need to find that bug. Let's see if we can just copy and paste it here. What happens if you solve it? Oh, it's just the fonts are bad. The font is bad. Oh, you could just. This is crazy. The font doesn't appear. Okay, this is nuts. Okay. Apply. Refresh. There you go. Now we have to-do list. Go do groceries. Laundry. Then you could like be. I did my laundry. I did my groceries, and you can see like it's hitting our back end on running on localhost. What else? Yeah, this is crazy. Let's add one more feature. Can you introduce like light and dark mode laundry and be like check in Airbnb. Deletes work. If you refresh, it goes on there. If you create a new website and go in there, it's still there. Now let's add another feature. Be like create light dark mode for to do app. This is something I actually don't really know how to do, so let's see. Dude, this is crazy. Yeah, that makes sense. Create a context provider. So we're gonna apply that. Do a new theme provider. Command YYY. Command YY. Accept. Update the CSS. Command Y. Update the global styles. Command Y. Okay, let's see how it looks. Okay, there's a night and dark mode. Not working. It's getting close. Or I didn't accept certain things. Accept Y. That's kind of getting annoying that I have to. Okay. See how it works. Wow. I mean, I want the whole the whole background should turn white, but look at that. It's like it's a beautiful animation. Like, okay, wait. Let's see, the whole background should turn black too. The only thing is you won't be able to debug this if you don't know how to code, because you can't verify. Dude, this is nuts. Okay, apply. Accept Y. No, like, I want the whole thing. Did I miss any? Okay, wait, I need to... Why? Okay, there you go. What? Okay, it's still buggy. Let's see. This is not proper dark mode. Fix this. This is dark mode. Okay. Let's see. Apply. Accept everything. Okay, that part's working. But like, why is this background? Why is this background not working right here? See, why is this still white here? Like, it looks like it's a reverse. Oh, okay, never mind. This. Yo, chat, we back. I'm gonna get Paul to hop in too. Paul's gonna be asking me some. Let's see what it does. Math questions. Yo, Paul, what's good?
Yo, what's up?
One second. Let me connect my AirPods. Accept. Accept. Okay. Input. Yo, chat, can you hear me? Chat, the audio is good. I sound like a boomer every time. I'm like, can you hear me? Does it work?
Yeah, I think it's good on your screen.
Let me check. Wait, can you say something? I just want to make sure your voice sounds good.
Yeah.
Paul, man, what's good?
What's up, man?
Long time.
I got a good set for you today.
Bro, what's wrong with you, man? Why is math in these LeetCode? No, I'm just kidding. I need to get good at math. Hold up, let me fix something up. Yo, how you been? How's the job hunt?
I haven't been doing any. I've just been doing school.
Loki, like, I feel like someone left their oven. Give me a sec. I feel like someone left their oven on. Let me give someone a call real quick. For this boot. I don't really care. I just don't want the place to burn down in the middle of my stream. Because I'm not hopping off the stream at all costs. Give me a sec. Man, it's been a long stream. 6 hours and 45 minutes.
You're only half done.
Yeah. Straight up. Just getting started.
Are you going for like 10 hours tomorrow too?
Pardon?
Are you going for like 10 more hours tomorrow?
Yeah.
Jesus.
Bro, like, I haven't been streaming that much, so I'm feeling energized. I just need to take a little break. Then when I come on, like, I basically took a month off.
Yeah, you did. You were streaming there for a bit.
Let me grab my... Alright. I'm just eating some freaking... Give me a sec. Let me grab something. How's your ML course?
It was deep learning, so it's like specific to that, I guess. But it's all right. It's like it's a lot of like work, but it's not like hard, if that makes sense. Just a lot of stuff to do.
I see. Okay, I'm gonna send you this. Are you do you want to become like a ML engineer at some point? After that?
I don't know. Like from what I've heard, it's just a lot of like infra stuff. I don't even know if I'd want to do that, but I don't know. We'll see.
Okay, I sent you in. I'm eating like this orange stuff. I think it's antelope or whatever.
I'm not even gonna give you the constraints. It's cheating.
The hell? Wait, let me give an intro. One sec. Wait, give me literally like 30 seconds.
Yeah, you're good.
While I'm eating this thing.
Paste the question here.
God damn. Oh, I forgot to record. Alright, so what's happening in this video is that Paul, Alpha's father, is going to be asking me math questions. So this guy did math competitions when he was younger, and he's trying to put me through that same weird stuff he was doing when he was younger. So let me try this out. Could you explain the question, or you want me to read it and figure it out?
No, you can read this one. I'll try to explain the other ones because the other ones are like harder. I feel like this one's pretty. It's like a warm up.
Okay. Alice and Bob are playing a turn-based game on a circular field surrounded by flowers. The circle represents the field, and there are X flowers in clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction between them. Wait, let me like draw this out a little bit. It's already annoying. Whenever it says Alice and Bob, I'm like, bro.
Can I move this? And I hate Google Meets, like the little thing that pops up.
Okay, Alice and Bob are in a turn-based game on a circular field surrounded by flowers. So it's some sort of circle like this, and we throw Alice right here. We'll throw Bob right here.
Okay.
Right. So there are X flowers in the clockwise direction. So X like X. So it's like, see, there's like random flowers in the clockwise direction, right? And then there's Y flowers in the anti-clockwise direction. So that's like somewhere between these. These are the Y, right?
Well, that would be clockwise. Are you talking from Alice or
Oh,
Bob?
sorry. Wait. There's X flowers in the clockwise direction between Alice and Bob. And Y in the anti-clockwise direction between them. What? So clockwise, pretend. Wait, let me see.
Yeah. I think what you're going for is right.
Yeah, okay. So anti-clockwise is, so between Alice and Bob, if we're going clockwise, just there. If we're going anti-clockwise from Alice, we're going like this way, right? This is anti-clockwise. Alice and Bob, we're going this way. So X shows, so that's what it's saying, right?
Yeah.
Damn, are you dazed and confused on this one too, or no?
No.
Okay. I need you to be able to explain it too, because this is some hard shit. Well, I don't know yet. The game proceeds as follows.
This one's easy.
Alice takes the first turn. In each turn, a player must either choose the clockwise or anti-clockwise direction and pick one flower from that side. So Alice is going to take one from either side. At the end of the turn, if there are no flowers left at all, the current player captures their opponent and wins the game. Given two integers, n and m, the task is to compute the number of possible pairs x and y that satisfy the condition. Holy crap. Why is it n and m, but then it says x and y in here? But anyway.
Well, your x and y is what their x and y are not necessarily n and m. They're two different sets of numbers.
So we're given two integers n and m. The task is to compute the number of possible pairs x and y that satisfy the condition. Alice must win the game according to the described rules. The number of flowers x in the clockwise direction must be in the range 1 to n. The number of flowers y in the anti-clockwise direction must be between 1 and m. Return the number of possible pairs x and y that satisfy the conditions mentioned in the statement. What? What the heck? Okay. This is so weird. Okay, let me think about this. Let's work through the example.
All right.
So we're given input n and we're given input m. And chat, do not spoil it for me in the comments, please. In the chat. I don't want to cheat. So we're given, let's see. Alice and Bob are playing a turn-based game on a circular field. The circle represents field, and there are X flowers on the clockwise direction between Alice and Bob, and Y flowers in the anti-clockwise direction. So I'm gonna remove these.
Okay.
Because now that we ironed that out, in each turn we start Alice. Alice must either choose the clockwise or anti-clockwise. Either looks on this side or this side and picks one direction and one flower from there.
Okay. Yeah.
And so they just start picking turns.
Yeah.
If there are no flowers left at all, the current player captures their current opponent. At the end of the turn, if there are no flowers at all, the current... So let's look at... So what are the following pairs? X and Y. So X is the clockwise direction. So the first one is like 1 and 2. Right? So Alice goes first. So Alice chooses this one, obviously, and then Bob chooses this one. Then Alice chooses this one, and since they're the last person to choose, they win.
Yep.
Alice wins, right?
Yep. Well, no. Sorry. Could you repeat what you said? I think you might have had it confused there.
Wait, what do we return? The number of possible X and Y pairs to satisfy the conditions mentioned. Well, okay, if Alice picks green.
Yeah.
If there are no... Wait. How do they win? If there are no flowers left at all. Okay. So Alice is going to choose this one, right? He's going to choose this. Bob is going to choose this. And then Alice is going to choose this. Since Alice was the last one to pick it, and after Alice picks, it became 0. Alice wins, right? That's why the pair 1 and 2 works. Because we just need to return all the times that Alice wins.
Okay, yeah, I think you got it.
So honestly, we don't really care about... I'm trying to see. We don't really care about either side or the number on either side kind of thing. Because if this was 3, Alice would still win because Alice would pick this, Bob would pick this, and Alice would pick this and win, right?
Yeah, so how do we tell who wins?
Well, we can tell who wins based on, like, if it's odd or not, essentially. If it's odd, Alice is gonna win. If the number on each side, if you combine the numbers on each side, if it's odd, Alice wins.
Okay, sounds right.
So if we combine the number on each side and it's odd, then Alice wins. So what now we're just given N and M. We pretty much need to figure out the amount of combinations that we can make. Wait, what does N tell us? N tells us that that's how much flowers we can place on this side. So we can place 1, 2, 3. So n tells us we can put we can possibly put 1, 2, or 3, like anything under that, like 0 to this many, or no, 1 is just inclusive, 1 to n inclusive.
Yeah, it's 1 to n.
So yeah, we could put 1
0
to n here. And then for 2, we could put on this side that we can literally put 1 to 2 on this side, right? So it becomes a combination. Like given these, so one way to do it is like for every one of these ones, well, if we figure out how many, so for every odd number, so what we need to do is we just need to figure out based on these combinations, let's just do some simple math here. Based on these combinations, 2 times 3, how many possible combinations is actually possible? Well, it's just 2 times 3. We could have 6 possible combinations here, right? We can have 1 and 3, or 1 and 1, 1 and 2, 1 and 3. Like 2 times 3 equals, but these are just all the combinations, right?
I wouldn't. Okay, I guess.
There's 6 possible combinations between that. We essentially, it's the result is going to be less than that.
Well, 6 would imply that you're able to use 0.
Wait.
Hey, never mind. I guess you're kind of right here.
Yeah, so there's 6 combinations. There's like 6 different pairs that you can create, but only some of them are like you need to add up to the even. So now I just need to figure out how do we quickly find based on these numbers. It could be let me think of a brute force solution, and then maybe you could optimize it to just like a single calculation. But we just need to see based on like n and m, like how many odd combinations between like the pairs we can create.
Yeah.
Right. So let me see if I can, let me like write it out quickly so I can see. So like pretend this is 1. So we have 1, 1. So if we just have 1 here and we have 1, we could do 1, 1, 1, 2. Right? If we put 2 here on this side, we have 2, 1, 2, 2. If we have 3, like these are the possible combinations, right?
Yeah, that's right.
And then like if we add these up, we only need to care about the odd ones. So this is 1, 2, 1. This is odd. So this is even. This is even. This is odd. Right. So the result here is 3.
Yeah.
Okay, so now the main part I'm thinking is like how do we easily find out like how many odds we can create given that. So what we can do is maybe we can loop through 1. If we have 1, we could just figure out how many even numbers can be made out of this. And you could just do that by dividing by 2. So you could be like, for 1, how many even numbers can I make? I can make 1. And we do that and then for 2, how many even number or odd numbers I can make if I had 2? Well, I can make 1 if we just divide this by 2. Right. So we could just ask that question for every single element. We could be like, okay, if it's an even, how many odds are there in the like how many odds are there on the other side that I can make by taking like y and dividing that by 2, taking the floor.
Mm-hmm.
That'd be like a O-Venn solution if we take this smallest one. Does that make sense?
Yeah, that makes sense. I'm just wondering, do you need to necessarily, like, if you know the calc beforehand, does it need to be O-Venn?
Yeah.
Like, if you know exactly.
Yeah. If you know how much evens are here, how many even numbers are here, it's like some weird calculation. Pretend I know how many evens. Basically, what you need to do is be able to calculate how many evens are here. Evens times odd. Because that will produce an odd.
Yeah.
And then odds, how many odds times even? Because that will produce the odds again. So that's on one side. And now I'm just wondering if we need to do it for the other way. I think just that will just solve it right there.
I think you're right.
Yeah, like you do even. You just calculate the even and you multiply it by how many odds there. And then if you just know how many odds, just calculate by how much evens. And from there, that's the result.
So you're saying to add those two, or what are you saying?
Add those two? Yeah, we have to add those two.
Okay. Yeah, because you had like an equal sign there. I was like, I don't know what the equal sign up there is.
Yeah, you have to add these two results.
Okay.
And then how do we calculate even? Well, we just pretend we just take 8. No, I mean, we divide it by 2. We take an integer division. So it's between 1 and the thing, right? So we need to minus 1. So this equals 4. Actually, this would, let's see, evens. This would equal 4 evens if we just divide it by 2. But actually, we just care about... We just care about 1, 2, 3. We just care about 2, 4, 6. 2, 4, 6, and 8. Okay, dividing it by that works. How do we keep track of how many evens there are? So if we do 8 divided by 2, this will get us evens between 1 to n. Now I just need to see how many, if it will calculate the odds correctly. So how many odds are there? Well, there's 1, 3, 5, 7. So there's 4. Does that work again? So I think you just divide it by 2. Like you just do this. Let's work on 9.
Yeah, I was gonna ask, would that work on an odd number?
This will do 4, right?
Yeah.
Because we take the floor. So 9 divided by 4 equals 5. So if it's odd, we just need to plus 1.
Is there another way of doing that?
Take the ceiling. Yeah, we could just take the ceiling.
Yeah, it's a bit like, I don't know if, I'm pretty sure Python, I don't actually think Python works this way, but like you could just integer divide it. Yeah, just anything like that works. Ceiling works too.
Yeah. So that's the solution. I'm going to go ahead and implement that.
Okay. Sounds good.
Damn, 20 minutes for that? Holy crap. I'm cooked.
Python, oh, okay. I thought that was true alpha, I just wasn't sure. Yeah, because that's converts it to decimal by default.
What we'll do is evens. So like I mentioned, we're going to have... Let me see. Is this an easy question?
No, it's medium.
Oh, really?
It's like 1570 elo or something. 1581.
Wait, how do I get back to the whiteboard? So, what we said we're just gonna do evens times evens. Oh, even time odd. Odd times evens. So what we're gonna do is we're gonna calculate n evens. We're gonna calculate n odds. Then we're gonna calculate m evens. And then m odds. How we're gonna do that is we're gonna do like math.ceil. Ceil function. And then we're gonna take n divided by 2. We're literally gonna do this for all of them. So n. Wait, for evens. Oh no, for evens we just divide. For odds we take the ceiling.
Yeah.
Right? And then we just literally return n evens times m odds plus the odds times m evens like that. Then just run solution and m. But can I use the AI assist to just make sure I'm calling the ceiling properly?
You're doing it right.
Okay. N is not defined. Oh, so dim. 1.
That's good.
3, 2.
Seems you're getting the wrong thing.
Wait. So I take the evens and I multiply that by the odds. I take the number of evens and I multiply that by the odds. I take the number of odds and I multiply that by the evens. I'm just gonna quickly print this out.
Okay.
So pretend this is 9. Oh shoot. I did this in so good.
I was gonna tell you if you didn't catch it after a little bit, but you caught it. Yeah, that should work now.
Let's get it. Next one.
If you're curious, there is a one-liner. There's just
combine these, right?
M times n floor 2.
Oh my god, how does that work?
Well, because you're basically taking every combination of 1 to m, 1 to n. Let me just write it down here. Like 1 to n times 1 to n. And basically half of those will be an odd, comma, even because of the nature of like odds and evens being half of numbers. So half the combinations will be the same and half will be different. So you can just divide this by 2 and it gives you the same answer.
You're right. That's crazy.
Yeah, I don't think anyone would expect anyone to get that though.
Kind of makes sense if I like enumerated it out.
Yeah, like if you had more time to like think about it, you'd probably.
I was thinking more about it in the terms of like in the circle.
Yeah. Yeah, like if you had more time, you could like if someone said, "Oh, there's a one-liner," you could probably get the one-liner.
Any feedback? How was that first approach?
That's pretty good. I don't think you were like slow. definitely like good for interview context. I think like yeah, you were able to pick up the pattern pretty quickly in terms of just multiplying the evens times the odds plus the odds times the evens. And I think you probably would have figured out that it was O of 1 before I said it was O of 1. I just said that too early, I think. But I think you would have figured out you didn't need to do an O of N loop.
Nice. All right, let's get in that next one.
All
That's
right.
just the warm up, right? Is it gonna get harder or similar? Because that was almost my maximum mathematical ability.
I'll go a little bit harder, and if you get this one, I'll go crazy just for fun. All right. So for this one, I'm just gonna like over the basics. You have two positive integers left and right, and you want to find two other integers, num1, num2, such that num1 is less than num2, and they're both between left and right inclusive. So these are like your left and right bounds, effectively, for the numbers. And both numbers are prime, so it's two distinct prime numbers within the range. And then num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. All right. So effectively what that means is you're finding the two pairs of primes within this range that are the closest together, like the two closest primes within this number range. And you want to return just both of the primes as an integer, num1, num2, or like as an integer array rather. And yeah, there can be multiple primes. Just return the smallest one. And if there are no pairs of primes, you just, like if say there's only one prime or no primes in a range, you just return -1, -1.
Okay, all right. Let me read over the question quickly. That was a really good explanation, but I'll have to read as well. We're given left and right, so these are kind of the boundaries. So there's like 10, 19. Find two integers num1 and num2 such that num1 and num2 are not the same numbers, and it's between this inclusive. So we're looking for any values within the number range of 1, 12, 13.
Yeah, it is
13,
inclusive.
all the way up to 19, right?
Yeah.
It's like pretty much in this number range.
Yeah.
Then all we need to know is we need to find prime numbers between these. And both num1 and num2 are prime numbers. Num1 is a minimum amongst all other pairs satisfying the above condition. Return the one with the smallest num. If there are okay. So, I mean, one thing we could do is literally something like for I in range 1 or left inclusive to right +1, because that's going to include that boundary. What we're going to do is we can just calculate, we'll actually come up with the primes and push them into some sort of array. We'll be like, if I is prime, push it into the array, right? So this is the first loop, essentially generate primes between left and right. Once we generate the primes, it's pretty simple, like two-pointer solution. Pretend we have like the different primes. Return 1 2. This is the brute force. What are the primes here? 11, because what's a prime number? A prime number is divisible by itself and 1, right?
Yeah.
Prime equals divisible by itself and 1. So 11, 12, that's not prime. 13 is prime. 14 is not prime. 15, not prime because it's divisible by 5 as well. 16, not prime. 17 is prime. 18 is not prime. 19 is prime, right? These are the 4 prime numbers in here.
Mhm.
I mean, these two have a distance, and since it's already sorted, we could just compare adjacent ones to see. Wait. Okay, since these are already adjacent, when we like if we just like compare each to the adjacent, we should be able to find the minimum. So this is 2. These are 4 apart, and these are 2 apart. So 11 and 13 is the smallest. So what we can do 2 passes. The first pass you just figure out what the smallest distance is, and the last part you just return on the first time you see something with that smallest distance. So that will lead to, if we were to generate this, that would lead to like a O of n times how does, like, how much does it take to generate a prime? Like, how do you?
So you're saying how much does it take to check if it's prime?
Like, one thing we could do is like we can just generate the primes first. We could just generate the primes and then only look at, we could generate primes up to 19 and then like only look at the range between that and 19. How we would generate the primes, I mean, there's multiple algorithms, and if we decide to go with the solution, I can talk about that. But I think that's my brute force solution, and it's gonna be like the bottleneck is generating the primes.
Okay.
How's that solution sound?
I think that solution sounds good. I'm just interested in how you're going to generate the primes.
Let's see. So like one way we could do it is, okay, what is a prime number? A prime number is any number that's divisible by 1 in itself, right?
Yeah.
So that means, another way to look at it is that there isn't a smaller number that's a multiple of it. So for 25 is a multiple, like, right? So 5 times 4 equals 20. So what we could do is we could initialize some sort of array of 1 to 19. So like 1, 2, 4, 5. And it could just be x's, right? Or falses. This is true right here, right? False. We could just initialize this something like this.
So is this like the prime for?
Basically, what I'll do is like for 2, right? So I'll just like set these to true because these aren't prime, because
So you're marking true for prime and false for non-prime?
True, or sorry, it'll be false. True means prime.
Okay, yeah.
So true means prime, right? So if this is, okay, we'll start everything off as a prime. Shit. So it's going crazy. Are you watching a show?
Me?
Oh yeah, I just hear something in the back.
Oh no, it's my girlfriend. She's like watching something in the other room.
Oh, no worries. Thought it sounded like your brother. But what we're gonna do is we're gonna have true, right? True means prime. So what we're gonna do is for 2 here, we're gonna mark this as false. And essentially what we're gonna do, this is, I guess it's like a log of n solution, because we're just gonna keep multiplying by 2, but we're gonna do this. For all the multiples of 2, we're gonna mark those as not 1, right? And then for 3, we're gonna do the same thing. So 3, and then we're gonna times it. We're gonna keep multiplying that by 3. So 3 and then 6. And essentially what it's gonna do is it's gonna generate a list of the prime numbers between that. And that solution is, since we're gonna be operating n, but it's gonna be n times like log of n, because it's gonna be like exponential. We're gonna be like, exponentially finish it, something like that.
Okay.
So
I will say there's faster ways to do it, but I guess this works as well.
there's faster way to generate the prime.
Yeah. I mean, you could just. I mean, we could just go with this one because I mean, I don't think it really matters that much. But just in case you're curious, like, there's a method. Like, basically, you could just create a is prime function and just loop through all of the numbers up to the square root of n and see if it divides into them. And that's like O of n square root n. And you could just cache that function, or even you don't even have to cache that function necessarily. And then there's also like something called the sieve of Eratosthenes, which is like O of log n, but you can
I
just
feel like this
go
one
with
would
this.
be like only 2 is gonna be log of 2n, right? But when we do 3, it's gonna be log of 3n. When we do log of 4,
Yeah. Well, I'm saying it's like O
O.
of log, like O of n log of n. So it's like the log of the log.
Mm-hmm. Yeah.
But I mean, I don't think we can go over that another time. Probably just go with this. See if you can code it up.
See if I
I
can
think
code
this
it
will
up.
work.
All right. Okay. So let me copy and paste my algorithm here. Yeah, I think all we need to also what we need to do is let's see. Let's do def solution. So we're gonna be given a left and a right here, right? So we're gonna be given primes. So let's just say def generate primes. So how do we generate primes? Well, we want to generate primes up until an n, and then so we'll do primes equals for I in range n. That'll produce, if it's 5, it'll produce 5 elements. Yeah. And everything's a prime essentially, right? Everything's a prime. Or go ahead.
Yeah.
Everything's for I in range n. We return true. So now what we're gonna do is for I in range 2. I think you kind of hinted at is like you don't really need to go all the way up to n because pretend if I have 10, right? I don't really need to. I don't like after 6. If I multiply anything, if I go 6 times 2, it already goes over 12. I don't really need to look at that. So I kind of just need to go like by n divided by 2 or something. Wait. Nah, because if it's 20, what if it's 50 or 100? Whatever. I don't need to optimize it right now. I think at some point we could just adjust the right boundary here.
Yeah, for sure.
Like n divided by 2 or something. But we're going to loop from 2 to n. And what we're going to do is for every single number, pretend we start at I. We're going to be like while current element. We'll do multiplier equals 1. While I times multiplier is less than, while I times multiplier is less than equal to n, what we're going to do is we're going to do primes times I minus 1 equals false. We'll do multiplier. So for example, for 2, we're going to do 2 times 1 is 2. Then we're going to, so we're going to do 2 times, like, it's 1 index, 0 index, so we have to do that. And while I times multiplier is less than or equal to n, we just keep incrementing. And then that should generate us our primes if we do that for every single I.
Yeah, let's see if your primes function works.
And then we'll just return, like, we'll just do primes, and then we'll do left to right plus 1. Because what we're gonna do is like.
Oh, I see what you're doing. Yeah.
We're just gonna. I have to fix these bounds because if they pass in 0. Oh, we just have to do -1 because they're gonna pass. They're gonna pass in like 1, so it starts here, and then I think it's just this. So let's just print. Let's just generate the primes for. I'll print this. Let's just generate the primes for 10 to 19.
Yeah.
And what the heck? I don't even care about that actually. Wait, where's this? Right, plus 1. Yeah. N. Where's N? Let's just initialize N then. Dude, there's like some off by ones here. Oh wait. It's all false. Okay, wait. So if we pretend N is 19, right? So we want to generate 19 elements. So this is going to be 19 elements. And then we'll go from 2 to N. And then here we're gonna go to 19. So we need to do plus 1. So that'll include 2. It'll go for everything from 2 to 19.
Mm-hmm.
We're gonna do I. So we're gonna start at 2. We're gonna start at 2, which is sorry. Yeah, we're gonna start at 2, and we're gonna start multiplying by 1. That equals N. And then we're gonna okay, what's 2 times 1? 2 times 1 is 2. That's less than N. So we say that's false. Like the main problem is everything is false. So we're not capturing the case. So we do need to do the divide. We do need to capture this bound properly. Right?
Yeah.
Otherwise, we just like go through the whole list. So I think this will be. Let's see what happens if we divide it by 2. Wait. Okay. Let's just do simple 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to generate all the primes between 1 to 9. That's essentially 1, 3. 1, 3, what else? 7, 9, right? Those are the primes, right? 1, 3, 7, 9. 1.
No. One's not prime, 2 is.
2 is prime?
Yeah, and 1 is not.
1 is not prime?
No.
Yeah. I gotta go back to my math class. 4, 5. 5 is prime because it's only divisible by 5 in itself and 1. Right?
Oh yeah, I didn't see you're missing 5. My bad. And
7.
9 is not prime.
Yeah, you're right. So because it's divisible by 3. Okay, so if we have let's just print out primes here. I'm gonna do like this. Holy crap. Okay, we print out the primes here. We're getting 1. Let's do it for 1 to 1 to 9. That should print us 1 to 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all of them are prime. You say 1 is not prime?
No. Also, you have 10, 9 here. I'm just going to put that as 1.
Where?
Well, like you had 10, 9 for
Okay.
generate primes. Just change it. I don't think it
So
matters right now,
prime
but just change it.
equals, this is false, right? So 2. 2 is a prime. Why is 2 a prime?
It's divisible by 1 and itself.
Yeah, 2 is divisible by 1 and itself. So can we actually do this? Do we do 2? Because if all of these are false, wait, I think I messed up my algorithm. If we instantiate all of these as true, is true, 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 true. Well, I think the first step is actually mark it false then. And then mark the rest as true. So this is going to be false. Or sorry, all of them are false. That means they're not prime. Okay. All of these are false. Holy.
I think you're going in the wrong direction here. I think you were going right direction first.
Well, like all of these are false prime, right? So
yeah, but you don't want to instantiate them as that.
You don't want to instantiate them as false. Because what I was gonna say is, we're gonna, for 1 we just do true, right? For 2 we leave it, but for all multiples of 2 we just. Oh, sorry. All of them should be true prime. Bro, I'm getting cooked. Okay, true. Okay, we start 2, right? And instead, we just leave this as true, but we just start converting all the multiples as false.
Yeah.
And then we get to 3. 3, we leave it as is, but then we just do all multiples. So 6, 9, false. 4 is the same thing. Well, it's already false, but anyways, we'll go 8 and we'll do false. 5 is the same thing. We like when we're at something, we don't turn it into false. That's the main thing. So we have to start the multiplier at 2.
Yeah, exactly.
So if I generate the primes, it's between this. Two, 3. What happened? Why is it 5 and 7? Wait. Whatever. I'm just gonna take it all the way to n. Wait. True, false. Okay, 1 is true.
I think it's because right here you're returning. You're looking at the wrong numbers.
You're right.
I think that's why you're confused a little bit.
Bro, the hell? Okay, we're going from 2. We're doing I. Okay, let's just. Where's n? Okay, so 1, 2, 3. This should actually be prime. Why? How did it get to false? Because we went. Oh, what am I doing here? This.
Yeah, there you go.
Holy.
That should be right.
1, 2. And then we'll say for and we'll just do a filter here. And then we'll do a filter of x. We're gonna do a filter of like this. We're gonna be given our primes.
Okay.
But we're gonna
Going some Python. I like this.
We're gonna do lambda x. X is between x is greater than or equal to the left and x is less than. So we just want to keep all of the x's that are between those. If oh no, that's kind of dumb. What the heck did I do? I have to enumerate. Let me hit the enumerate. That was dumb. Tried to get fancy for no reason. Bro. Okay. What's the time? Oh shit, went over. What we're gonna do is for I.
Oh yeah, we did go over.
For I. What we're gonna do is yeah, I got cooked. For I in result equals enumerate the primes. What we're gonna do is like if result, if the result, and we don't care about 1 at all, right? Do we care about 1?
No, we don't care about 1.
So we're always gonna take the primes here and we're gonna go like that. If the result equals true, that means it is a prime. What we're gonna do is result dot append I plus 1, and then we're gonna return the result here. Wait. Oh, we already removed it. That's what we do. Oh no, this is cooked. 1, 2, 3, 5, and 7, and then we just remove the 1 here. Holy crap! Okay, we generate the primes. Now we have our solution here. For the solution here, we're gonna do primes in range. What we're gonna do is we're gonna call generate the primes of left and the right. That's gonna generate the primes between the left and right. So we're gonna calculate minimum distance, and then that's gonna be float infinity at first.
Yeah.
Say for I in range length of primes in range minus 1. What we're gonna do is we're gonna compare adjacent elements. So we're gonna say min distance equals the min of min distance and primes in range of I plus 1 minus primes of range of just I here.
Alright.
Then what we're gonna do is like for what are we gonna return? The first pair or negative 1?
Yeah, the first pair. Or minus 1, 1 if there's no min dist.
Negative 1, 1 here. So what we're gonna do is we're gonna do kind of the same thing here. For I in range like that, if we'll So just so we're not shadowing the last one. My variable names are just trash right now, but right element. Primes in range like that. If the right element minus the left element equals minimum distance. If the right element minus the left element, the distance between these is equal to that, we just literally return left element.
Yeah.
Right. Something like that. Got cooked. Let's see.
Hey, you were doing pretty good there for a second, and then you just got caught up trying to create the primes. You got like you started with the multiplier equal 1. I didn't want to like give you a hint too early, and then you like went crazy.
Multiplier equals 1.
Yeah, that was what really like cooked you is whenever you because like you had it pretty much you were good to go until you did this. I think you.
Oh, left and right.
I think it's because you have this.
Where?
Like line 77 here, I think is what's cooked, or at least you could fix it with line 77.
Let's see. Let me just see what primes in range. What? Oh, okay, because it has to be like left. Oh, oh, wait. Oh, wait. If
I guess no, I guess it wouldn't be that though.
If
yeah, probably just right here.
If I is less than left, or I is greater than right, continue.
Yeah.
719. What's the result?
It's 1113. So I think you probably want to do like. I think you probably want to do res. Whoa, no, not res.
Plus one right here. Right?
Yeah, +1.
Oh damn.
Usually people will like create as one indexed array, so they'll just add an extra element so you don't have to deal with all these off by 1 things.
God damn. I enumerate primes. I plus 1.
I think it might be I minus 1 rather. I don't know.
I minus? Well, 0.
No.
When you look at 0, that's 1.
Is it?
So we do if the prime number or if the candidate number is less than, or sorry.
Oh, okay. Well, no, you don't want and.
Wait.
That'll never continue.
Bro, what the? Oh,
Nah, it's just gonna always continue.
Wait.
You had it right before with the or. I don't know what's.
Wait, let me print out the primes. Well, it's only printing out 13, 17, and 19.
Yeah, so it's skipping 11. And you're starting at 10 here. Okay, just print primes here. I was curious if it's like skipping 11 in here or if it's skipping like whenever it's creating. So no, it has 11 as prime. See.
Is it here? Prime number if.
Prime num less than.
Does this include I right here? Wait. Did I?
Oh no, it's because you're doing this. It's because you're doing this now. You don't want to do this because you're.
Oh shoot.
That should work now. Yeah.
Got cooked. Generating primes, man.
Yeah, you're doing yeah. I think like easiest way to do this is instead of doing this, you just do true for range n plus 1, and then you would just use like you would just use the actual number. So you would have like index 1 equals 1. That way you don't have to deal with all these off by 1 issues because they were like they were kind of cooking you everywhere.
Goddamn.
There's also like faster way to do this. So in this algorithm here, if you do like I times multiplier, so effectively, huh?
I times I.
Yeah, so you start with the square of the number, and you only go from that. It'll actually end up catching everything, and this is how you make it log n, is by you start with the square root, and then you go up from there, or you start from the square of the number rather. It's also why I was confused why multiplier equals 1 wasn't working, because if you do it this way, you start with multiplier equals 1. You don't actually well, I guess you wouldn't actually do this. You wouldn't do multiplier. You do primes of I times I plus I think it would be in this case I, or I times multiplier, and then you would start with multiplier equals 0 here, just the way you have it coded. Usually what you do is you do like a for loop. So you would do for I, like j in range, I think it would be like I times I, and then you would go to n. Yeah, that works.
I see.
I think, right?
Damn, yeah.
Yeah, so you'd start like with I times I, you'd go to n, and then for your increment, you would use I. So you would just go up by I each time, but you would only start with I squared, and it makes it faster. But like that doesn't really matter.
Yeah.
I think overall though you did pretty good in terms of like knowing just generate the primes is probably your best bet. You just kind of got cooked by the way you were generating the primes. I think like honestly, if you just study the sieve of Erasthenes for like 20 minutes, it's pretty easy to memorize it. It's like pretty hard to forget in my opinion. And then you just always know it, and it's like pretty much anytime you want primes, you're just going to want to generate the primes. Like if you want the primes in a range, you just want to generate them all. It's probably faster than anything else you could do for like 95% of problems.
Damn.
So this is like the right approach. Just if you study the sieve and you memorize it, it's super easy to not forget. And then you probably would have gotten this question in like 10 minutes, realistically.
Yeah, like I'm pissed at myself. I could have got a good higher on that, and I failed it.
Yeah, you could have gotten a pretty strong higher there. But I mean, I guess they're not gonna ask you this type of question at like a FAANG. But if you're like interviewing for quant, I could see them asking something like this.
Telling you to generate primes.
Yeah, just like math stuff for LeetCodes.
Nice.
I feel like they would probably be more mathy.
Yeah.
Overall, I think you did pretty good. Like I said, you had the right idea. Just memorize it. Also, like, I would just recommend doing this. This is so much easier.
Yeah, that messed me up bad.
Yeah, you kept getting like everywhere you were getting cooked by this. Just like all not really here, but like up just everywhere in here you're getting cooked by I+1, I-1, just everything about it.
Yeah, at some point I literally just snowballed. I couldn't even solve like very simple off by 1.
Yeah, like after I think like you started at 2, like multiplier equals 1, and then you were like, oh, I don't know what to do here, and then you started like oh, I'm just gonna like initialize these all as false.
Mhm.
you're just everywhere after that.
Yeah.
Like made you lose your mojo.
Yeah, but then you realize that you have to do it with multiple too.
Yeah,
Alright.
because then or else you're just
Everything
turning the
false.
whole array into true or false rather.
Nice. All right. Thanks, Paul. Gonna
Yeah, no
pick on the
problem.
next person. Yeah, let's do another one another time. Take on some even harder math questions if you got any.
Yeah, I got some harder ones lined up.
All right. All right. Peace out.
All right.
Thanks
peace
for
out.
running that. Yeah, I'm gonna ask people this question. Should I add that to the 75 list? Who's next? Yeah, I might have to. That's a good question. 3 more interviews. How long has this been? 8-hour stream? 3 more interviews. What would that solution be, Alpha? If we had to do it like that. Let me... Yo, Shabaj, what's good? Yo, I can't hear you.
Yo.
What's good? What's good?
Yo. I'm just chilling. You?
I'm chilling too. Let me get you up on the screen. Just got cooked by some math questions. Were you watching that?
Bro, yeah, bro. I think I struggle a lot with math and like combinatorics. I was doing a mock interview before, and I got asked like the guy asked me like a combinatorics question. I was just like I got the answer, but like took a lot of time.
Yeah.
Like, well, like graph and like graph questions, I do pretty well. I remember like last time he asked me that like Dexter question he asked someone else. I didn't know this, but I was like able to like just like do it like my own hacking solution and worked on LeetCode. So like with graph kind of questions, I do well. With combinatorics, bro, I get like one shot at. So
yeah,
I have to like work on that part. That's cool. It's cool. You know, you learn where you're not good. So it's all good practice.
Facts.
Yeah.
Setting you up on my stream.
Put the face cam up.
Oh damn. All right. What kind of interview do you want to do? You want to do a coding interview? You want to do a system design interview?
No. Coding. So I have a coding interview coming up, and I'm only supposed
really?
I'm only allowed to use C++.
You're only allowed to use. Oh, is this like a quant role or something?
No, but like I'm just only allowed to use C++.
All right.
I think it's gonna be. It's very hard for me. I mean, I gotta reach out to those if I want to do it.
Yeah.
It's I don't know. I think what I've learned, what I've searched, like they just like to ask a lot of like DP questions or graph questions.
Are you allowed to say which company or no?
I don't want to jinx it. I'll tell you after. I'll tell you after.
Okay. All right. Okay.
It's not a quant. It's not.
But it's a good paying job essentially.
Yeah, I'm not. I don't want to move to New York just now.
Yeah.
Yeah.
All right. I'm gonna start this up. 3, 2, 1. Hey everyone. So today we got Shabaj in the building, and yeah, could you give a quick background on yourself for the chat?
Yeah. My name is Shabaj. Wait, hold on. Can you like, can we redo the video? I just want to make one thing clear.
Why?
The video?
One take. Why we don't do second
no,
takes?
No.
Like, what do we need to make clear?
Wait, hold on. Can I like text this to you in
Okay.
Gmail chat, but like don't reveal it on stream.
Yeah, just email it.
On Google Meet chat. Google Meet chat. I just only want you to read it.
I'm gonna send you an invite to the coder pad. Yeah.
Hey, all right, cool. Yeah. All right, go. We're good, bro. We're good. All right, let's do it.
2, 1. Hey everyone. So today I got Shabaj in the building. So we're just gonna do a coding interview. Yeah, just want to give a quick background on yourself, like maybe where you work, what school that you went to, how many
Yeah.
leak codes you solved, etc.
So my name is Shabaj. I work at AWS. I went to state school in California called Cal Poly. I graduated with a degree in computer science there. Graduated 2023, so I've been out of school for 2 years. I've solved about like 300 lead code. Most of it was during while I was doing internship prep, so covered most of Blind 75 and all the popular lists. All of this was in Python, so now I'm trying to practice these questions in C++. So we'll see how good or bad I do.
Sick. All right, so I'm gonna pick from the Peralta 75 list that just dropped.
You made a new 75 list?
Yeah.
Oh my
The
god.
new improved, new
It's
age
the proper 75?
Proper 75. I looked at all the questions that I ever solved and came up with my own list right there.
The proper 75. That sounds like a whiskey, like a whiskey brand.
No, I just called it Peralta 75, like for my last.
The Peralta 75. No,
Yeah.
see, when you say Peralta 75, that sounds like a firearm. I don't know.
Yeah, maybe
Like,
I'll change it.
a shotgun. Proper 75 sounds like an Irish whiskey.
I see.
Or Scotch. I don't know.
So I'll put it on. Everyone, go tune in. Go check it out. Yeah, it's a lot of syllables, but what I'm gonna do is pick a few questions. How many C++ questions have you done? I just want to see how easy or hard I can go.
For the most part, it's just like understanding how the different data structures and the standard library work and what sort of operations you can do. So I was able, I from the original Blind 75, I think I covered like 60 of them. So I'll be.
I'm talking about in C++.
Yeah,
you already did C++. Nice.
Yeah. No, because the major challenge is not about solving the problem; it's just about like the coding part here. Like, how do you work with a heap in C++? How do you like work with a vector, or vector is a list? How do you work with a map or a set? So those were the syntax is all you need to figure out, and some just little quirks.
100%. Let's go through. Good question. All right, we're gonna warm it up with C++ just to make sure that you have the right.
Are we gonna do a sanity check to find out how to do? How do you reverse a linked list in C++? Imagine I get cooked.
All right, first question. You're given a root of a binary tree with unique values and the values of two different nodes x and y. We need to return true if the nodes x and y are cousins or false otherwise.
Oh, okay. So given the root of a binary tree with unique values and the values of two different nodes of the tree x and y, return true if the nodes corresponding to the values x and y in the tree are cousins or false otherwise.
Exactly.
The two nodes of a binary tree are cousins if they have the same depth with different. Are these so with different parents? Note that the root node is at depth 0. Okay, so just so I understand, we have a single tree, and from that tree, we know two nodes, right? Like, is that?
You can go into drawing mode too.
Oh, drawing mode. Oh,
might be easier.
So we have one. So it's like we have a single tree. We have a single tree, correct?
Yeah. Delete some.
Where do you? Okay.
Okay, let me draw out the tree just because.
Okay, yeah. I'm watching you.
I'm already used to this.
You fast.
Yeah.
I hear sirens. Bro, is it the protests in San Francisco? I see sirens in the background.
There's always just sirens around me. I'm pretty far.
Bro, you live in a sketchy part. I never hear sirens in the marina. I don't know what part of the city you live in.
All right. Okay, we're gonna be given two random nodes here, and we just need to be able to tell if they're cousins.
Yeah. Okay. So, if are 2 and 3 cousins, it doesn't look like both of them don't have the. Well, both of them have the same depth, like from the root node. Both of them are at depth 1. but like the two nodes are cousins if they have the same depth. So in this case, 2 and 3 have the same depth, correct? Like they have depth 1, right? If you start from 0, if root is at depth 0, 2 and 3 are depth 1, correct?
Yeah.
But they have the same parent, so that means that they're not cousins, right?
Yeah.
Okay. They're so they're not cousins. Oh, okay.
What about 2 and 6?
Okay. What about 2 and 6? Well, they're not at the same depth, so that check fails off the bat. So
Okay.
they're not cousins.
What about 4 and 5?
4 and 5, their depth is the same from the root node. So 0, 1, 2, 0, 1, 2. So 4 and 5 are at depth 2, but they have different parents. So 4 and 5 should be cousins. Is that correct?
Yeah.
Okay, I understand. Okay. So it looks like what we need to just figure out is we need to keep track of two things for a given node. For that given node, we need to see what depth that node is from the root, and we just need to keep track of who's the parent of that node, and then we can just store this information and then just do we can store this in a map and just do a lookup and just return true or false.
We write that down. What did you say you're gonna do?
Okay. Yeah, so we can traverse the entire tree, and we can traverse the entire tree. We can at each traversal, we can store info about the parent of the node and the node's depth. So in this case, 4 and 5, they're at 0, 1. They're both at depth 2.
Yeah.
So 4. So let's just say if this was like depth map, and 4 will be at depth 2. Node 4 and 5 will be at depth 2 as well. And let's just say this was like a parent map. 4's parent would be 2, like node 2, and 5's parent would be node 3. So probably and then if you say like you've given like nodes X and Y, all we would probably, once we build both of these maps out, we can just return depth map of X equals to depth map at Y, and parent map of X is not equal to parent map at Y. So, something like this. Does that make sense?
Yeah. What's depth map? So depth map tells you for
yeah, just something like this. So let's just say we make a depth map to store, like we can combine this in a simple like single map, but depth map just tells you it just stores the information about the depth of a given node, the parent map. And right, like that's the only condition, right? They just need to be at the same depth and their parents need to be different, right? That's the only condition, correct?
Same depth and their parents are different. Yep, exactly.
Okay, so and with this, the time complexity would be, if the tree has time complexity would be O of n, where n is the number of nodes in the tree, and space complexity will also be O of n, because we will be building these two maps to store the information about the tree, but let's just say if we had the requirement of not using these maps, we're not allowed to. Even traversing the tree would be, because once we do the traversal, and if we traverse the tree, and we use recursion, the maximum, like at worst, the stack, the DFS stack could have all the nodes of the tree if the tree is just a single linked list. So if a tree is a single linked list, so the worst time complexity is also O of n, where n is the number of nodes. Does that look good, or do you have any concerns or any?
I think it looks good. Let's go ahead and implement that.
Okay. Do we okay? Let's do we want to define the tree node class? Let's just do that. Tree node. So
Yeah,
it will
define
be,
everything, and we're gonna run it on some test cases.
oh, we're gonna run the code.
Yeah, 100%. We'll see. We'll see how I'm feeling.
We'll see. No, I'll write the code, but it's like, but this is good too. Like, you know, is my code like? Can I write compilable code off the bat?
That runs and works.
Yeah, yeah, yeah. And I think so. We're going to have left and right, and we will probably need a constructor for this. We need a so tree node. Let's just say int.
Eat my fruits that I didn't get to eat last because I just had to do some freaking math questions.
Okay. So we have this struct, and then it will be let's just say a return bool. So our cousins, you're gonna pass in two nodes. So tree x, tree node x, tree node y, and then the root of the tree, right? We will also pass in the root of the tree, correct?
Yes.
Okay. Let's just say if root is null pointer, let's just return. I guess if like we can just return false. If I don't know what else could be the edge case. Like if x is a null pointer or y is a null pointer, we can also return false. Now we can just we can store pair map. And after that, once we have this, we're just going to do a traverse tree. So this should be traverse tree. Node. And so if node is null pointer, return just return, and then we can also pass in the depth of the node. Let's just pass the we can pass in the depth map. Okay. Now we're in here. We check if the node is null. We return, and then what we can do is depth map of node.val. Node.val is equal to the depth, and then we can come here. We can do if node.left and if node.right.
Yep.
Here we will do. We can set the parent here. Traverse tree will pass in node.left, depth plus 1, depth plus 1, the depth map, and the parent map. Same thing here. Pass in the right, We pass in, we do depth +1, pass in the depth map and the parent map, and we can set the parent here. We can do parent map of node left dot val equals to node dot val. And same thing here. So we can set the parent from here. That will set up with that will have all. We'll configure the depth and the parent. Now we can come here. We can do traverse 3. This should be root. Depth 0. Depth map. Parent map. Now there also could be the case like what if x and y are not in the tree? So we can also check for that if not depth map dot count. If depth map dot count, so we can just check for return false, because now we can check if both of them are not in the, like, well, both of them were never in the tree. We can just return false. And I think after that, we then need to return depth map x.val should be equal to depth map of y.val, and parent map of x.val should not be equal to the parent map of y.val. And I just need to, I'm just going to quickly Google what's the import for unordered map. I need to remember these. I don't actually know off the top of my head. Okay, you just do an include. Okay. Traverse tree. Okay. Now I have to put this at the top. Okay. And then we would need the main func too. So we have our cousins where our cousins, we check if their root is fine, if x and y are fine, if they're valid inputs. We then just traverse the tree. We then make sure x and y are present. They're not outside of the tree. Then we just check if their depths are same and their parents.
Why would this case ever happen?
Okay, then we can. I mean, sure, we can get rid of that.
Because like right here catches that, right? If
x is null pointer. Oh no, it just checks if x and y are just null. You passed in an invalid, like it was just not a null.
Yeah, but we could assume x and y are in the tree.
Okay. So yeah, so we can get rid of that. Okay. That's it. Okay, let's try. Let's just try a test case. We can do this one that you shared.
Wait, let's see. The traverse tree. Can you walk me through the traverse tree function?
Okay, let's do a dry run then.
You don't need to I don't want to write the tree.
Okay, so for the traverse tree, you're passing in the node, the input node, which is in this case the root of the tree, passing in the current depth and the depth. So if the current node is null, we just return, and then we record the depth of that node. And I guess another question I had is, can the nodes have duplicate values?
No, they can't have duplicate.
So all the nodes in the tree, so there cannot be multiple nodes in the tree with value 2, correct?
Yeah, let's see. Oh, we deleted the prompt? Yeah, all nodes are unique.
Okay, all nodes. Okay, then that's fine. So then here in the depth map for that node, and we're just like the node with that value, we just assign its depth, and then we configure the parent map, and then we just keep going down. We just use DFS to traverse the whole tree here, and configure the depth map and the parent map. So we will configure. So let's just say, do you have the board open on the
Yeah.
like?
Wait,
We will.
I'm just looking at it just now.
I guess we wouldn't need this if check if we're doing an if check here.
Yeah.
We don't need this. We don't. This is redundant. So we'll just configure its depth, and then it will configure the parent map for its child. And then we'll just go and see the child.
Okay.
Do you want to do a dry run so it's clear? Like how do you want to do it?
I think it makes sense. I'm just gonna let's move on to the next question. Let me pull it up.
Yeah, I need to. I think one thing it's not on LeetCode you don't get to practice is like importing the correct library. Like how do you write the struct definitions and like the constructors, those sorts of things. Tree ones are straightforward. The ones that I get one shot at are like, man, this is like a math question or like like the kind of questions that Paul likes to ask you. Like I'm like, dude, like, kind of please ask me like a graph question or at worst a DP question.
Yeah.
Or some string manipulation related. Like at least I can I can feel smart. I can feel good about myself.
Okay, we're gonna get into the second question.
Okay. Well, that's gonna be a hard one. All right, let's. Oh, okay, man. Long prompt. Long. All right, let's see.
Wait, let me just configure it. Like, just make sure that it's formatted correctly. So we're implementing an underground railway system, and we're gonna be implementing a few functions here.
Okay.
Here, this is the time. Holy, okay, wait. So we're implementing three functions. We're implementing void check-in, a void checkout, and a get average time. So what we're doing is, it's an underground railway system. And we just need to keep track of how many times it's taking customers to travel between the different stations.
Got it.
So they'll check in at one point. That's where they're checking in. And they're going to check in at a certain time T. And they're going to check out later.
They're going to check out later.
Yeah. And then we just need to keep track of, like, what's the average time between two stations. We're going to, like, ask that question after. We're going to do a bunch of check-ins and check-outs. And then at some point, we're going to calculate once we have enough data, we're going to calculate the average time it takes between two stations. And we could assume that there's at least been one trip that did that route.
Got it. Okay. Let's see. So this is okay. So check in, the customer checks in. Check out, the customer checks out from the station. And here, let's see, returns the average time from the start station and station. Okay. The average time is computed from all previous traveling times from start station to end station that happened directly, meaning a check-in at station followed by a checkout. Okay. Time it takes the average time may be different from time to time. Takes to travel from end station to start station. Oh, okay. So start station to end station is a different trip from end stations. Okay, there will be at least one customer that has traveled from start station to end station before get average time is called. You may assume all calls to check-in and check-out methods are consistent. If a customer checks in at time T1 and then checks out at time T2, then T1, all events happen in chronological order. Okay. Understood. Okay. Some questions for checking here. There can be an edge case where, like, what happens? Like, what happens if like customer checks in at station A, and then they try check in again at station A or B or C or whatever. Like, what do we do? Do we just like throw an error, like do nothing, like throw an error or something?
Take a read at the different functions. Like you'll see.
Check.
Like you're wondering what happens if they check in?
Like no. They check in at station. Like I'm talking about a customer can only be checked into one place at a time.
Yeah.
I'm just saying if they're already checked in and they didn't check out, because checks in at station A and does not check out, and tries to check in again.
Yeah, yeah. So what's like basically that's what line 11 is saying.
Line 11. Okay, so we can assume that this case will never happen here.
Yeah, that's line 11, right? It says
Okay.
Yeah,
Okay.
Customer can only be checked in at into one place at a time.
No, I guess the question I'm asking is, do we want to write code to handle that case? Like that's like their requirement. Do we, in this thing that we're building, do we want to handle that case that if they try to check in, or are we just going to assume that this case will never happen and we don't have to write the code?
We could assume this is telling us what's gonna actually happen. So a customer with a card ID checks in. Customer can only be checked into one. I guess we could assume that the input is valid.
Okay, got it.
Right here, right line 30.
Okay, got it. Okay, fine. Okay, then we don't have to worry about that. Okay, then we can check out. Okay, so let's see how we will store. So we can store this. We need to like have a struct to store information about. This would be like string of like station name. Like let's just say a trip, like a trip, a struct trip. We would have a, and this would have a start name. This string would be start station, like start station. We could have a string end station, and we could also store an int start time, int end time, and then yeah, we can then store, because we know that a customer can only be checked in at once, so we can store the ID of the customer. So int ID will just be the customer ID, and so this can be the trip for a given station. Now, what we now need to do is associate. So if you look at our function check in, check out, they receive like both the ID, the station name, and the time. So we can also store a map where we can where the key is. So this can be unordered map of int and a trip where we can associate customer ID with the trip. So the key is the customer ID. Here the key is the customer ID, and the value is the trip. And this will just contain a map of all active trips that we can find for that given customer. And then what will happen is if we do a check-in for ID and then the station name and the time, then what we can do is we can make a new trip. We can make a new trip where we have the start station can become the start name. ID, we'll have the start time, and then we can just set the end time to some -1, and the station to like -1, and so we can put that in the active trips map. And once the customer does a checkout, that'll be ID, station name, and we will also have an end time. Now we will then again look up for this object in that map. So now trip, we already have this information. We'll just update the end time t, like end time, and then we would just have the end station. And now we will, have, and we can then also remove this trip from that structs map, from that all active trips map. And so now all we need to do is now we have to compute the average time between the start station and the end station. What we can probably do is we can also have another map, unordered map, and I think, okay, so unordered map of average times. Unordered map, this should be string, and let's just like have a pair. So here the key would be the key. We can create our own key, like this can be like something like, start station, end station. Like we can create our own string. So something like this, that can become our key. And for the val, it can just be a pair where the first val is the total time, and then the end val is the second val is the total trips. And so because then once we store this, because whenever you would call get average time, and this would be what's this, get average time, start station, end station. So this would be start station, end station. What we can then do is just like let's just say times, let's call this times map. What we can do is just like we'll do times, and we'll just like look for that key. We would have start station, end station. We will look for that key. We will get the pair, and then we can all we need to then return is pair pair dot first, pair dot second, and that'll just be that'll return the average time. Now all we need to do is just configure this map when this trip. So we also have to populate this map. So when we do this checkout,
the solution makes sense. I'll just go ahead and implement it at this point. Like iron out the stuff like when you are implementing it.
Understood. Okay, let's do struct trip. This should be okay. Copy. Okay, so we have the start. Okay, we have our trip struct, and I think that's it. The class. No, this we're probably gonna implement a class. There should be underground class system, and I'm gonna Google. I need to. So
you
like
can ask the AI assist right here.
Yeah. I actually this is the part I need to work on. Is like what are the import libraries? What are the like?
Can you ask the AI chat here in the AI assist tab?
Where there's an AI assist tab on here
Go to chat.
Oh, they added this. Can you get to use these in actual interviews, or they don't allow you to?
Depends. Like, so I've seen some they started doing that.
Well, I mean, that's actually very neat. How do I create a class in? And I guess this way the interviewer can also see what I'm asking for.
Yeah, I want to understand how good you are with the AI.
Oh, okay. That's actually like okay, yes, because all I need to know is just like how do I create a new class? Okay. Honestly, I just wanted to okay, and then you have the public, and then here would be an unordered map of string and a pair of int. This would be trip times, or we're gonna call this trip times, and we have to import unordered map. Okay. And then unordered map would be int, then a trip. This should be active trips. Okay. So we have these two things we're gonna store, and then hold up. And now we have to implement our functions. Void check in, void check out, and then int what's the average get average time. We can make this a float. Average time, and so here it would be for the average time start station, end station. Okay. And then we return something here, and for check-in we have ID, station name, and tea time. Okay. And ID, string station name, and int time, and ID string station name, int time. Okay. So here all we have to do is create new trip.
Odds are there in the
New trip dot new trip dot ID, and new trip dot start station name would be station name, and new trip dot start time, the time, and then new trip dot end station, new trip dot end time. So we have this, and then what we can do trip time, active trips for the ID. We can assign it the new trip. Okay. Now we have to do the checkout. So now let's assuming that there will be like we can do, if active trips dot count ID, like this would check if there is no active trip, but we can assume that this will never happen. Like this checks if no active trip. But assuming that we have a trip, we can do we can get the current trip. Current trip would be active trips, and we fetch from our map. We can then,
like, you keep forgetting the over here. We could assume all checks are correct, right? In line 30.
Okay. Sounds good. Okay, we can then remove that. Perfect. We don't have to assign.
It's good. It's good to be also.
Yeah.
Like cover everything, but if it explicitly says, I would try not wasting any time on it.
Yeah, sounds good. Okay, so end time. We don't have to assign this, but we can do current trip dot end station name. That would be, and then we can remove it active trips dot erase. This would just remove that trip from the active trips map, and now here we have to configure our trip times. like configure trip times map.
So why do we need to erase?
Because we're done with that trip. It's no longer an active trip because we checked out.
But next
Now
time, will it just replace it or no?
the next yeah. So erase means erase it from the map.
Mm-hmm.
There's no longer an active trip, so this will just delete that entry from the map. So now we can create a new string trip, like trip key. We can just do current trip dot start station, current trip dot end station. So this just becomes, we can just create a trip with like something in the middle, like 3 dashes. We can create that key. And now first we can check if there is an existing entry for these two stations. So we can check if trip times dot count trip key. So this will check if there's no key over there. So we will have to create a new key. And so then we would do current trip times our trip key. We would just assign it a new pair where the first value is the total time. So this would be current trip end time, current trip start time, and then the second would be the number of trips. So 1 trip.
Yeah.
And now we can just get the current data. So this would become an int pair current data, which should become trip times trip key, and then current data dot first would just be plus equal. We would just update so the first value will contain the total times. So current trip end time, current trip start time, and current data dot second plus we can just plus and then we could we can then we can just then set it to current data, and we would have to put it. We can like combine these two because they're very similar. We don't have to, but let's implement this function first. So now we can just construct our trip key, and we can just get our current data. This should be trip times dot trip key. And then all we do is current data dot first divided by current data dot second. Division using possible. Okay, it's fine. Can we return a float 64 or double? Oh, I think double is a type. But then we can return. This will return the average time. Let's
run it on some cases.
I want to see if we can first plus. Oh yeah. We actually we can actually combine this thing. So all we have to do is trip times dot trip key dot first plus equals to current trip dot end time minus current trip dot start time, and trip times dot trip key dot second plus because it will initialize all the values by 0 by default, so we can get rid of this. Okay.
It does?
Yeah. So in the map, like if you have some like for pair, since we have specified int by default, it will set to 0. I hope it does, or it'll be very embarrassing.
Okay, let's run it on a few cases. We only have a couple minutes left.
Okay, got it. Let's create okay, let's create a class. Check in. Let's just say check in ID 0. Let's just say actually let's just say SF. Time 10.
Sir.
Check out at Santa Clara. San Francisco, Santa Clara, and then let's also let's just say both of us checked in from San Francisco. At time 10 and then let's just say you get off at Menlo Park. My work's in Santa Clara. I think Menlo Park comes first. Okay, so this should configure these two things. Let's just also have like some random values of like 3, 4, and then check out 3, 4. Let's just set this to 30, 40, 80, 100.
So what is this for? 3. So somebody else going to San Francisco to Menlo, and somebody else going to
Santa Clara. Yeah. And now we have checked out. So now I think all we should do is average time. So this should be double average. So this should be sys got so let's just do, so we had 2 people. So from the first trip was from 10 to 20. So this should be 10. The time taken for this was 10, and then the time for the next one was 70. So 70 plus 10, 80. Total trips are 2, so this should be 2. Average time from SF to Santa Clara. This should be true. And then let's from SF to Menlo Park. So here the first trip was 5. So this would be 5 minutes. The second trip was 45. So 50. And 50 divided by 2 should be, so wait, 5. SF 15. So
divided by 2.
Yeah, 50. Wait, I want to write it down so I don't forget it. 45. Okay, so 45 plus 5, 50. 50 divided by 2 should be 20.
Just write it down here, just to make sure you don't forget, right?
Yeah. No, I'm actually writing that in the log line.
Oh, okay.
Yeah, so 10 plus 70, 80, 40. Okay. Got it. Okay.
What is this, average time? You're only calling average time once.
Oh yeah, you're right.
Why not just go like this? Does that not work?
No, that should, yeah, that should work. Looks like it's not correct. Hold up.
Okay, San Francisco to Menlo Park. The first one is 5 minutes, right? What is the next one? 55 minutes?
50. Menlo Park. Oh, it's 55. Oh, okay.
So 60 divided by, there's 2 trips equals 30.
Oh,
So you
30.
get the right result. Yeah. Yeah. And the last one, San Francisco to Santa Clara. The first one takes 10 minutes.
Oh, I just did I do
San
it wrong?
Francisco, the other one takes 60. Equals 70 divided by 2 trips equals 35 average.
35?
Yeah.
Oh wait. Oh, did I do the math wrong? Oh,
I think so.
so wait, okay. I'm confused if my code was right or did my math was wrong.
You messed up your code. Or you
Okay.
messed up your math, but your code is
Okay.
right.
Okay.
Yeah. Cool. We'll end that
Okay.
here.
Dude, I was like, wait, was my code wrong or was my math wrong? I was
No, it's
like,
the
I
math.
wish my math is wrong.
Cool. All right.
All right.
How was that? What do you think? How are you feeling?
It was fine. I think I was able to get through both questions. I wouldn't say I struggled.
Yeah.
With like these are like if this was an actual interview, I would pass definitely. I think the questions I think well at least I have some feedback from this. I need to like work on like how do you like define structs in C++? How do you like create classes? How do you define the constructor methods? How do you like which libraries to import? Because I had no clue.
Yeah.
Even like Python, you don't need to do that. Like you just like, and so I think that was yeah. And then I think I did a mock interview earlier today. Like the guy asked me combinatorics questions, I was just like blank, so I have to practice those. But
Yeah.
really good practice. It's good practice, I think.
Nice.
I think with yep. All right. Well,
Thanks,
good session.
Shabaj. Good stuff. Yeah, no real feedback. You solved this stuff. It works. Thanks for coming out.
All right.
See you
All right.
again.
Talk to you later.
Peace.
Bye.
Good luck. Good luck with all your stuff. Peace. Two more people. Yo, this guy's crazy, Shabaj. You're tweaking. I'm gonna have to find you and give that back. This guy's crazy. Yo. Shabaj, appreciate you, bro. That's wild. That's the biggest donation. Bro, this guy's a legend. Shabaj, appreciate you, man. Thanks for hopping on. This guy's crazy. Okay, who's next right now? Oh, Shabaj, man. You wildin'. I'm gonna have to find you and get you some drinks to make up for that. This guy's crazy. No way. Take a pic of that. I'm gonna have to post that. Shabaj, man, appreciate you. Everyone go follow him. He has his own YouTube channel too. That's a massive, massive donation. Let me hit the, I might have to hit the air horn for that. This guy's wilding, bro. Yo, Shabaj, man. Shabaj with the $100 donation. Let's go. It's actually crazy. 100 is a lot, man. 100 is a lot. Appreciate you. We have somebody, I don't know if they know show. Let me message them. Wait, I'll be right back. I'm gonna use the restroom real quick. Give me a sec. We back. Shabaj is a legend. Appreciate you. Crazy big donation. You paid 160. You did it on coding interview IO. Was it good? Was it any good? It's good? Nice. I've never tried it. The guy that did a mock was a staff eng at Google. That's crazy. Yeah, like, what kind of feedback did they give? They're probably just trying to help out with the community. Maybe, I have no idea. But $160 is not light to anyone. You know what I mean? Like, you do a few of those interviews. Then that's like your dinner. Like, you do 5 of those a week, and you get free dinner every week, essentially. Yeah. Wait, just gotta reply to some people. Let me ask Richie if he's ready right away. Yeah, for sure. Yo, I'm so cooked. Wait, let me grab something. How long has this stream been now? 8 hours? About to be 9? That's insane. That's a full shift. My longest, I've done like I did a literally 24-hour stream, but then it didn't post. I did the blind 75 go list in one go, and I was kind of trash a year ago, so I couldn't solve it in time. And I was like doing it with friends and stuff, so it was taking a bit. Cyclops was good. It was deadly. Alright, what's going on now? Did the contest finish? Maybe we could kill some time with the contest. Or let me ask this next guy, Richie, if he's on. Yo, you got this, Cyclops. Gusto's a sick company. Yeah, someone no-showed, so it's all good. They just finished 454. Let's just work through this question. Alright, weekly contest 454. Oh, you're ready? You're ready? Okay, let's hop in. Are you ready now? I think the other guy no-showed, so. He's just not replying or he's not in the thing, but so we can move him around, but okay, hop in, Richie. Or we'll call you Hylam. Hylam, hop in the Google Cal. Let's get it. Hylam, what's up?
Oh, hello.
Nice. So we got someone joining in all the way from Australia. It's crazy. What's up?
Yeah, what's up? Not too bad. How are you?
I'm pretty good. How'd you like get at, or how did you come across my channel?
I've been like a lurker for a bit. So you just came up on my For You page when I started prepping for interviews.
Nice.
Like about a month ago. Yeah.
Cool. So, yeah, you're based in Australia, you said?
Yeah, I'm in Melbourne.
Nice. So, what's kind of like the algorithm or LeetCode culture out there? Is it kind of the same thing as here in the US?
I'd say not as much. Obviously, with like big tech stuff, there's still the American LeetCode culture, but for companies that aren't big tech, generally you get given like take-home assignments, I'd say, or they focus on behavioral. So
Okay. What kind of companies do you get to work in over there? Like, what are the options?
I guess here the probably bigger ones are the banks and just a lot of random other small companies. No, it's not tech isn't that big here.
Not as big.
Yeah.
What's like what do people get into if they're like what are the different careers that makes good amount of like you make a good living out there in Australia?
Probably quant and big tech's probably the big
Quant is
ones
still
there.
in big tech. Okay.
Yeah.
Or like in
yeah.
general, like if I wanted to have a good life, make a good living, it's like
Yeah, to be honest,
go ahead.
tradies honestly have it really well here. If you know what a tradie is, I don't know if that's like
what's a tradie?
Slang.
The slang.
Tradie is like electricians, your
Oh.
electricians, your plumbers, your builders. It's like a really big course here in Australia. And when you're in high school, you can either choose to go to be a tradie or you can choose to go to uni.
I see.
And most of the time, a good population are just tradies, and they make a really decent amount, average like 100K here.
Wow.
So, yeah.
How much is like an apartment?
Oh, well, I'm only 20, so I haven't looked into that much still with my parents. But I'd say depending on where you are, Sydney and Melbourne, it's pretty bad. We're in like a high housing crisis, but
I see.
Yeah, I wouldn't be able to know. I think the average house there is like $1 million something.
Average house is like $1 million. Or for you never looked at rent prices. So pretend I wanted to rent a 1-bedroom or 2-bedroom apartment.
If you wanted to rent in Australian dollars, it would be on average like 300 to 600, I'd say, that range a week,
To rent?
because we do it by week. So
Okay, so yeah, around like 1,200 to over 2,000 a month kind of thing.
yeah.
Well, you do it by week. So what happens if someone doesn't pay for the week? Do they get kicked out?
Well, it's usually up to the landlord to sort some stuff out there, but yeah, it's usually by week.
Wow,
You
that's
can probably
interesting.
evict them if they're late, but yeah.
What's sort of like the salaries for you expect to graduate from? Like when you graduate, how much would be a good amount for you, or like the minimum for computer science? I'm just trying to get a gauge of the difference between working in Australia versus US.
Yeah. I'd say a good amount is like the average salary here for people straight out of comp sci is like 80K. I'd say around 60 to 80. Obviously, there's the upper bounds of all the big tech stuff, which is like 100, close to like 110, 120. Generally, if you're at 80K, 70K a year, you can still live by yourself. Obviously, you'll have some limitations in your lifestyle, but yeah, it's pretty livable for around that range.
I see. Okay, so why are you doing LeetCode then? Are you trying to like get into those big tech companies?
Yeah, pretty much.
Like
Yeah.
Amazon, Meta, Google, they all have Australia offices that you can work at. You can apply for.
Yeah, most of them are in Sydney.
Wow.
So yeah, Sydney's like the tech area of Australia.
Yeah.
Most of the stuff are there.
Yeah. So how many LeetCode questions have you solved?
I started about 3 months ago, so I solved around 400, I think.
Wow. Okay, so you're really good, huh? Or you done a
No,
lot?
I don't think so. But
All
for the
right.
quantity of done, I don't know.
Yeah, I can't go easy. Like if you're warmed up, you already did 400 in the last 3 months. You're gonna be.
Yeah.
What language do you want to code in? Let's just get started on this then.
I prefer Python. That's how I've been doing it.
Cool. All right, I sent you the coder pad.
Oh, sweet. All right. Can you see my thing?
Yep, I can see you in there. Let me just pick a question for you real quick.
Sure.
This question. You've done all the classic questions?
Yeah, I've gone through the Blind 75. Haven't done all the LeetCode 150, but yeah.
Okay, I got some questions. Okay, we'll do 1 to 2 questions depending on how fast you're able to solve these questions.
Sure.
So this is the first question. Oops, hold on. So we're gonna be given n cities. So we're gonna be given n cities. Some are connected while some are not. If a city is connected directly with a city B and city B is connected directly with city C, then city A is connected indirectly with city C. It's like that's transitivity. Okay. So a province is a group of directly or indirectly connected cities and no other cities outside of that group. We're going to be given a matrix called is connected that tells us which cities are connected. And we just need to return the total number of provinces given that input. So I'll give the first example.
Yeah.
So this is what we're given. So what we're saying, city 1 is connected to, wait, how is this input? City ij, wait, you're given an n by n where ij equals 1 if the ith city and jth city are directly connected. Okay, so we're given an n by n where n is the number of cities, right?
Yeah.
So pretty much, so this is gonna be, pretend this is city 0, this is city 1, this is city 2. 0, 1, city 2. So this is the input. So this is, so when we're saying, when we have 1 here, that means 0 is connected to, city 0 is connected to city 1. Does that make sense?
Mm-hmm. Yeah, it makes sense.
Yeah, I'll just let you go ahead from there then.
Okay. So this, I guess the first thing that comes to mind when I see this transitivity condition is probably a disjoint set, where we basically just create a normal DSU where we can pretty much iterate over the cities in the matrix, and if they're connected, we can just unionize them here. And then when we do that in our DSU, we can keep track of how many sets there are. So anytime we unionize, we can minus, I guess, the number of, like, starting from the size of how many cities there are. When we unionize, we can, I guess, -1 because we're combining it. Before I go more into this, I try to think if there's any edge cases. So in the constraints, is it possible that there's like an empty input, or it's just like just this?
That is possible. I mean, actually no, let's just assume n is greater than 0.
N is greater than 0. Okay, sure. But yeah, we can just use a normal disjoint set union. Does that sort of make sense, or did you want me to explain a bit more? Or?
And then what? How, at the end we just print out, like what? Like how do we know what the result is at the end?
Yeah, so in the DSU, we initialize it with like the size of n. But anytime we call union, then in the DSU, if the two cities that we're trying to unionize are in the same cities, we would pretty much just do nothing. But if two cities are in two different sets, we want to, I guess, to decrease the total by 1. The total number of provinces, I guess.
Yeah, it makes sense. Yeah, you can go ahead and implement.
Sure. God, how do I? So for a DSU, I'll do 2 optimizations called path compression, and I think it's called union by rank or join by rank. Basically, it makes our 2 functions that we have. We have our define. We have our, what's it called? Define function for I. And we have to define our union function, I and j. So using the 2 optimizations, it makes these of log n, which I'll explain it after I do them. But
sure.
Yeah, so for the DSU, we're going to need a parent array to show the parents that we have. And we're actually going to initialize it to be the city is the parent of itself for initialization. And then we'll do self.rank. The rank, I think we do 1 times n, because the rank will be referring to the number of, the depth of the, I guess, tree within this DSU for each parent.
Sure.
And then is there anything else we need to do? Don't think so. So for our find, let's go, we get a node. So node is equal to the parent. We'll basically just check. We'll get the parent of whatever node we're given. And we'll also do a quick check. If the node is equal to self.parent of node, we have reached the root node in the tree. So in our tree, we can just simply return the node. If not, then we will flatten, or I guess path compress this. So for this I, we're going to make it self.find of node. So here's where we have the path compression. So that way we're flattening the intermediary nodes every time we go from, I don't know, the bottom of a tree all the way to the top. Then we can return self.parent of I. Hopefully this one works. And then for the union, we can get the roots of our two nodes that we're trying to unionize. So we can just simply call find I and self.find j. And then we can just check if I root is equal to j root. What happens here is they are already in the same province. So no need to unionize.
Mm.
Then we can just simply return false. Oh, we don't actually need to return anything, to be honest. So after this, we're going to go with our ranks. So if self.rank of I root is less than self.rank of j root, here it means that the j has a larger depth to it, or the j tree. So we should make self.parent of, I believe, I root to be j root, because we want to minimize the total length of the tree that we're making. So we want to take the bigger one, and we will want to move this, I guess, left subtree to be the parent of this right subtree. And then here for this one, we can pretty much just reverse this. J root is equal to I root. And then for the final one, if they're both equal to the same, then we can just do we can add the left subtree to the right subtree at any time. But the thing we need to keep track of is when we add to this I root, we need to update the rank, because we're adding one more level of subtree. So we do this. And then the very last thing we should do is to keep track of how many provinces there are. We can keep track of it up here, where we have the self.provinces.
Mm-hmm.
And we can just initialize it to n, which is the number of cities there currently is. And then when we reach here and we're unionized, we can safely decrease it by 1, because we've combined 2, I guess, trees together.
Yep.
So after we do this, if we go with our solution and then we have our adjacency matrix, I guess all we need to do is create our disjoint set. So here, we need to know the number of cities. N is equal to number. Is n given as an input?
Well, the array is n by n, so we can infer
okay.
from.
Yeah. Sweet. So we can just do this, initialize our disjoint set. And then after this, we're going to iterate through our adjacency matrix range of n. What we're going to do is we can do a quick, I actually don't think we need to do that, but we can just do if adjacency matrix of I and j, if it was equal to 1, it's connected. So if it's equal to 1, then we should try to unionize it. INJ. And then we can just return DSU.provinces. I believe this might work. I guess the best way to do this is probably a dry run just to check.
Yeah.
But for the dry run, let's just do here. Ready? So we're gonna have our parent, and then we're gonna have our rank. Doesn't matter. So parent will be this.
I think for this case, since I have another one I want to ask, let's just run it on some of these test cases. So example 1, run it on this. Output should be 2. Example 2 should be like this. If those pass, we should be good.
Sure. So I can just go solution. I think. Oh, wait, it's a function. Okay, never mind. Let's call solution of, and we'll just take this in. Missing parameter. Oh, I don't need self. There we go. So here, let's see. Let's go with this. And this should be 3. This should be 2. Yes, just see if it runs. There'll probably be some syntax.
Not printing.
Oh, there we go.
Nice, nice. Yeah, looks good. Let's move on to the next question.
Sure.
Nice. Haven't seen anyone pull out the disjoint set yet, the union find yet.
Not gonna lie, I learned this yesterday.
Beautiful algorithm.
Yeah, it's really good.
Bye, boy. What's up? Chat say you cooked.
Oh, that's great. Thank you, chat.
All right. Next one. Okay, question 2. So we're given a ball in a maze with empty spaces represented by 0 and walls represented by 1. The ball can go through the empty spaces by rolling up, down, left, or right, but it won't stop rolling until it hits a wall. When the ball stops, it could choose any other direction. So let's hop in here. Kind of explain it here.
Okay.
So essentially, let's just pretend we have this maze that's kind of blocked in by walls. And then let's just do like a simple like this. Wait, let me see. 1, 2, 3, 4. Like we could assume that there's ones around it, causing it so your ball doesn't like go out of bounds, right?
Yeah.
There's gonna be like random walls in here. Walls, and we're gonna be given a ball, and we're gonna be given an exit. E. Just exit. We'll just go like this. Exit. This is the target, right?
Yep.
So we can start rolling the ball in any direction. Let's see. Yeah, essentially, we can start rolling the ball in any direction, right, up, down, left, or right. But once it starts rolling, it doesn't stop. We want to be able to figure out the minimum distance, like the shortest distance to actually get the ball to the X. So you could go like, you could roll all the way down here, then you could roll down here, then you could roll down here, then you could roll down here, then it could roll down here. That's the shortest. another more suboptimal path is it could have rolled down here, then here, then here, then here, but that's more suboptimal. You don't want to go the green path, so we just need to be able to like roll the ball and figure out. Yeah, does that make sense?
By shortest, is that shortest in terms of the number of squares traversed?
Yeah, exactly.
Like
The number of squares traversed.
Okay. Yeah, this sort of makes sense, I guess. Guess. Right. Oh, okay.
So I'll give you an example here.
Yeah. Oh, and we're given a start and destination.
Yeah, you're given a start and destination.
Okay.
So where's 0 and 4? 0, 1, 2, 3. 0, yeah. 0, 1, 2, 3, 4. So start is here, and end is 4, 4.
Yeah. Okay.
Yeah.
End
is here. End is here. So what's the shortest path? I mean, go down here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 12. Like it's easier if we. Yeah. I'll let you go ahead and read it. Actually, hope I explained it well.
No, you did. I think I get it. I guess. Yeah, the first thing comes to mind is just some backtracking, regular backtracking. Usually, that's mainly what these types of matrix problems are like. The only key difference for this is it doesn't stop rolling, but I guess we can just sort of emulate that. Yeah, for the backtracking, we can just have our like backtracking algorithm where we try out every possible path and we keep track of the number of squares, I guess, number of squares traveled.
Mm-hmm.
And we have like our base case where for the base cases, the first obvious base case is if we reach the exit, we can return E or update a global variable, either or. We can return number of squares. And yeah, after that, we could just go in I wouldn't say any direction, go in 3 directions because we wouldn't want to go back to a square we've already visited. So in terms of the backtracking aspect, we could keep track of a visited set because realistically, if I'm a ball and I'm traveling through this maze and I go back to a spot that I've already seen in my path, I don't want to go back to that spot. I'm obviously at the wrong path. So in this set, we could like add to our visited set of our current position. And in the go through in 3 directions, we would roll till we stop and call backtrack on this position once more. And then at the very end for the backtrack stuff, we remove the current position from the visited. So this seems like a bit of a brute forcey method, but I can't really think of any other way to do this.
It's like, okay, so if this is a like what's going to be the runtime of this algorithm if we do that?
The runtime, since we're going in 3 directions, it'd be 3 to the n, I'd say, because we're making 3 recursive calls.
Yeah. And the constraints of this question is like the size of the array could be is large. It's
yeah.
Like this would TLE essentially.
Yeah. For an optimized method, since we're finding shortest path, maybe Dijkstra's here. For Dijkstra's, we're going to need a graph. So in terms of how we can make a graph, the thing we could do is probably iterate through each cell possibly, and then create an edge from, say we're at 0, 0, we create an edge from 0, 0 to 2, 0, because that's where it stops, and an edge from 2, 0 to 0, 1. Basically, we can use that graph to call Dijkstra's on it. But I'm not sure. Does that sort of sound like a better optimized method?
Yeah, it seems like it's going in the right direction.
Okay.
Just the parts like converting to the graph kind of thing. Could you just explain why or how you do that?
Yeah, so basically Dijkstra's, well, for me, I know implementing Dijkstra, you need a graph to do any Dijkstras, but the edges will basically be the number of squares we traverse from this, from like 0, 0 to 2, 0, for example. That would be 3 squares, 3 or 2 squares. There's some off by 1 there, but one of the weights. So we have this sort of directed weighted graph, and then we can call it, we can go from our start position in our graph. We can perform Dijkstra's, and once we perform Dijkstra's, we can just get the distance, the minimum distance at our exit. And if it's infinite, we can just return -1 because it means it's impossible to reach there. And that also makes it, I guess, faster because we like instantly traverse from 0, 0 to 2, 0 or 2, 0 to 2, 2. But yeah, should I try to do it and see if I can get it? A bit unsure, but
Stream tweaked. Wait, give me a sec.
yeah.
Stream tweaked.
Oh.
Did the stream leave? One sec. Yo, chat, is the stream still good? Okay, perfect. Yeah, implementing, you need a graph. I'll just say one small thing is like we don't need to convert to a graph. It's already sort of in a graph structure. Okay.
Okay.
Yeah, the maze is already a graph.
Wouldn't we need to go? We need to like iterate through these 3 rows to know we can get to here. I guess that wouldn't be a problem. But okay.
So what are we storing in the priority queue, or like how are we performing this Dijkstra's algorithm?
So our priority queue, the state that it'll track is the number of squares, and then just I and J, and then we'll have our visited set of all the positions that we've already visited, and our distances, which is the distance times m like for this. So yeah, it's just the way we do Dijkstra's is anytime we reach, say we pop and we have num squares I and J, we would go through each direction that we can go in. So travel in each direction until we reach a wall. And the moment we reach a wall, we would just push this new position to the heap. And then we would also, we would check check if the distance at this new position is greater than the current distance that we're at. So number of squares plus squares traveled, I guess. So to emulate this traveling, we would have like another for loop to travel until we hit a wall.
Yep.
Okay. Sweet.
We check if the distance at position is greater than the number of squares plus squares traveled. What's that?
So if basically if the number of squares traveled is less than whatever the distance array is, then we will update distance and continue in.
Okay, what's distances?
Distances is the number of squares at to reach the position in the cell. So if that distance ij means starting from start, number of squares.
Okay, like how long? Okay, sounds good. Okay, yeah. Go ahead and implement that.
Okay. So define get min path distance. So we're given our matrix. I guess the first thing I'll do is just set up Dijkstra's. So let's set up the heap. And our heap, we will start here, matrix, and we have start and end. We'll have our heap, then we'll have our visited here. We could do a matrix, but this is less syntax to write, so I'll just do a set. And then we will have our distances. We'll be here. Let's get our lengths. Equal 0, length of matrix, and then length of 0 to make, again, the syntax cleaner. So for here, let's go float of infinite times m for this in range of n. And then let's redo our. So the start is given as a list. So distances of start 0, start 1 will be equal to 0. And for the heap, let's pass in the number of squares traveled and just the position. So let's go start 0, start 1. And then after this, we will need to construct our Dijkstra's. Let's make this P queue. So while we have our priority queue, let's pop. So let's go num traveled. I'll go squares, and then we'll have I and j is equal to heap q heap pop. I think I have to import heap q here. And then if, I guess, I, j is then visited, we'll continue because we don't want to revisit cells that we've already seen. And then for the directions, the directions is what's going to be a little hard. Directions here. And then here we will return distances of the end of 0, end of 1. If this doesn't equal float of infinite, else -1 because it's impossible. So this distance thing is going to be probably the tricky part here. Let's maybe create a directions array to make it easier on myself. There. So we need to travel up, down, left, or right. So for direction I, direction J. In directions, we will need to do new I, new J is equal to I plus di and J plus dj. So we need to move forward. Probably a while 0 is less than equal to ni, it's less than n, and 0 is less than equal to nj is less than m, and and matrix of I, we're going here, new j, while it's equal to 0, so while it's an empty space, we will continue going in. And then we will go ni equals plus equals di equals dj. So we'll continue going in the direction that we want to go in. So here we stop at boundaries for the walls on the top, bottom, left, and right. And here we keep track of obstacles so we don't go into those obstacles. Yeah, we've reached the end. So when we reach the end, the edge case I want to, I guess, keep track of is, say we're at ij, and to the left there is a wall. We will be immediately going into that wall, so we would automatically get out of this while loop. So probably the first thing I want to check is...
Chat's asking how many questions you've solved, by the way.
Oh, I've solved 400. Okay, so I started, 3 months ago.
Yeah.
Matrix of ni and j. If this is equal to a... Yeah, we'll have this. We're at a boundary here. If we reach this boundary, I just want to make sure I keep track of that. The actual place that we can be at, so the position, new position, will be ni minus di, j minus dj, because we will exit at the wall. Well, and when we reach a wall, that's when it'll exit. So we need to minus by whatever direction we've traveled in. So I don't even need this.
One small thing, let's just count it or something. Count it 0. While we're rolling it, just count it. I don't want to verify the math there, just in case that ends up. I think yours makes sense, but yeah, just go.
Yeah. You're right. I didn't think of that. So here we'll go if new pos. I guess we can just go di and j minus equal dj. If ni is equal to I and nj is equal to j, we haven't moved at all. So we will continue. We will ignore this. So now we have moved to a position. So let's go here, and then we will push in the... Oh, we need to check one thing. If the distance of ni and nj, if this is greater than square... Here I go. Total distance traveled will be squares plus count. If this is greater, then we'll make this equal this, and then we will push it in here. So this is a lot of code. It's going to be hard debugging, but maybe the best thing to do is maybe just run it and see how it goes. I feel like a dry run would be a bit too much.
Yeah.
So for here, we can do this. We have this and 0, 0.
I'll just post this in there. I mean, you have the same thing, I think, but just gotta make sure. I just posted this shit out the LeetCode.
Sure.
So this should output 12.
Okay. End is not defined. Let's see. Name of end. At line 102. End is defined, but Oh wait, no. Get path. Okay, let's go from the top. We go this, we set up a priority queue, we have our visited, the distances is initialized correctly. We make this set start to 0. We have our directions. Go through it, we'll pop, it's end visited. Oh, we also need to do this. I don't think that's the problem here. For this in directions, we have this. We go through each direction, and INJ, we keep going. And we minus this. And then if we haven't moved, we continue. So we ignore it. Our total distance. Turn distances of the end. Why is this? Oh, okay. So it should be 12 and it's getting 5. Something 0. About count. Total distance is squares plus the count. Maybe I just check if the distances is being calculated correct at all. 2, 2, 0.
Okay, wait, can you just walk me through line by line, starting from the top? Just walk through and just make sure everything's good. Yeah.
So we go initialize our variables, initialize the priority queue to be of 0, start 0, start 1, the INJ. Visited set we initialize to not go back to visited ones. Initialize our distances to be correct. Initialize that. For this directions, this is fine.
Sure.
I'll run the priority queue. Okay, so here we will get the smallest distance from our heap. In our squares, we'll make sure it's not unvisited. We'll add it. Then we'll go through each direction. Ni is equal to I plus Di, and J is J plus DJ. Have our count. While it's in boundaries and it is empty, we will continue traveling in the direction. Increment the count, and then we just go back by 1.
What's NI here? Wait, NI.
Oh, well, yeah. NI is the position that we're currently at.
Okay.
And then we minus it by
the
direction. Count minus equals 1. If NI is equal to I and NJ is equal to J, we haven't moved because we're right next to a wall. I think this seems fine here. Total distances is squares plus count. Maybe it's here.
Squares plus count.
And distances of ni and j to the total distance. Maybe this is what's wrong here, but
how would we debug this? What are you thinking?
yeah, it's a good question.
Okay. What if we just start from? Okay, we start from S. Let's just do one iteration and break out, and then see that the first iteration worked.
Sure. Same break here. Do one iteration. So what it should be is from the top right, it should be the left of the top right should be 1, and then on the bottom, so at 1 0 1 2 3 4 0 1 2 3. So at 4 3 it should also be 3. No, 4. It should be 3.
Okay. Or 2.
2? Oh
okay,
yeah,
right.
2.
2 and 1 after the first iteration.
Yeah.
In the distances. Okay.
0 and 1. Okay, so maybe this count. I decremented it, and maybe that's why. 1 and 2. Okay. Maybe get rid of the break. No, but
Nice. Just that simple one suddenly.
yeah.
Solid job. We're 50 minutes in, so probably gonna stop that there.
All good. Thank you so much.
Nice. How do you feel? How was that?
Yeah, it feels good. It was cool questions, definitely. The backtracking, I haven't done that for a bit, so it was interesting going through it. But yeah, really good questions.
No, this is a solid job. I think you solved this question the fastest out of the people I've asked this one. You went the backtracking way, but the moment I just said like what's the runtime, you kind of fix it up to a Daisha. So yeah, no real complaints there. Yeah, overall really good job. You are able to implement the code like it is in the textbook exactly. So I think you have really good fundamentals and are able to like figure out when to use what. So I think really good job. I'm pretty sure you could probably land most jobs if you got it. It's just more can you get the interview now kind of thing. But if you got the opportunity, I'd be confident in you. Good job.
Sweet. Thank you. Thank you so much.
All right, man. Thanks for joining. Have fun over there in Australia.
Yeah.
See ya. Nice. That's pretty solid. Let's see. One last person. And then we're going to stream again tomorrow. Gonna grind out one more question. Dude, my eyes are burning. But it's all G. Do you think LeetCode is still useful to learn now? I think so because it's still what gets you a job, right? The moment it doesn't get you a job no more, I'll say don't do it. But honestly, I think there are questions that are really good and help you learn. Yo, what's up? How you doing?
Good.
Nice. Let me see what you answered in the survey. It's late for you. You said you're in Florida, right?
Yeah, I'm in Florida.
Damn. Where in Florida?
I'm in Naples right now.
Oh, I don't know where that is. Is that near Miami?
Yeah, it's like across the. It's like on the other side of Florida.
I
Miami's
see.
on the
So it's like West Coast Florida kind of thing?
Yeah, it's like West Coast Florida.
Is it near like Lakeland or anything? Or whatever?
Yeah, it's kind of near Lakeland, kind of near like Tampa. It's like south of
Nice.
Tampa.
Cool. I'm gonna send you this link, but let's see. You go to University of Florida. Did y'all
Yeah.
just win the NCAA basketball? Or no?
Yeah, we won
Nice.
the
That's sick.
championship. Yeah.
Nice. Are you a fan? Like basketball fan?
No, I don't really watch it.
Let's see. So, okay, we'll just do a quick intro before we get into it. This person is
Okay.
from the University of Florida. They solved 365 questions. Yeah. So, what is it? What's like the culture of computer science, I guess, in the University of Florida? Is it a super tech-driven school, or a lot of people trying to get in tech, or yeah, like a lot of people grinding LeetCode, etc. Like, what is it like over there?
I think it's more of a like engineering school, or of like a medical school. So the computer science focus isn't that heavy there. You don't really see people grinding LeetCode that often, but yeah, some people do land like FAANG offers here though.
Yeah, for sure. It's like a top school, or like it's a really well-known school. But you're saying it's like not as much. It's not like a target school like Stanford kind of thing, or
Yeah.
where it's like everyone's going crazy on the tech stuff. Um, yeah. What kind of companies are you aiming for? How come you did so many questions?
I was aiming for like want to go for like Capital One or like one of the banks, but still not good enough for like the top tech companies like Amazon or like Meta. So I'm still working on that.
Damn, you solved so many questions though. I feel like you'll be decent. 365. Like,
Yeah.
what's the breakdown of how many questions you've done in easies, mediums, and hards?
I just went down the list of like the LeetCode 150 and I did all the easies first, and then after that I did all the mediums. And then I started working on the hards, and then usually after I get done with that I do the daily if it's not a hard.
Yeah. Bro, you're out here grinding. Respect. Honestly, a lot of people from the East Coast, especially like Florida area, I don't see like people grinding that many LeetCode questions. Usually it's from like people grinding that many LeetCode or like from New York or SF or like Texas. But yeah. How are you with the different data structures like arrays and strings? How are you with
I'm
that?
good, yeah. I'm good. With
What
those.
about trees and graphs? Are you able to do those questions
Yeah.
really well?
Yeah, I can do those.
All right. Okay, let me find you a good question.
All right. Most of the grinding was the previous summer. That's when I did most of my grinding.
Okay, I see.
I haven't done.
How are you
some.
with backtracking dynamic programming questions?
I can still do some, yeah.
Okay. Okay, we're gonna do 1 to 2 questions. It all depends on how you perform on the first one.
Okay.
You have access. I sent you inside of our meeting here. Oh, I didn't do it. Okay, join into our coder pad.
Okay. Let's see. Python 3 coder pad.
Just put like a random name or something.
All right, there we go. Now I'm in.
Sick. All right. So question 1. We want to validate binary tree nodes. So we're given n binary tree nodes numbered from 0 to n minus 1, where the node I has, we're pretty much, this is the input right here. I'll show you the input. We're going to be given n. Right? We're going to be given n, which is the number of nodes.
Mm-hmm.
And then we're going to be given 2 arrays, left child and right child. The index specifies like so index 0, so 1 and 2 are left child. The left child of 0 is 1, and the right child of 2, or of 0 is 2. So this is kind of, basically, this is the input. We're given left child and a right child. And yeah, the index of the left child, so the 0th index here is the left child of node 0. So the way to look at it is, for each index, if you look at the 0th index, 1 is its left child, 2 is its right child. -1 means it's null. So you could see that node 1 doesn't have a left and doesn't have a right child. Right? So this is like how the input is given to us. We want to return true if and only if all nodes in this input are they form exactly one binary tree. So we essentially just want to validate that it's a binary search tree. Like it's a valid binary search tree.
Okay, so from what I understand,
I'll delete this. Give me a sec. Yeah, easy. I can post the input in right there.
let's see. Okay. So for node 0, you said the left child is 1, and the right child is 2.
Yeah.
There's no number at the root then? It's just null at the root here.
0? Well, this is 0, this is 1, this is 2, this is 3. So we know that 0 has, left child of 1 and 2. What about 1? Sorry, can you hear me?
Yeah. So still kind of confused on how to draw the tree out here. So for 1, it's just null for both branches, left child and.
Yeah, no.
Okay.
No. What about 2?
And 2, we have a left child of 3 and a null right child, and for 3 we have both null. So we're supposed to validate if it's a binary search tree.
No, sorry, not binary search tree. Regular binary tree. So
Regular
is
binary.
this a binary tree?
Yeah.
What makes it a binary tree?
It has 2 branches, and it's not disconnected anywhere.
Mm-hmm. Okay, I'll give you another input right here.
Okay.
And this one is actually false. This is not a binary tree. So just draw it out, and see.
Wait.
Are you in this? Or?
Yeah, I'm in it.
Okay. Just like
Okay,
disappeared your
so-
thing. Oh, lagged.
Oh.
It just lagged for me.
Yeah, I'm trying to draw up the tree.
Yeah.
So we have a bunch of left child of 1 and a right child of 2, and for 2 we have. Does the index of the array like specify like the left child and right child of the?
Like, what's left child here? Left child, the 0th index, like basically the index is it's the node. So if we're at the 0th index, we're looking at the left child of 0. If we're at the 1 index, like you're doing it right. So
Yeah.
yeah.
So 1, it'd be like that here, and then 2 would be 3. Is it a problem that we have 2 3s here? Is that why it's false?
Well,
We have
okay,
2.
wait, go back. So it
Yeah.
says 3, right? So that means
Yeah.
it's pointing here.
Oh, okay.
So these are like when it says 3, it's pointing to the unique 3 node. Like every node is unique. There's not going to be 2 nodes that are 3.
Oh, okay. This is not a binary tree because we have two nodes pointing, 2 inputs here pointing to this 3 node. Okay. So what I'm thinking is maybe we do Kahn's algorithm. Count the integrity, amount of integrity. Count the number of integrity. Let's see.
Count the integrity.
So we treat this kind of like a graph problem where we can make like a adjacency list, maybe. And then we can count the integrity to figure out if we're having a cycle or multiple inputs for a node.
You got a bunch of notes? Do you like
Yeah.
reference? That's cool. Grinder. So you're thinking count the integrity?
Yeah. So for the nodes, we have 0, 1, 2, and 3. And then we have, for each of them, we have the left and the right child.
So why'd you say we want to use Kahn's algorithm?
For Kahn's algorithm, from what I remember, it's topological sort. And with that algorithm, we count the number of integrity that goes into each node. and then we pop it off when the degree is 0. But why would we use contact rule here?
Why would you use
I guess we just count the degree, and then if it's more than 1, it's false. If it's one, if each node is 1, then it's true. So do you think I should convert this into like a adjacency list? Do you think that would work?
Yeah, you could convert it into an adjacency list. What would be the point of that?
Would count like the integrate for each node, and like if it's more than 1, then it's not a binary tree. Like for the second example, we had a case where there was two arrows pointing into one node. So integrate would be 1 here, and then 1 here, and then this would be 2, and that'd be false.
That'd be false. That's not yeah. That makes sense because it has 2.
Yeah.
Right.
Mm-hmm.
So what are you gonna do? You're gonna just count the integrity of every single one and just make sure none go over 2.
Yeah. But would there be a case where that wouldn't work? Let me see.
Yeah, think about it.
If it points back to the root, it won't be a binary tree.
Mm-hmm. So all these have integrity 1. What are you thinking?
I'm still thinking about counting the n degree. There could be a case where it forms like 2 trees. Would I still return false in that case? Like if
Yeah, if there's 2 trees like 0 and a 1.
Yeah.
That's false.
Okay.
Good catch. I think you covered all the edge cases at this point.
Okay, so think cons would work then, because we're counting the number of things here. I kind of forgot. Let's make the adjacency list first. All right. Let's see. This is the node, and then left child, right child. Oh. Default dictionary of list, so we could store the left child and right child. Let's see, left child, right child. If it's not -1, if it's not null, if
But like what when we have the adjacency list, what do we do after that?
we count the we figure out which node is the root. I guess is 0 always going to be the root? Or like can like 1 be the root?
Anything
or something?
could be the root.
Anything could be the root.
Roots too if it's not.
We start with the node with the in degree of 0, and then we have like the in degree count for each node, and we use, I think it was like it's a queue, and then you subtract the neighbors of the current like node with the in degree of 0, and you keep running that until the algorithm until you run out of nodes.
Okay, why do we have to do it that way? I'm just trying to think of why do cons. So we're looking for the things with in degree of 0, and then what, we add them to the queue, and then what? Like, how do we know if it's actually like pretend we have 0, 1?
If it's
Here, let's just walk through it then.
Okay. We'll figure out like why. Oh, okay. I remember cons algorithm having to do with cycle detection. But what was it?
Oh, so you want to do cons in order to perform cycle detection?
Yeah.
Okay, how do we verify the case? Okay, you mentioned there's multiple cases, right? There's cases like disconnected. mentioned two pointing, two parents. You mentioned cycles. This is kind of breaks it. So you want to use Kahn's algorithm to capture the cycles.
Yeah.
Will Kahn's algorithm figure this out? The two parents.
The two parents. I guess if we start out with two nodes with in degree of 0, then that means we have two parents. Yeah.
If we start off with two in degree.
Two nodes with like in degree of 0, that means we have two parents because the root node has an in degree of 0 usually.
Mm-hmm.
So yeah. I guess we use that to figure that out. But I gotta figure out like how I could do cycle detection with Kahn's algorithm. Let's see. Let's see.
Okay, so Kahn's algorithm. Here, let me think. So I'll give you one small hint. Like maybe we don't need to use Kahn's.
Mm-hmm.
Right. Let's see. Go back to drawing. Like, why not? Can we do something simple, like just a regular depth first search?
Regular depth first search. To figure out if it's a valid tree. So I'm going to list out the cases when it's invalid. When we have first case is when we have.
Like, how do you detect a cycle with just a regular depth first search? Like, you could do that without Kahn's, I'm pretty sure.
Yeah, you can use like a visited set maybe.
Mm.
If you can, you just add it into the visited set. If it's already in the visited set, that means there's a cycle. And there's a case where. So cases when it's invalid. Let's see. So we have multiple roots.
Yep, you already know to check that.
Mm-hmm. And when there's a cycle, or when there's a node with multiple in degree more than 1, greater than 1, and if there's a cycle. So I think these are like all the cases where it's invalid. We can use
Like with a depth first search, can you check 2? Is that possible? Just a regular depth first search?
you'll have to figure out like where the root node is, and then you do the depth first search.
Mhm.
So we're gonna have to figure out where the root node is again. I think we'd use we count the integrate to figure that out.
Yeah. What is the in degree of a root node?
It's 0.
Yeah.
Okay. I think I get how to do it now. We just use this. So we'll figure out if there's multiple root nodes with counting the integrity, and then we will figure out if node has integrity greater than 1 by counting the integrity, and we'll figure out if there's a cycle using DFS, depth first search. Okay, so I guess we'll continue doing this. Let's see. It's not null, then we add it to the adjacency list. But wait, do we even need to do this? Just count the integrity.
Well, do we need to do that? Like, why don't we just find one root? Like, once we have a root, right?
Yeah.
Somebody said in the chat, it's been 10 hours. I went to my job and came back, and James is still streaming. Okay, once we find a root, right, and we perform a depth first search, when do we return true or when do we return false?
We return. So we have all these. These are like the preliminary checks. If it doesn't pass this, then it's false. And then we do the depth first search. If there's a cycle, then it's false. If there's not a cycle, then it's true. We have to check the top 2 first, though, before we do depth first search, because we have to make sure it's one root node. In degree. Okay.
Wait, can you say that again? Like how? Okay, we find a root. What I'm saying is like, we find a root, right? We do a depth first search. When do we return true and when do we return false again? Sorry, I kind of missed that.
We return false if there's a cycle, and we return true if there's not a cycle.
Return false.
We return false if the node's already in the visited set.
Okay, that's one of the checks, right?
Yeah.
But like also, one small is like, shouldn't we capture all the nodes when we after depth first search? We would have captured all the nodes. Otherwise, it's doesn't contain all the nodes. That way, you could avoid the multiple roots count thing.
Oh, I was thinking that we do the first 2 checks first, where we count the integrity, and then if there's like multiple integries, like an integrity greater than 1, we just return false automatically, even before we start the depth first search. So when we start the depth first search, we're guaranteed to only have one root node. I was thinking about doing that, like these 2 checks first. Checking if there's multiple roots and checking if there's a node with the integrity greater than
that would work.
1.
Yeah, that would work.
So yeah. So I'm implementing counting the integrity right now.
Yeah.
Counting the integrity. it's not null, that means it's pointing to that means okay. It's pointing to it's pointing to this one. So this does the nth degree. If it's not null, then we increment the nth degree of the node that it's pointing to. So that's left child. Yep. Right child. I'm pretty sure that works. And then we have our nth degree set here. That's the, let me test this real quick, make sure it works. Invalid
Invalid syntax. Where's that? Oh, because you have these comments right here.
Oh, okay. Oh, there it is.
Okay, 0.
Do we have a drawing of this graph right here?
I don't even know. You just made that one up, I'm pretty sure. Wait, let's see.
No, I was using your example.
Okay, validate binary tree.
Let's see.
We're using my example, -1.
Yeah.
Okay, that's gonna look like this. 0. 1. 2.
All right, so all right, let's look at the code real quick.
So 0 has an degree 0, 1 has an degree 1, 2 has an degree 1, 3 has an degree 1. That makes sense.
Yep. So that's working.
I'm gonna run it on a separate one.
All right, so we have to take account of these cases now when it's invalid. since we have the in degree count now. Oh.
Yeah, in degrees looks like it's working correctly.
All right, so if there's multiple roots, if there's multiple multiple nodes with in degree of 0, that means we have multiple roots. So we have to do another for loop to figure that out.
Sure.
For I in range. Oh, wait, in degree. Wait, no. Node in degree in. Oh, wait. Same name. Just gonna do count. Just return false immediately here. Int is not iterable. Oh, dot items. And node with the in degree greater than 1. Okay. Oh, wait, we could figure that out here as well. Count. Nope. Or count greater than 1. Just return false immediately. So we're guaranteed to only have one root node. So we run DFS on the one root node. I want to do another for loop, so I'll just figure out, like, I'll just store the root here. Wait. Number of, wait, it's the number of. Number of roots. It's number of roots.
So if the count equals 0.
The count is the in degree. If that's equal to 0, we increment the variable num roots by 1. And if the number of roots is greater than 1, or if the count, which is the in degree, is greater than 1, we return false. Take account of both these cases. I don't want to run another for loop, so I want to store the root node within this for loop. So just root. So we have the root now. Root.
Okay, let's walk through here. You got the roots for the num roots.
I got the root.
Okay. Let's assume that works. Let's implement the DFS.
Okay.
Looks like it's good.
So we have a visited set for cycle detection. So DFS root. Ah, I think we should have. I think I should have made the adjacency list because it's going to be hard to traverse, kind of. Hmm.
Well, like, we're given the left and right child. It almost acts as adjacency list already. What does adjacency list tell you? It tells you the left and right child, right?
Yeah, yeah.
So it's kind of like given to us already,
Oh,
kind
yeah.
of thing.
Okay, yeah. Okay. Thinking about if I should do it iteratively or recursively. So we have the root node. We do def first search now. We have the left child and the right child.
So how do you implement a depth first search usually?
With recursion, you have the root, and then you do DFS root dot left, DFS root dot right. From what I remember.
And then
you there's a base case here if it's.
Are you familiar with like how to do it iteratively?
Yeah, you use a stack.
Might be easier to do it iteratively here for this specific problem.
So we have the stack, we have the root here. While stack. Let's see. Node equals stack dot back. Left child node. Okay. Dot add node. If So if it's if it's in the visited set, we return false immediately. I think this is how you do depth first search iteratively, and then I think we covered all the cases here. We just return true at the outside.
Yeah. I think the one case would just be, we just need to we maybe visit equals n or something. Like the visit equals n.
Yeah.
Because we need to make sure with that DFS we visit all the nodes. But I guess yeah, with your thing, you kind of capture that maybe. So yeah. All right. I think we're pretty much at time because it's already been 50 minutes.
All right. Did it work, or does it actually check if it works? Oh.
Let me run it. Let me run it in LeetCode.
Okay. It's a LeetCode question?
Yeah. You thought I came up with this? That'd be genius. It's actually a pretty good question. You could build this in so many different ways. Like I could create so many variations off this.
Mm-hmm. We'll watch your pop up stream real quick.
Stack. Where's root? Root came out of thin air. Node.pop. What's node here? Right child. Node is none. It's breaking on some cases, but it might work on some.
All right. Well,
yeah, it's close enough. All right. Yeah, thanks for hopping on. Like, what do you think about the question? Or like how the interview went. What are your thoughts?
I was a little bit confused in the beginning. I thought it might have been contact rhythm, because I remember that having to do with cycle detection or like something with graphs, but I was going in the wrong direction in the beginning. I think I need to work on my communication. Like, as I'm working through the problem, I should like talk more about what I'm thinking about.
Yeah.
But what's your feedback?
I agree. I think definitely there's times when you just went complete silent, and you don't need to just constantly talk the whole interview, right? And just like there's some people who they think they just need to be talking the whole time. That's not the case. But you do need to talk when you're thinking about something important. Like when you're stuck or you're thinking about something, you just let me know what you're thinking about. So it's like, oh, right now, instead of just like when, for example, you're in this for loop, you're quiet for a lot. I instead of be like, okay, I'm in this for loop and I'm thinking about how to track multiple routes, or I'm thinking about. So you just figure out when to say stuff, and it's just a skill. Like usually over communication is not too bad. I never really met a case where somebody talked too much, but I have cases where people just talk too little. So I don't know where they're stuck. I don't know what they're thinking about. I don't know what they're trying to do. I could kind of see what they're trying to do, but they'll just go implement it. I think you weren't that bad at that, but you were definitely quiet a lot. And I think, yeah, other than that, yeah, I think just more practice, because you're able to figure out the algorithm, but even after that, it took a bit to implement. So yeah, it's honestly a hard question. A lot of people have failed this question already. So yeah, I don't know. Just more practice, I think. Definitely more communication. And just figuring out the best times to talk. Yeah. Other than that, I think you have good intuition on some of the stuff, like understanding what is a root, when to get the root. Like you understand the graph theory a little bit, and you're not completely blanked out. You understand it. It's just more of the implementation part where you took.
Yeah, appreciate the time.
Yeah. Good night, man. I know it's late for you.
Good night.
Peace. Holy! 10 hours and 47 minutes? That's crazy. Would you consider median of two-sorted arrays a trick question if you haven't seen similar? It's not really a trick question, but it is a question that's would probably not get asked in an interview. Honestly, I've never seen that question get asked. It's good to know if you're just trying to get better and better and better. But other than that, I doubt you'll see that in an interview. But anyways, thanks for hopping in. That was a crazy stream. We're gonna do this again tomorrow. Yeah, have a good night, everyone. It's 11 p.m. for me, so I'm gonna go chill out a bit and probably chop these up and post it. But thanks everyone for tuning in. I'll be streaming again tomorrow. I literally have 4 more interviews tomorrow. Let's see what the schedule is like tomorrow. Like, if you want to book time, just hit up this Google. Yeah, if you want to get a mock interview tomorrow, just hit up that. There's slots on Sunday and there's slots on Thursday, Juneteenth. So yeah, I have that day off. So we have 4 more slots, and then we have a bunch of slots then. We'll see how it goes. We'll see how I'm feeling. But definitely that June 19th, there's way too many slots. Everyone go book those up. And yeah, let's get better. We're gonna be grinding all summer vacation, gonna be like 4 days. Yeah. All right. See you tomorrow. Time to grind more. Gotta chop these up. Peace out.